Python's popularity has grown exponentially over the past few years. It is widely used as evidenced by high rankings in surveys such as the TIOB Index and the vast number of Python-based GitHub projects. Python is renowned for its simple programming syntax, code readability, and English-like commands that make programming a lot easier and more efficient. Python's large library system makes it a best choice for data science, machine learning, and artificial intelligence projects. Considering the job opportunities in Python, tech giants like Google, Meta, Bosch, and many others hire Python developers with handsome salaries, with salary in India starting from Rs 5.1 lakhs per annum and may get as high as Rs 10 lakhs per annum. Whereas the average base salary of Python developer in US is $105,000 and may get as high as $170,000 annually. If you are watching this video, I believe you are one of those aspiring persons dreaming to build a secured career with a strong fundamentals and a powerful portfolio to crack your dream job opportunity. We from Simplilearn bring you this complete Python full course. Here, we will cover the fundamentals of Python that includes the Python programming concepts like data types, variables, conditional statements, strings, operators, lists, tuples, dictionaries, and much more. Not just that, this full course will also dive into the most crucial programming paradigms that involve the advanced Python programming concepts, that is, the OOPS concept, exception handling, fine handling, sorting techniques, and much more. To make things more interesting, we are also covering the Spotify data analysis project and a lineup of interview question and answer that will help you get your dream job. Now, I have an insight for you guys. If you are aiming to get certified in Python programming and want to build a Python software development career, in that case, you can check the Python certification course by Simplilearn, which will open the doors for the best career opportunities. To find the details of this course, check the link in the description box below. So sit tight, you are going to learn with Simplilearn, and if you love these kinds of videos, then hit the subscribe button and press the bell icon to never miss the upcoming videos from us.
In this introduction to Python video, we will learn what is Python, the features of Python, and where Python is used. We will also look at the popular Python frameworks and libraries and get an idea about the best Python IDEs. Then, we will see the top companies using Python programming and get some hands-on experience by learning the basics of Python on a Jupyter notebook. So let's get started with what is Python. Python is a high-level object-oriented programming language developed by Guido van Rossum in 1989 and was first released in 1991. Python is often called a batteries-included language due to its comprehensive standard library. A fun fact about Python is that the name Python was actually taken from the popular BBC comedy show of that time, Monty Python's Flying Circus. Now, let's look at the top features of Python. First, Python has a simple structure and a clearly defined syntax. This allows the learners to pick up the language quickly, so it is easy to learn and use. Python can run on different operating systems such as Windows, Linux, and Mac, making it a portable language. It enables programmers to develop the software for several competing platforms by writing a program only once. Third, Python is freely available at the official website. Since it is open source, this means that source code is also available to the public. Now, Python uses an object-oriented approach that encapsulates code within objects. Python provides a collection of libraries for various tasks such as machine learning, web development, and data analysis. And finally, in Python, you don't need to assign the data type of the variable. When you assign some value to the variable, it automatically allocates the memory to the variable at runtime. Now, with that, let's move on to the uses of Python programming. So Python programming language is used to develop desktop applications and build web applications too. It is popularly used in the field of data science, machine learning, and artificial intelligence to analyze data, build predictive models, and make business decisions. Python is also widely used in game development. Now, let's see some of the popular Python frameworks and libraries. Python can be used for web development using frameworks like Django, Flask, Pyramid, and CherryPy. Now you can build graphical user interfaces using libraries and frameworks such as tkinter or just kinter. You can also use pygtk, pyqt, or pyjs or Python JavaScript. Now Python is also used to perform machine learning tasks using libraries such as TensorFlow, PyTorch, scikit-learn, matplotlib, and scipy. You can also perform mathematical computations using NumPy and pandas. Now let's look at the best IDEs that you can use to write programs in Python and perform specific tasks. So we have Jupyter Notebook, which is part of the Anaconda distribution that is widely used these days. Even for our demo in this video, we'll be using Jupyter Notebook. I'll show you in a while. Then we have the Visual Code Editor from Microsoft. This is also one of the preferred IDEs by learners and companies. Then we also have the popular text editor called Sublime Text Editor. Then we also have PyCharm, followed by Python IDLE and Spider as our top IDEs. Now let's look at the top companies that are using Python in our day-to-day work. So we have Google, Quora, Facebook, even Netflix, Spotify, and Instagram. Now there are other top product-based, service-based, and startups that also use Python programming.
So let's start. As you all know, Python is an interpreted language. So you need to install a Python interpreter. So for that, we'll go to the browser and search for python.org. Now we will move to the downloads page and choose the latest version of Python to download, and the latest version is Python 3.9.5. We'll click on the download. Once the installer has downloaded, open it. Now you can see the installation window for Python. You have to double check both the boxes, add Python 3.9 to path, and click on install now. As the installation completes, you can see a screen that says the setup was successful. Now click on close. Now to check whether the Python has been installed successfully on the system or not, we will run a command on the command prompt. Let's open the command prompt, click on start and write cmd. Now to check whether the Python is installed or not, we will run the command python ---- version. Python space ---- version and press enter. So here we can see that Python 3.9.5 version is installed in the system. So yeah, Python is working in the system. Now we'll run some commands for Python. So for that, first we will type py and press enter. And now we will write the basic command, that is print bracket hello world semicolon and press enter. As you can see, hello world is printed here. So yeah, Python has started working in our system. Now we will install libraries of Python. We will be using pip to install NumPy, scipy, matplotlib, and pandas library. And before installing the libraries, make sure the latest version of pip is installed in your system. So to check that, we will run a command in command prompt. We will open the command prompt and write a command pip space ---- version and press enter. As you can see, the pip version is 21.1.1 and it's being downloaded with the Python 3.9. So it's the latest version we have downloaded. So now we have to keep one thing in mind before installing scipy, matplotlib, and pandas library. First, we need to install NumPy library. So for that, we will run a command pip space install NumPy and press enter. Depending on your internet speed, it will get installed. As you can see, the NumPy library has been installed and there's a warning that our pip version is 21.1.1 and we should upgrade it to 21.1.2. That is the latest version available. So we'll upgrade the pip version. For that we will write a command python space -m space pip space install space minus upgrade space pip enter. Okay, so we made a mistake here in the command. So the mistake is we have written only one minus sign before the upgrade. We have to write two minus signs before the upgrade. So we'll write the command again, python space -m space pip space install space minus upgrade space pip, and then press enter. And now, depending on your internet speed, the pip version, the latest pip version, will be installed on your system. As you can see, they have uninstalled the pip version 21.1 and they have installed the latest version, that is 21.1.2. We have installed the first library, that is NumPy, and that's the basic requirement for the installation of SciPy library. So now we will install the SciPy library. So for that we will write the command pip install SciPy, pip space install space SciPy, and press enter. And depending on your internet speed, it will be downloaded. Now you can see that the SciPy library has been installed successfully, and here you can see that the requirement already satisfied, NumPy. So we have firstly downloaded the NumPy library so that we can easily run the SciPy library. Now we will download and install pandas library. For that we will write the command pip space install pandas and press enter. And this will also install depending on your internet speed. We can see that the pandas library has been successfully installed. Now we are left with matplotlib library. So now we will install that. For that we will write the command pip space install matplotlib and press enter. As we can see, the matplotlib library has been successfully installed. Now we have installed all the 4 libraries. So if you want to check whether the library is installed on your system or not, you can write a command to check that. First you have to write python and press enter. First we will check for NumPy library, and for that we will create a array. For that we will write the command import NumPy as np and press enter. If you don't get any error, it means that the library has been installed successfully. So now we will create an array a equal to np dot array (1, 2, 4, 5, 7, 9, d type equal to, we'll set it for float. Press enter, and we want to print this array. Write print array created a and press enter. You can see the output array created 1, 2, 4 and 5, 7, 9. So the NumPy library is working fine. So we will check for other libraries. For that we will write import space matplotlib and press enter. If you don't get any error, it means that the library has been installed successfully. So for the rest also we can write the same commands, import pandas and press enter. We do not get any error, so the library has been installed successfully and we are left with scipy. So we'll write import space scipy and press enter. So here also we didn't get any error, so the library has also been installed successfully. Now we will see what Anaconda is. Anaconda is a free and open source distribution of Python and R language. Here we have Conda, which is a package manager system similar to pip in Python. So now we will see how to download Anaconda and then we will explore its features. To download Anaconda, first we will open the browser and search for the keyword Anaconda. We have to visit the official website, that is www.anaconda.com. And now we will click on the product section and choose the individual edition, as it is open source edition and it is free of cost. Now we will scroll down. Here is the toolkit for the individual edition and we'll click on the download. On clicking the download, we are directed to the bottom of the web page, and here we can see the different versions available for Windows, that is 32-bit and 64-bit. We will download the 64-bit and it is of size 477 MB, so it will take ample amount of time to download. We will download it. As the download completes, click on the application file. Now click on next. The license agreement will appear. Now click on I agree. Then you have to select the installation type. If you want to install for a single user, click on just me. I'll select for all users and click on next. I am installing for me, so I will click next. Then it will ask for installation location. After selecting location, click on the next. For me the location is fine, so I will click next. Then advanced installation options will appear. If you have already installed Python on your system, as we have installed already, so we do not have to click on this section. We will only click on this section and press install. It will take time to install. After the installation is complete, click on next. Then click on next and uncheck both these options and click on finish. As you can see, the installation has been completed. Now we'll go to start and type Anaconda. We can see that Anaconda prompt and Anaconda Navigator are visible. First we will open Anaconda Navigator. It's initializing and adding features. Here you can see some pre-installed applications and tools that are already installed in the Anaconda, and if you want to install any other tool, you can. Like you can install RStudio, PyCharm Professional, Orange 3, GlueWiz in the Anaconda, and you already have Spider, Qt Console, PowerShell Prompt, Jupyter Notebook, Jupyter Lab, IBM Watson Studio Cloud, Datalore, cmd.exe prompt. So now we will open Anaconda prompt. Now we'll see which version of Conda is installed in the system. For that we'll write a command, conda space info, and press enter. Here we can see that the Conda version is 4.10.1. Now we will launch Jupyter Notebook. For that we will write the command Jupyter Notebook and press enter. You can see that the Jupyter Notebook has initiated. Now create a folder where you want to store the projects. and rename accordingly. So to create folder, we'll create the folder in OneDrive. Sorry, I will create the folder on desktop. New folder. We will take the untitled folder and rename it. I'll rename it as Python 1. Now minimize the window and open the desktop. You can see that the Python 1 directory is created, and now we will click on the Python 1 folder and create a Python 3 notebook. As we have created a Python 3 file in the Jupyter notebook, now we can run the Python commands on it. So we will run some commands, and first we will run a basic command that would be print India, and we will run this command. India is printed here.
So let's get started with who is a good Python developer. To be a good Python developer, you will need more than just technical knowledge and the following skills. The first skill you need to know is you should have a problem solving mindset. The second skill you need is strong communication skills. You will need to communicate project requirements and features to your team. This will also help you write better documentation. The third skill you should have is an eagerness to learn new tools and libraries. Then you should have knowledge of how things work internally, and definitely strong technical skills. And if we talk about the average salary for a Python developer in India, that is rupees 8,25,593 rupees per year, as stated by Indeed.com today at 21st December 2022. And the average salary for a Python developer in the United States is $1,06,649 per year. And now we will start with what Python is. So, Python is a general purpose interpreted programming language. Due to its extreme versatility, Python is one of the most sought after programming languages by data scientists, software engineers, and web developers. Python can be used in a wide range of disciplines, including data analysis, machine learning, artificial intelligence, web development, web scraping, competitive programming, and much more. Unsurprisingly, given its versatility, Python became the most sought after language to learn in 2021. There are specific employment positions and sectors that a Python developer can pursue depending on their skill set. That is, web developers, software engineers, data analysts, data scientists, automation testers, etc. These are all Python developers. And the next question that arises in your mind would be why to become a Python developer when there are so many other programming languages that may be learned? Let's look at some of the benefits of being a Python developer. You should start your programming career by learning Python for several reasons. First reason should be Python has a basic syntax and is easily readable. Second should be it makes the language easy to learn for both beginner and intermediate programmers. Python is a multi-purpose programming language with many practical libraries and outstanding analytical capabilities. A programmer can devote more time to development due to these features of Python. Then the third reason should be Python enables programmers to write programs with fewer lines of code. Python programs, for instance, run slower than Java programs, but they also need less time to create because the Python code is 3 to 5 times shorter than the Java code. And the next reason should be all operating systems can utilize Python for free because it is open source software. The next is it is the most productive language. Then we have Python has a wide range of applications, and Python has a vast and active community, and it has hundreds of built-in libraries and frameworks. Now moving on, Python is used by numerous companies like Google, Facebook, Netflix, IBM, and much more. These companies use Python to develop software and use them for machine learning, web development, and many more. You can see how beneficial learning Python is. Now, to become a Python developer, we will begin by studying the fundamentals of Python programming. To master the fundamentals of Python, you should study these subjects. Starting with basic syntax, then you should have a hands on any code editor like Vim, Jupyter Notebook, Google Colab, or Atom. Then you should study the indentation of Python language. Then you should move to loops and logical operators. Then we have data types and variables, then operators, then strings and numbers, and then we have conditional statements and type conversions. And at last, we have functions and built-in functions. Now, we shall go to Python's most crucial section, that is data structures and algorithms. They serve as any computer language's building blocks. DSA is a requirement for both coding and software development interviews. To master the DSA, you should learn about these subjects, starting with array and linked list. Then we should learn binary search trees and recursion. Then we should learn Python lists and tuples. Then dictionaries, sets, and slicing. Then we have stacks and queues. After that, we should learn hashing, hash tables, and graph traversing. Then we should learn about sorting algorithms, divide and conquer algorithms, and many more algorithms. Then we should have a hands-on dynamic programming. After finishing the Python DSA, we will move towards some of the advanced concepts in Python. And the relevant topics to learn in the advanced topics are, we will start with object-oriented programming. Then we should learn the methods. And then we should learn functional programming. And then we have the most popular element, that is inheritance. Then we have decorators in Python, and then we have Lambda functions. We should learn how to use Lambda functions in this language. Then we have classes, and then the simple and regular expressions. After having expertise in core Python concepts, you should learn GitHub. Do you know that practically all hiring managers request a GitHub profile these days? It is an environment to develop your online portfolio and highlight your abilities. A GitHub profile makes you more distinctive from your competition. Recruiters will first look at your GitHub profile when you apply for competitive positions like data scientist, ML engineer, web developer, or Python developer. It gives potential employers an impression of your coding expertise, problem solving techniques, and problem solving philosophy. You have a greater chance of standing out if your GitHub profile is up to date and well maintained. Without a question, knowing how to use GitHub will help you succeed in your career. GitHub is a platform millions of developers use to exchange their code and create online portfolios. After mastering the above concepts, you can choose a career path that interests you as a Python developer. And the career paths we have as is web development as a Python developer. Then we have machine learning or artificial intelligence expert or engineer. Then we have the field of data science. In data science, you can pursue data scientist or data analysis. Then we have automation, testing, and web scraping. So these are the career paths you can choose after learning these concepts of Python. And if we talk about data science, it was rated one of the hottest fields of the 21st century by Harvard Business Review. Data science is an interdisciplinary field that employs arithmetic, statistics, and algorithms to extract useful information from data. A data scientist is a professional with expertise in data analysis and interpretation. These data scientists assist firms to make better decisions and run more efficiently by utilizing their data science expertise. To start a career in data science, you should learn the following things, starting with libraries such as Matplotlib, Pandas, NumPy, and Seaborn. Then you should learn statistical analysis. The science of statistics focuses on creating and researching strategies for gathering, analyzing, interpreting, and presenting empirical data. Then you should have a hands-on probability and mathematical formulas. Probability is a way to gauge how likely something is to happen. Then we should have a hands-on data visualization. Data visualization is integrating different data sets and creating a visual display of the results using diagrams, charts, and graphs. Then we should have a hands-on data manipulation, data analysis, and data interpretation. And if we talk about database management, then we should learn about databases, which are necessary to store and analyze data using programs like Teradata, Microsoft SQL Server, Oracle Database, and MySQL. Once you have mastered these skills, you will have various careers opportunities as a data science expert. And the average salary for a data scientist reported by Indeed.com at 21st December 2022 is $97,148 US. Now moving on web development as a career. If you want to pursue web development, then you should have a good grasp of two frameworks, starting with Django and Flask. If we talk about Django, then it's a high level web development framework mostly utilized by businesses and startups. You can utilize a variety of databases including PostgreSQL, MySQL, SQLite, and Oracle, and it adheres to the MVC design. It could take 2 to 5 weeks to learn if you are a beginner and unfamiliar with authentication, URL routing, API, and models, but these take your time to be patient. Read through some of the additional resources and comprehend every line of code. You will get a grasp of it. You will gradually and thoroughly comprehend everything. And one of the simplest frameworks to learn in Python is Flask. Flask is appropriate for creating straightforward, lightweight web applications. Although it lacks Django's strength and breadth, it offers capabilities like support for developing REST APIs and unit testing. It will take 1 to 1.5 weeks to learn Flask. And then you should have a good command or front end technologies, that is HTML, CSS, and JavaScript. And if you want to build a GUI based web app, then you should have Kinter, MVC, and MVD architecture, which stands for Model View Control and Model View Template. You should have hands on these technologies. And if we talk about the average salary for a Python web developer, that is $106,649 US per year in the United States as stated by Indeed.com. And if we move towards the career path in machine learning and artificial intelligence, then one of the industries with the most rapid growth is machine learning. If you are interested in pursuing a career in ML and AI, you should learn the following things, starting with apply maths and stats. Then you should have hands on machine learning algorithms. And then you should learn libraries such as scikit-learn, TensorFlow, and Keras. Then you should have a hands on prediction model. Then neural networks for deep learning, and then the natural language processing. And after these skills, you can easily pursue a career in machine learning and artificial intelligence. And if we talk about the average salary for a machine learning engineer, that is 1,07,856 US per year in the United States, as stated by Indeed.com on 21st December 2022. And if we move about the career in web scraping and automation testing, we have things to consider while learning web scraping and automation testing. Although Python comes with its own set of test automation frameworks, a Python developer should be familiar with this concept for better understanding. Test automation enhances your work as a Python developer. As Python developer is responsible for debugging errors, tools like Selenium, Test Complete, etc. will help increase efficiency and speed. And things to consider while learning web scraping and automation testing are, we should start with web scraping using Beautiful Soup and request libraries. Then we should have a hands-on Selenium WebDriver. Then we can learn Selenium Grid, and then we should have a hands-on computer vision using OpenCV library. After these skills, you can pursue a career in web scraping and automation testing. If we talk about the average salary for an automation engineer, that is $94,211 US per year in the United States, as stated by the Indeed.com on 21st December 2022. Now, to pursue any career, you should have your projects in your portfolio. Using Python to build interactive projects will help you develop useful coding skills. Your self confidence will increase as you work on your projects, which will also help you in your comprehension of all the programming ideas. Technical expertise will be used to create an appealing portfolio. It is the finest technique to demonstrate your coding abilities to potential employers. Everyone could master the programming language we discussed for different job roles today, but the real deal is to implement your learnings. As you enter an interview, picture yourself stating, I have a respectable portfolio of projects. I learned about the company's future endeavors aligning with my goals. Now, who could possibly reject that, right? In particular, businesses that want to think creatively and break convention to create something remarkable will never say no to such candidates.
Before writing a program in Python ideally, we will write a program on command prompt. So for that, first we will open command prompt. We will click on start and write cmd and click enter. Now the command prompt appears. First we will check the Python version, pip space minus minus version, and press enter. You will see the Python version 3.9. Now we will start writing the Python program. For that, first we have to write the command py and press enter. Now we can start writing a program. We will write a basic program on division. For that, we will assign a value 5 to a variable a and value 10 to the variable b, and we will divide b by a and we will print the value of c. Press enter. As you can see, we have got an output 2.0. Now we have run a program on command prompt successfully. Now we will write a program in Python ideally. So to write a program in Python ideally, we will see some steps. First we have to open the Python ideally, then click on File menu and choose the new file, and after writing the program we have to save the program with .py extension, and then we can click on the Run menu and then we will see a Run module and we have to click on that. Now we'll see it practically. For that, we'll click on Start and search for IDLE. And now we'll click on Python IDLE. Now we will follow the steps as we have seen now. We will click on File menu and choose New File. A new window will appear. Here we will type the program to get two numbers inserted by user and add them. But before writing this program, let's understand this program. So Python program on adding two numbers. First, we have to get an int value inserted in variable a. For that, we will write the command a equal to int round brackets input round bracket started. For the message, we have to put it in inverted commas and the first number colon round bracket close and another round bracket close. Now we will insert an int value in variable b. For that, we will write the command b equal to int round bracket started input round bracket started. For the message, we will put the message in inverted commas and the second number colon, and then we will close this message by round bracket and another round bracket closing. Then we will assign a variable c and add the operation a plus b for that. Now we'll print a message that would be addition of two numbers equal to, that would be in inverted commas, comma c, as c variable will store the result of a plus b. All the statements in the program will get executed line by line. Now we will execute this program on Python IDLE. So for that, we will write a program here that would be a equal to int round bracket start input round bracket inverted commas enter first number inverted commas close, round bracket close, b equal to int input, round bracket started, inverted commas for message, enter second number, inverted commas, round bracket close. Now we will assign the operation a plus b in variable c. For that we will write c equal to a plus b, and now we will print c. Before executing this program, we will save this program file, save as, we will save it as demo1, and we will write the extension py and press save. As the program is saved, now we will run this program by click on this run menu and then click on run module. You can see the program has been executed. Now we will write the first number, that would be 10, press enter, and second number we will write 6 and press enter. We will get 16 as an output. So we have executed the program on Python IDE. Now we will see some best Python IDEs in the market. For that, the best Python IDEs in the market are Jupyter Notebook, Visual Studio Code, Sublime Text, PyCharm, Python IDE, and Spider Notebook. Among all these IDEs, we have worked with Python IDE. Now we will write a program in Jupyter Notebook. For that, you have to install Jupyter Notebook. I have installed Anaconda distribution and it has Python IDE already installed. If you want to know how to install Anaconda distribution, go and check the video in Python playlist. So let's open Jupyter Notebook. For that, first we will click on Start and write Jupyter Notebook and click on the Jupyter Notebook Anaconda 3, and we will wait to get it started in a browser. Now we'll select the location where we want to store the program. We will select the location in OneDrive, desktop, and I've created a Python 1 folder there. So here we'll create a new Python 3 notebook. And name it as first Python program. And now here we can start writing a program. Here we will write a program to multiply 3 numbers. So for that we will get all the 3 integers inserted by the users in 3 variables, and then we will operate the operation multiplication. So for that we will write the command a equal to int, round bracket started, input, round bracket, and here we will print the message, enter, first number, colon, and then inverted commas close and the round bracket close. Now we will enter another integer in variable b. For that we will write the command a equal to int, round bracket, input, round bracket started, inverted commas, enter second number, colon, and then we will close the inverted commas and the round brackets. And now we will get the third integer inputted by the user in variable c. For that we will write the command c equal to int, round brackets, input, round brackets, inverted commas, enter third number, colon, inverted commas close and round bracket close. Now we will assign the operation of multiplication in variable d. That would be by the command d equal to a into b into c. Now we'll print the variable d, and for that we'll also print the message multiplication of 3 numbers and close the inverted commas, and then we will insert a comma and then write the variable d, as d contains the output of a into b into c. Now we'll click on the run command, and now we'll enter our first number, that would be 5, and press enter. Then the second number 4, then the third number 6, and then press enter. And then we will get the output of multiplication of 3 numbers as 120. Now we have successfully run the program on Jupyter Notebook.
So in this video, we will learn what is a variable in Python. Then we'll understand what are object references. We'll also see the different rules for Python variables. And finally, we'll understand variables in detail with hands-on demonstration on the Jupyter Notebook. So variables in Python hold an object of a particular data type. Python variables are containers for storing data values. We do not need to declare variables before using them or declare their data type like we do in other programming languages such as Java or C++. Python is not statically typed. A variable is created the moment we assign a value to it. A variable is a name given to a memory location. So here we can see we have a variable called car and it has a value called BMW. Now this value is of type string since it is written within double quotes. Now, variables can have values of multiple data types. Now Python also allows you to assign values to multiple variables in one line. So here you can see I have assigned X, Y, Z to Audi, BMW and Mercedes in one single line. Alright. Now let's look at object references in Python. A Python variable is a symbolic name that is a reference or pointer to an object. Once an object is assigned to a variable, you can refer to the object by that name. So here we are assigning an integer value of 50 to the variable a. So assignment creates an integer object with a value of 50 and assigns the variable a to point to that object, as you can see here. So a is the variable and it is pointing to the object that has 50 value. Now let's see another example. So in this case we have assigned a variable a which has a value of 50, and then we have created another variable called b that has the value stored in a. Now Python does not create another object in this case. It creates a new symbolic name or reference called b which points to the same object that a points to. So here you can see both a and b are pointing to the same object, that is 50. Okay, now in this example Python creates a new integer object with a value of 100 and b becomes a reference to it. We will explore all of these in our demo. Now there are some rules for Python variables. Let me just read and we will explore all these rules in our demo session. So first, a variable name must start with a letter or the underscore character. A variable name cannot start with a number. A variable name can contain only alphanumeric characters or underscores. So you can see from A to Z, 0 to 9 or just underscore. Variable names are case sensitive. So here you can see I have written date in 3 different types and these are read as different variables and not the same variable. And then there are several techniques to write multi-word variables. You have the camel case, you have the Pascal case, and we have the snake case. Don't worry about it, we'll explore these in the demo. Now let me take you to my Jupyter Notebook where we will understand variables in detail. Okay, so I am on my Jupyter Notebook and I have my title as variables in Python. So let's start with my first variable. Let's say I have a variable called a and I'm assigning 50 to it. Now you must be aware 50 is of type integer. So this a variable is now holding an integer value. Now if you want, you can just print a. If I hit shift enter, it will give me the value of 50. Now to check the data type of a, you can use the type function. Now we have covered data types in detail in our previous video. If you want, you can have a look at it. So I will write type of A. If I hit Shift Enter, it gives me the integer type. Okay. Now let me show you another function called id. If I write id of A, let's run it. It gives me a number. This is a long number. Now the id function in Python returns a unique id for the specified object. So here object is A. So all objects in Python have its own unique id. The id is assigned to the object when it is created. Now what if I assign 100 to A this time, and let's see the id of A. If I run it, you can see here the values are different than the previous one. So every time the id function will return a unique id for the specified object. Alright. Now we learnt in our theory section that you can assign multiple variables in a single line. Now let me show you how to do it. Suppose I'll write x, comma, y, comma, z. So these are the three variables and I want to assign three values to them. So let's say x will have 50. In y, I want to store, let's say, 168.6, and my z will have a string or a text value, let's say Simplilearn. Alright, let's run it. Okay, now you can print them one by one. You can see here x has 50, y has 168.6, and z has Simplilearn of type text. You can check the data types if you want. Let's say I want to check the data type of y. It gives me a float because 68.6 is a float. You can check the data type of z. It is of type string. Okay. Now you can also perform the same operation of assigning multiple variables in a single line in another way. Let me show you how to do it. Suppose I want to assign the same value to three different variables. Let's say I want to assign the value of 10 to x, y, and z. So I'll write x equal to, y equal to, z equal to, I'll write 10. If I run it and let me print them one by one, you can see here x is 10, y is 10, and z is also 10. Now there is another way to do it. That is, I'll pass in my variables x, y, z, and then I can write 10, 10, 10. This will return the same result. Okay. Now let's look at the rules for writing variable names. So these rules we had discussed in the PPT section. Now we'll explore them one by one. So the first rule is a variable name must start with a letter or the underscore character. So let me just give a comment first. Rules for variable naming. So the first rule says a variable name must start with a letter or the underscore character. So if I write, let's say, some random variable name ABC equal to 100, this is valid. You can print it. ABC, it gives me 100. Now you can also write the variable name as A followed by any number. It should be integer number. If I write 102 equal to, let's say, this time I'll give a string, let's say India, and let me print it. It works perfectly fine. Now we also said the name must start with an underscore. I can start with an underscore and then write, let's say 123 is equal to 70.5. Now let me print it. Now this works as well. So you can start your variable name with an underscore followed by a letter or numbers. Let me show you another example. This time I follow the underscore with letters. Let's say dog. I'll just give any random dog name. Let's say I have a dog called Puppy, and let's say I'll print it. This also works. Okay. Now you can have multiple underscores in your name as well. Suppose I'll write underscore name underscore age. This is my variable name. I'll write, let's say, Stuart 36, and let me print it. I'll write underscore name underscore age. This is also a valid variable name, so you can have multiple underscores in your variable name. Now the next rule is a variable name cannot start with a number. So if I write, let's say, for name equal to Gilly, and if I try to print it, it will throw an error. So you cannot have a variable name starting with a number. Alright, now let me just scroll down. The next rule is a variable name can only contain alphanumeric characters and underscores. So if I write @ then let's say age equal to 40. If I run this, it throws me an error because @ is not recognized and it is not a valid variable name. Similarly, let's say I'll write name $age equal to, let's say, 40. Again, this is not recognized. You cannot use it in your variable name. The next rule is variable names are case sensitive. So suppose I have a variable called car which is all in lowercase, and my car has a value, let's say, BMW. Now if I were to print car, it gives me BMW. Now suppose I have another variable which starts with a capital letter C followed by lowercase ar. If I were to assign CAR to, let's say, Tata, and I print it, it returns me Tata and not BMW. So you should keep in mind that variable names are case sensitive. Now similarly, I can also have a variable in all uppercase. Let's say my car is of Toyota brand. I made a spelling mistake. Okay, now if I print CAR, it gives me Toyota. So these are the different types of using case sensitive variables. Now another important thing to note is in Python, reserved words cannot be used as a variable name. So let me open a new tab, and here you will search for reserve keywords in Python. Let me open this link or any other link for your reference. You see here, these are all your keywords in Python, and these cannot be used as variable names. Let's try using a few of them. Let's say I'll use break. Let's assign a value to variable break equal to, let's say, 60. If I run it, it gives me an error, invalid syntax, break you can't use. Similarly, let's use another keyword. Let's say I'll use for this time. We have a keyword called for, you can see it here. Suppose I write for equal to, I have, let's say, Virat. If I run this, it throws me an error again. Let's try one more keyword. Do we have try as a keyword? Yes, we have. You can see here try is a keyword. If I write try equal to any random value I'll pick, this time I am giving a floating number, let's say 140.5. If I run it, again it throws me a error. But you can use an underscore and then you can give that keyword, let's say try. I'll assign the same value and let's say we'll print it. This will work fine since the variable name is no more a keyword because we have an underscore in the beginning. Okay, now let me show you some basic operations that you can perform on Python variables. Let's say we have a equal to 100 and let's say b equal to 200. You can assign an operation to another variable called result. Let's say I want the operation to be an addition operation, and let's go ahead and print result. You can see it has given us 300 because in result we are storing the addition of a and b. So 100 plus 200 is 300. Now similarly you can perform many operations, like let's say this time we'll perform a subtraction operation. So this time I'm storing a minus b in result, and let's go ahead and print result. You can see here 100 minus 200 is minus 100. Then you can also have, let's say, result equal to a by b, and let's print it. Fair enough, we have 0.5 because 100 divided by 200 is 0.5. Similarly, you can also have integer division. Suppose I write 100 divided by say 40, and I'll print the result. You see here it has given us 2.5, but what if I want to perform an integer division? So I'll add one more forward slash here and let's run it. It gives me only 2, so it has truncated the 0.5. Okay, now moving ahead, let's say I have a variable called country and I have India in it. So country is my variable name and it is pointing to the object that has India as the value. I can print the variable. You see here I have India, and now if you want you can perform some extraction operation. Suppose if I write country within square brackets, if I write 3, it gives me the character that is present at the third index. So I is present at the 0th index, N is at the first index, D is at the second index, and I is at the third index. Let's say I want everything that is present until the third index. It gives me I and D. So this 3 is exclusive. It will only return us the values present at the 0th index, the first index, and the second index. Okay. Now let me show you another interesting example. Suppose I have a list that is called cars, and I have a list of car names. Let's say I have BMW, then I have Ferrari, and let's say I have Toyota. I'll run it and I'll print my list that is cars. You can see here there are 3 car names, and now what if I want to put each of these car names in different variables? So I can write x comma y comma z and I'll write equal to cars. If I run this, now what it will do is it will assign each of these values to x, y and z respectively. Now if you want to print x, you can see here x has BMW, then y has Ferrari, and z has Toyota. So this is another way to assign values to variables from a list. Okay. Now you can also use variables in the print function or the print statement. Suppose I write x equal to, let's say it has Simplilearn. Now I can print a message, let's say welcome to, I'll give a space, close the quotations, give a plus sign, and I'll give the variable name. If I run it, you can see here the message is printed, welcome to, and the X which has the value of Simplilearn. So welcome to Simplilearn. Okay. Now another thing to note in Python is that you cannot add an integer and a string. Suppose I have X as the variable and it has a value, let's say 20, and then I have Y which has the string Simplilearn. Now string can be put in double quotes or in single quotes. You can use whichever way you want. Suppose I print X plus Y. Let's see the result. It gives us an error. So you cannot print or add an integer and a string. So you need to convert one of these values. Now there are several techniques to write multi-words variables. You can use the camel case to write multi-word variables. So here each word except the first starts with a capital letter. So I'll just give a comment here and write camel case, and the way to write is, apart from the first word, all the words start with the capital letter. Suppose I write my department equal to marketing. So here the first word my, the M starts with a small letter, while the second word department, the D starts in a capital letter. So this is an example of a camel case. If I want to print it, I can write my department and run it. It gives me marketing. Let's see another example. I have, let's say, car brand. So you see here car brand are two words, but the first word starts with a small letter while the second word has an uppercase B. Let's say my car brand is Hyundai. Now you can print it. There you go. Alright. Moving ahead, we also have Pascal case where each word starts with a capital letter. Suppose I have a variable called my name is, let's say, Nathan. Here you can see my and name are two different words and both the words start with a capital letter. So this is an example of Pascal case. If I run it, let me just print it first. Okay, you see here I have my name. Similarly, let's say we have another Pascal case multi-word variable which is age now, where age has A caps and now has N caps. So this is also an example of a Pascal case variable. Let's say my age now equal to 30. I'll print age now. It returns me 30. Now one thing to note here is, if I write, let's say, age now, if I do this, it gives me an error because your variable names are case sensitive. So we haven't created any variable which has small a and small n in age now. Okay. Now the third way to write a multi-word variable is called as snake case. So if you want, I can give a comment saying snake case. So here each word is separated by an underscore character. So let's say I have a multi-word variable which is city underscore address, and let's say the city is New York. Now if I print it, you have New York. So this is an example of a snake case where each word has a underscore in between. You can have multiple underscore between each word. Suppose I write my current age equal to 35, let's say. So I have my current age. If I run it, okay, there is some mistake here. I have missed an R. You see here it says 35. So this is also an example of a snake case where each word is separated by an underscore. So here we have two underscores. Alright, now let me go to the top and let me brief you what we did. So first we saw an integer value variable. We saw how you can check the data type of the variable using the type function. Then we explored about the id function. We saw how you can pass in variables or multiple variables in a single line. Then we saw how you can assign the same value to 3 variables in one line. Now this is another method to do the same operation. Now then we looked at the different rules for naming variables. Your variables can start only with a letter or an underscore, and that letter can be followed up with numbers as well, and you can have similarly numbers after underscore. You can also have characters after underscore. You can have multiple underscores, but your variable name cannot start with a number, and it cannot have special characters like @ or dollar symbol. These will throw an error. Now you can see your variable names are case sensitive. So here we defined car in 3 different ways, and all the 3 gave us different results. Another important thing we saw was you cannot use keywords, Python keywords, as variable names. We saw break, for, and try. Now we performed some basic mathematical operations. We also saw how you can perform some extraction operation using string values in Python. Then we saw another way to assign the values of a list to different variables. We saw how you can use the variable name in a print statement. Then we saw how you cannot add an integer with a string. We explored the camel case. Then we saw how you can write multivord variable using Pascal case, and finally we looked at snake case. So in Python, every value has a certain data type. The variables in Python hold an object of a particular data type. Since everything is an object in Python, data types are actually classes, and variables are instances of these classes. Now there are various data types in Python. First we have the numeric types, which are essentially numbers. So under numeric types we have integers, floating point numbers, and complex numbers. Then we have text type data, which are in the form of strings. The third type of data that is available in Python are called as sequence types, which consists of lists, tuples, and range. We have already seen about lists and tuples in our previous video. And in Python we also have dictionary objects as mapping data types. In the previous video you saw how to map key value pairs using dictionaries. Next we have set data type. Now sets are unordered collection of unique items. Python also supports Boolean data types, and finally we have binary types of data, which include bytes, byte array, and memory view. Now let's head over to the Jupyter notebook, where we will learn about these data types in detail. So here I am on my Jupyter notebook, and I have titled my notebook as data types in Python. REC is for recording. So let's first start with numeric data types. I'll give a comment using a hashtag. I'll write numeric data type. Okay. Let me define a variable called num, in which I'll store a value of 7. Now let me go ahead and print the data type of my variable num. So for that I'm using my function as type. If I run this using shift plus enter, you can see here it tells me that num variable is holding a value of type integer. Now you can also use a print statement. I can write something like print num, comma, I can give a message as is of type. I'll give another comma, and then I'll use my function type of num. Let's see the output. You can see it here. It first gets the value that is stored in the variable num, so 7 is of type, and then it prints the class is of type class integer. Alright, I've just increased my size of the notebook. Next, let's declare the same variable num, and this time we'll store the value as, let's say, 10.8. Now you can see here there's a point, which means this is a decimal or a floating value. If you can check the type of num, it gives us num is holding a value of type float. Now let's say I'll take a negative number, let's say minus 10.8, and we'll see the type of num. Again, minus 10.8 is also of type float. Now let's say I'll declare a complex variable, let's say 8 plus 6j. Now this is a complex number which is again of type numeric data type. If I want to check the data type of num, it gives me complex, because 8 plus 6j is of complex data type. Okay, now if you want to extract the real and the imaginary parts of a complex number, you can do it something like this. You need to pass in the variable name followed by a dot, and the attribute name is real to extract the real part of the complex number. If I run this, you can see here it has returned the real part of the complex number, which is 8. Now if you want to print the imaginary part, you can use num.imeg, which is for imaginary. If I run this, there you go, it gives us the imaginary part, which is 6. Okay, now in Python you can also perform conversion of data types. So you can convert between different data types by using type conversion functions such as int, float, str, etc. So let me define a variable called num which has a value 7.8. Now what I'm going to do is I'm going to create a variable called b, which is going to store the integer part of num, which means initially I had defined num as 7.8, which is a floating point number. I want to convert this num to integer type now, and let me go ahead and print my b, and I also print the type of num, and I'll then print the type b. Let's run this and see the result. Okay, so if you see here clearly, when I see print b, it has returned me 7, which is of type integer, so it has truncated the decimal part present in 7.8. Again, if I print type of num, so num is holding 7.8, it is of type float. After converting the float value into integer, it has given me int. Okay, similarly, let's say we have another number minus 90.5, and if I were to check the type, I would write print type of num. Then let's convert this to integer. So I'll write print int of num. Let's see the results. Okay, so initially minus 90.5 is of type float. After we converted our num to integer, it gives us minus 90, so it has truncated the decimal point part. Alright, now let's say I'll create another variable, let's say c equal to, let's say I'll write float of b. Now if you remember, our b holds a value of 7. if I were to convert b to float again, I can use the float type conversion function. And let's go ahead and print c. If I run this, you can see here previously b was holding an integer of 7. Now it has converted that integer into a float value, so it is 7.0 now. Okay. Now moving ahead, let's see about Boolean data types. So if I have a variable, let's say r equal to, let's say it has a value called true, which is a type of Boolean value, and let me go ahead and print the type of r. It gives me Boolean. Now let's say I'll write num greater than c. Let's go to the top. If you see here, num is holding a value of minus 90.5 and my c is holding a value of 7.0. I'm checking if num is greater than c. If I run this, it gives me false because minus 90.5 is less than 7.0 and not greater than 7.0. Suppose I create a variable boolean or bool and I'll store that value num greater than c, and let's print the type of boolean. I'll use type of my variable, that is bool. Let's run it. You can see it here. It tells us that this particular operation is now holding a data type of boolean. If you are getting confused, we can change the variable here. Let's say I'll write b underscore bool, and similarly I'll write here b underscore bool. Let's run it. You get the same thing. Alright, now moving ahead, let's explore how string data types work in Python. I'll give a comment as string data types. Let me scroll down. Okay, so string data types or string values in Python are passed within quotations. Suppose I have a string called str1 and it has a value, let's say Python programming. So this is a text value. I have another string, let's say str2, which has a value, let's say Simplilearn. Now let's run this. Okay, now if I were to check the type of str1, it should give me string. So str here is a string. Now you can also perform extraction operations from the string. Suppose you want to extract the value that is present in my first string, that is str1, at index number 5. Let's run it. Okay, there is some error here. Okay, so this should be str1 and not strl. Let's run it again. It returns us n. Now let's count what is present at the 5th index. So from our previous introduction to Python video, you might be aware that in Python the index number starts with 0. So if you count, p is at index 0, y is at index 1, t is at index 2, h is at index 3, o is at index 4, and then n is at index 5. So hence str1 of 5 returns n. Similarly, if you can check for other string, that is string 2, let's say I want to see the value that is present at minus 4. Let's run it. It gives us e. Now if you use a negative indexing operation, it will start counting from the backward position. So here n is at minus 1, r is at minus 2, then you have a at minus 3, and e is present at minus 4. So hence str2 of minus 4 returns e. Cool. Now you can also perform slicing operation. Suppose I write str1. I want everything that is present between the 0th index to the 5th index. I'll run it. It gives me pytho. So if you check in string 1, it will start counting from the 0th index and go up to the 4th index and exclude the 5th index. So in my string 1, if I start counting from the 0th index, so it is 0, 1, 2, 3 and 4. So it will print from P till O. And that's the result. Okay. Now you can also use some inbuilt functions with string. Suppose I write str2 dot find. So I want to find the index where my m is in Simplilearn. So I'll write m within quotations and print it. It returns me 2. If you check again, so s is at 0th index, 1 is at the 1st index, and m is present at the 2nd index. Okay. Now moving ahead, let's explore a few sequence data types. So we'll start with list data type. Okay. Now, first of all, let me go ahead and declare a variable called split1 equal to, and this will have some text. Let's say this is orange. Then I'm going to create another variable called L1 equal to, I'm going to split my variable or my string, that is split1, using the split function, and I'm going to split using the comma. So you can see here my string has comma. I'm going to separate each of these words with a comma, and let's print L1. If I run this, you can see it here. Initially my split1 was of type string, and now we have converted split1 to a list. You can see this is a list and it is present inside square brackets. To verify, you can use the type function. So I'll write type of split1. It should return string. You can see it here, str. And now if I write type of L1, it gives me a list. Okay. Now let's see a few more examples. I'll create another list called list1, and let's see it has some values. The alphabet A, we have the number 1, which is in terms of string again because I have passed in quotes. Let's say I have India. Let's make it consistent with single quotations, and let me print what is inside list1. If I run it, I get my list. Now you can check the data type. If I write type of list1, it gives me, it is of type list. Now you can also perform certain operations on list. Suppose you want to add a few elements to your original list. For that, I'm going to create another variable called list2, and let's say list2 has some values, let's say b, comma 2. Now if I write list1 plus equal to list2, and let me go ahead and print list1. Let's see the result. There you go. So our initial list had 3 elements, A, 1 and India, and now we have merged or concatenated 2 more elements, B and 2, and hence this becomes our final list. Okay. Now moving ahead, let's see one more sequence data type, that is tuple or tuple. Now list and tuples we have already covered in our previous video on Introduction to Python. If you need to brush up what list and tuples are, you can check the previous video. So I'm going to create a tuple that is tup1, and I'm going to store some values. Tuple you can create using braces. I have some value, let's say A, B, C, D, and let's say E, or let's just restrict it to D. Now you can check the type of tup1. You can see here tup1 is of type tuple. Now I'll create another tuple, let's say tup2, and it has some values, let's say E, F, and let's say G. Now if I write tup1 plus equal to tup2, and if I print my tup1, I get the result of a merged tuple which has values of both tup1 and tup2. You can see here our original tuple had A, B, C, D, and then we merged the second tuple, and it has given us E, F, G as well, and hence this becomes the final tuple. You can also perform some basic operations on tuple. Let's say I'll write tup1 multiplied by 2. You can see the result here. It has printed my original tuple twice. Okay. Now moving ahead, let's see our mapping data type, that is dictionary. Again, dictionary is also covered in our previous Introduction to Python video. You can also have a look at that video. Now the way to declare a dictionary is I'll create a variable dict1, and dictionaries are written using curly braces and have key value pairs. So I'll write my first key as 1, and let's say this dictionary is about animals, and I have, let's say, lion as my first animal in the dictionary. Then I'll create my second key. Let's say the second animal I have is tiger, and let's say my third element is a dog. Let me run it and print my dictionary. You can see this. We have the dictionary printed. Now if you want to check the type, you can write type of dict1. It returns us dict, which means dictionary. You can also print the length of dict1, and it gives us 3, which means our dictionary has 3 elements. Okay. Now moving ahead, we'll explore our set data type. Now as we understood that sets are unordered collections of values, and these values are always unique. So I'll write set1, let me give a space, equal to, again sets are written within curly braces. I'll create a set, let's say it has some duplicate entries as well, and I'll print my set1. It returns only the unique values, so it has dropped this 5 which was duplicated. You can check the type of set1. It gives us it is of type, or the object is of type set. Now suppose I have another set called set2, which has values, let's say A, comma B, and let's say we have some numbers 3 and 4. I'll tell you the operation that I'm going to do. I'm actually going to do an OR operation. So I'm going to print set1 or set2. So this is an OR operator in Python. Let's print the results. You can see here it has printed all the values that are present inside set1 or set2. So in set1 we have 1, 2, 3, 4 and 5, and in set2 we have A and B. So it has dropped 3 and 4 because these are not unique, and 3 and 4 are also present in set1. Suppose I were to perform an AND operation. I'll write set1 ampersand set2. If I run this, you can see here it has only printed the unique values that are present in both set1 and set2. So 3 and 4 are the unique values, and hence it has printed 3 and 4. Let's say I'll write set1 minus set2. Let's see the results. It gives us only those values that are present in set1 and are not present in set2, which is this. Let's see the result if I write set2 minus set1. So this will return the unique values that are present in set2 and are not present in set1. So A and B are the unique values that are present in set2. Hence it has printed as A, B. Okay. Now another data type we had discussed was range. So range is basically a function. If I write x equal to range 4 and I'll print x, it gives us from 0 till 4, because in Python the first index starts from 0 and goes till 4. So the range is from 0 to 4. Now you can also print the type of x. It returns us a range. Now we'll see some binary data types. Binary data types are not very often used in Python, but it is better if you know. Binary data types can be written as x equal to b. Let's say I have a string. I'll write within double quotations hello world, and let me go ahead and print my variable x. You see here we have hello world, and now let's print the type of x. You see here this is a binary type which is bytes. I'll show you another operation. Let's say you want to extract a specific value from a particular index from this binary data. So again you can use the indexing operation. Suppose I write print. I want to extract the value present at the 4th index. It gives me 111. Now this is very interesting. Let's deep dive into this. Let's check what is present at the 4th index of my string. So H is present at the 0th index, E is at the 1st index, L is at the 2nd index, the second L is at the 3rd index, and we have O at the 4th index. So when we are trying to print the index position, it is actually returning us the ASCII value of small o. Now here I have a doc open which is from IBM documentation. If you see the ASCII value of small o or lowercase o, you will find that the ASCII value is 111, and hence it has returned us 111. Let's try for another index number. Let's say I want to find the value which is present at index number -2, and if I run it, it gives me 108. So -2 means it will start from the last index. So -1 is D and -2 is L. Let's see what is the ASCII value of L. If you see it here, the ASCII value of L is 108, and hence it has returned us 108. So this is how the binary data types work in Python. Now let's convert some sequence objects to other type of objects. Let's say I have a string called S which has something like Messi is from Argentina. Now you can check the type of S. Fair enough, it tells us that Messi is from Argentina is of type string. Now what I'm going to do is I'll use my list function and pass in my variable that is S so that it converts S to a list. And let me go ahead and print my L. You can see here my string S has now been converted into a list, and this is the result. See here, these are all list elements present inside square brackets. Now if you want, you can check the type of L. It should return us list, and you can see it here. Now suppose I have another list, let's say L1, which has some numbers, let's say 1, 15, 3, 6, 0, 8, 4 and 3. Let's say we also have 1. Okay, so this is a list. You can check type of L1. Fair enough, it tells us that this is a list. Now I want to convert this list L1 to a set. Now as we know that set only contains unordered unique elements. So if I write S equal to, I'll use the set function and then I'll pass in my list variable that is L1, and let's print S. It only returns me the unique values present in the list. So it has dropped the duplicate elements such as 3 and 1. Now you can check the type of S. It gives us set. Okay, so that brings us to the end of this demo session on data types in Python. Let me go to the top and I'll brief you what we did in this demo. So first we looked at the different numeric data types. So we saw integer data type, then we saw floating data type. We also had complex data types. We saw how to extract a real part and imaginary part from a complex number. Then we used some type conversion functions to convert the numeric data types from one data type to another. So here we converted a floating type data to an integer type data. Similarly, we saw how to use Boolean data types. Then we saw about string data types. We also performed some basic operations of using indexing method to extract different values. We also saw how you can use slicing to extract a range of values from your string. We used the find function to find the index of a particular character in the string. Then we learned the important sequence data types like list. Then we had tuples. And then we learned about mapping data types such as dictionary. We also looked at set data type. Now later on we explored about range data type and we looked at binary data types. We saw how binary data type returns ASCII value of a certain character. Finally, we converted strings to list, and then we saw how to convert list to sets. So we are going to talk about object types in Python. Then we'll see the different type conversion functions that are available in Python. Then we see the different types of type conversion. Alright. Now let's look at the different types of objects in Python. So we have lists, you have tuples, numbers, strings, dictionaries, sets, you even have file objects. Then you can see we also have other core types such as Boolean and none. Then we have program unit types like functions, modules and classes. Now we will touch upon most of them in the demo section of this tutorial. Then we also have implemented related types. Alright. Now let's see how you can convert one data type to another using type conversion. So Python provides two types of data conversion techniques. One is called the implicit type conversion and the other is called the explicit type conversion. Now in implicit data type conversion, Python can automatically convert one data type to another data type. This process does not need any user involvement. While in external conversions, users convert the data type of an object to required data type by using predefined functions that are listed here. So you can see here we have the different functions. So if you want to convert a specific value to an integer, you can use the int function. We have the float function. Now we have something called as ORD. So the ORD function accepts a string of unit length as an argument and returns the Unicode equivalence of the passed argument. Now we also have hex and oct. So the hex function is used to convert an integer number to its corresponding hexadecimal value. Similarly, the OCT function will convert the corresponding, or let's say will convert an integer number to its corresponding octadecimal value. We have tuple, list, set, dictionary. Str is for string. You can convert a number into a complex number by providing its real and imaginary part. Now we also have the chr or the character function. Now this is how the basic general syntax looks like. You have the required data type followed by the expression. Okay. So let's head over to our Jupyter notebook and learn the different types of objects as well as look at the type conversions in Python. Okay, so here I am on my Jupyter notebook. Let's first look at number objects. So I'm giving a comment as number objects. Alright, let's say I have a variable called num which is equal to, let's say, 2. Now it's very simple that 2 is an integer. So if you want to check the type, you can just use the type function and it gives us int, which means integer. So here 2 is of a type called number object. Let's say you want to pass a floating value, that's a 2.0. See the results. 2.0 is of type float, and again 2.0 or 2.0 is a number object. Now you can perform various operations on number objects. Suppose you want to add a few numbers. So let's say 321 plus 365 and I'll say add. It gives us the addition of these two numbers, which is 686. Now let's say you want to perform a multiplication operation. Let's say 62 multiplied by 2.5. If I hit shift enter, it gives me the multiplication or the product of these two numbers, that is 55.0. Now Python by default will convert the result to a floating point number if there is one integer and this one float. If you want to return the exponent of a number, let's say I want to know 2 raised to the power 4. So I'm using double asterisk to represent the exponent operator. If I hit shift enter, it gives us 16. So it's basically 2 multiplied 4 times. Now you can also import specific libraries. So let's say I want to import the math library and I want to print the value of pi. So here I have written import math, and then using the module math I am trying to find the value of pi. Let's run it. You see here it says 3.141, so on and so forth. Now you can also import the random module. Let's say I'll write import random, and then let's say I want to print a random number. You can use the random function. Let's run it. You see here this is a random value that Python has generated. If I run it again, this value changes. Let's run it again. Again this value changes. Okay. Now we'll shift our focus to understanding string objects in Python. So I'll give a comment string objects. Let's say I have a string A is equal to, and let's say the string has India. Okay. Now if you want, you can print A. It says India. Now suppose I want to extract the value that is present at the 0th index of the string. So the way to do is, I'll pass in my variable name, that is A, and within square brackets I'll give the index value, that is 0. Now one thing to remember, in Python the index value starts with 0 and not 1. So if I do A of 0, it gives me I, because I is present at the 0th index. Now let's say I want the last value in this string India, so I need to return A. For that I can use negative indexing by using -1. If I do -1, it gives me A, which is the element present at the last index. Now let's say I'll write A1 and colon. Let's run it. You see the result here, it says NDIA, which means Python has returned everything starting from the first index till the last index. So here colon means you need to return everything that comes after the first index. Now let's say I'll write print A and I'll add, let's say XYZ. Let's run it. You see here this XYZ has been concatenated with the value that was present inside A, that is India. So the result is India followed by XYZ. Okay. Now if I write A multiplied by 7, it will print India 7 times without a space. You can see it here. Cool. Now let's say you want to replace certain values in the string, you can use the replace function. So if I write a.replace, let's say I want to replace IA that is present in India with, let's say, XYZ. Let's run it. You see here IND is fine. After that we have IA, and that IA has been replaced by XYZ. Now let's move on and understand list objects in Python. So I'll write list objects. Okay, so let's go ahead and declare a list L1 within square brackets. Let's say we have values like 101, let's say America, and then let's say we have another floating value, let's say 2.05. This is my list. If you want to print the list, you can use L1 to print it. You see here, this is my list L1. Now if you want to find the length of L1, you can use the len function. If I run it, you get 3, which means there are 3 elements in the list: 101, America, and 2.05. Now if you want to extract certain values from the list, for that you can use the indexing method. Let's say I'll write L1 of 1. That gives me America, because at index position 1 we have America. So 101 is at the 0th index, America is at the first index, and 2.05 is at the second index. Next, let's say I write L1 and then I give colon -1. Let's print it. So that gives me 101 and America. So what it does is, this colon -1 will exclude the last index and print the other 2 elements in the list. Okay. Now if you want to append some elements to the list, you can use the append method. So I write L1.append. Within brackets I'll give my value, let's say USA. Now let's go ahead and print L1. If I run it, you can see the difference. Earlier my list had 3 elements, 101, America, and 2.05. Now we have added the 4th element, that is USA. Cool. Now you can also use the pop function in Python. Let's see what it does. So if I write L1.pop, and I'll give, let's say, 3. If I run it, it returns me USA because USA is present at the third index of my list. If I write pop1, it gives me America because America is present at the first index. Alright, now you can also reverse the elements in a list. If I write L1 dot reverse function, if I run this and then I'll print L1, you see the result here. We have 2.05 and 101, which is printed in reverse order. The reason being, we have already popped America and USA out and we are only left with 101 and 205, and if you reverse the current list, it will be printed as follows. So 2.05 comes at the beginning and then we have 101. Let me just rerun my list again to show you the difference. I have run my L1. Let's run this append query, and now let's use the reverse function. There you go. So now our original list has been reversed. So you have USA at the beginning and 101 towards the end. Okay. Now moving ahead, let's see the next type of object in Python, that is dictionaries. Okay. Let's say I'll create a dictionary called dict1, and you might be aware that dictionaries are created using the curly braces. So I'll have my key value pairs. Let's say my key is 1 and the value it holds is, let's say, the names of animals, tiger, comma, we'll have the second key, and that second key will have the value, let's say, lion, and let's say we have another element with the third key, and let's say we have mouse. Okay, now let's print our dictionary. So this is how my dictionary looks like. Now you can display the keys by using the keys function. So this will return all the keys present in the dictionary. You see here 1, 2 and 3 are my keys. Similarly, you can display the values in the dictionary. You need to change these keys to values. If I run it, you see here tiger, lion and mouse are the 3 values. Now suppose you want to add another element to your dictionary. For that you can write dict1 and give the fourth key equal to the value, let's say, cat. Now let's run dict1 and see the difference. There you go. So here we have added another element to the dictionary, which is cat. Now moving ahead, let's explore tuple objects. Okay, so we'll create a tuple called t1 equal to, we'll have the values 1, 2, 3, 4, and let's say you want to print the length of tuple t1. It gives you 4 because we have 4 elements in the tuple t1. Now let's say I'll declare one more tuple called t2, and this time we'll have 2 more elements in the tuple. So I'll write t1 plus followed by the 2 elements that I want, let's say 7, 9, and I'll print t2. If I run it, you can see here we have added 7 and 9 to our original tuple that had 1, 2, 3, 4. Now you can also use the indexing method or the slicing technique to extract values from the tuple. Let's say I write t2 of 3, it will return the third element that is present in tuple t2. So if you see here, my third index has the element 4, hence it has returned 4. Cool. Now moving ahead, let's see how file objects work in Python. Alright, Now, using Python, you can create files. Let's say I want to create a text file in Python using the Jupyter Notebook. For that, I can write f1 equal to, I'll use a function called open, and inside this open function I want to create a text file, and first I'll write something into that file. Let me show you. So this is a folder that I have. The folder name is called object types and it is present in my desktop. So I'll use this location, and here you can see now this folder contains no files as of now, but we are going to create a text file using Python. Let's see how to do it. So here I'll paste my location that I've just copied. Now one thing to note is you need to convert everything to forward slash, or you can use double backslash also. I'll give another forward slash, and let's say I want to create a file in the name of data.txt. So it is going to be a text file. Make sure everything is inside single quotation, and I want to open the file in write mode. So I'll write W here. Let's run it and see the difference. Now if we check our folder, you see here earlier there was no data file. Now we have created a text file in the name of data. You see here there are no information or data inside this text file. Next we are going to add some data to this text file. Let's go back to our Jupyter Notebook. Okay, so we'll write some data to that file. So I'll write f1 dot. After that I'll use the write function, and within single quotations I'll write, let's say, hello Simplilearn, and then I'll give \n to go to the next line. I'll write again f1 dot write, and I'll pass in another message, let's say welcome to Python programming, and we'll give another \, followed by n, and then finally we'll close the file. So I'll write f1 dot close function. Let's run this and we'll see the difference now. If I open this, there you go. We have some data in this text file, that is hello Simplilearn, welcome to Python programming. So this is how file objects work in Python. Alright, now moving ahead, we'll see how sets work in Python. Suppose I create a set called S, and I'll use the set function, and I'll pass in India. So this is a string, and I want to convert this string to a set. Let's say I have another set called S1, and here I have a list of values, let's say U, S, and let's say A. Now if I write S comma S1, so what set does is it will return only the unique values that are present inside each set. So here if you see India, all the elements are unique except I, because I is repeated twice, so it will return I only once in the result. But USA has all the elements present only once, so set will return all the elements. Now what if I'll write, let's say S ampersand S1. So this will give me only the common element that is present in both the sets. So if you see here in India and in U, S and A, only A is repeating in both the sets, so it gives me A. Suppose I write S, this is the OR operator, and I'll write S1. If I run it, it gives me all the elements that are present inside set S and S1, excluding the repeating elements. So here I is repeating, so it has printed only once. Similarly, you can write S minus S1, so you get only those elements that are present inside set S and are not present in set S1. Now in set S, A is present as well as A is present in set S1, so it has excluded A from the result. Okay. Now we'll see some operations. Let's say I'll write A equal to 7 and B equal to, let's say, 2.0. I'll add A and B and store the result in my variable R, which stands for result. Let's see the output. If I write print R, it gives me 9.0, and if I check type of R, it gives me, there's a spelling mistake, I'll write type of R, it gives me float. So here Python is performing implicit type conversion. So if you add an integer with a floating point number, the result will be a floating point number and not an integer. Now if you say A equal to 7 and let's say B equal to same 2.0, and this time I am explicitly defining my result to be an integer, so I'm using an integer function. So if I write A plus B and if I print R, you see the result, it has given me an integer which is 9. Now to verify, you can also use type of R, it gives me integer, but earlier it returned us float. So this is how implicit and explicit conversion work in Python. Now this example was for numbers. Similarly, you can also perform for strings and for lists, tuples and sets. Now moving ahead, one thing I wanted to tell you was you cannot add a string and an integer. Suppose I'll give a comment, string and integer addition. Suppose I have a variable called A which has a value of 7, so 7 is an integer here. Then I have a variable called B which has a value 2, but this time I'll assign this 2 within quotes, so this becomes of type string. Now if you want, you can check that as well. If I write type of 2, rather type of B, it will give us str, which means string. Now let's say I'll write R, which stands for result, equal to A plus B. Now if I print R, it will give us an error because you cannot add a string with an integer. So it says unsupported operand. The way to fix this is you need to convert this string into an integer explicitly. So this time we'll say equal to 7, B equal to 2, so it is a string. Now I'll write R equal to A plus, I'm going to use the integer function or the int function to convert my B to an integer, and then I'll print R again. Let's do this. There you go. So here we have converted my string value to a numeric value of 2, and this time it works fine. So 7 plus 2 is 9. Okay. Now let's see how you can convert a float value or a floating number into an integer number. Let's say I have a variable called A which has a value, let's say 77.9, and I'm going to create another variable called int underscore A, and I'll pass this to my integer function. So it has int of A. Now let's print int underscore A. So you have 77. So my integer function has truncated the decimal point value that had 0.9. If you want to check the type, you can use the type function. I'll write type of int underscore A. So it gives us integer. Now you can also convert an integer to a floating point value. So if I have a variable called A that has a value of, let's say, 50, and if I write float underscore a equal to, I'll use the float function to convert the variable a to a floating point value, and let's print float underscore a. So it gives us 50.0 instead of 50. You can also check the type of float a. It gives you float. Okay. Now you can also convert an integer to a complex number. Let's say I'll take the same value equal to 50. I'll write comp underscore a, which stands for complex a. I'll use the complex function and pass in my variable, that is a. Now let's print comp underscore a. So it gives us 50.0j. So 50 is the real part and 0j is the imaginary part. You can also convert an integer to a string. I'll take the same value, let's say 50. I'll write str underscore a equal to str of a. So I'm using the string function to convert my integer to a string. Let's print str underscore a. It should be an underscore and not an hyphen. Let's run it. There you go. You have 50 within single quotes. You can also check the type of a. str underscore a, it gives you string. Cool. Now we learn how to convert a string to a tuple. So let's say I have a string that has India as its value. If I write ts equal to, I'll use the tuple function and pass in my variable, that is s, and then we'll print ts. You can see here Python has converted my string s, which had India, into a tuple of individual elements, and my tuple is present inside brackets. Cool. Now similarly you can convert a string to a list. I'll use the same string s equal to India, and then let's say I want to convert it to a list. I'll use L1 equal to followed by the list function, and inside the list function I'll pass in my variable, that is s, and let's print L1 and see the difference. You see here my string has now been converted into a list. You can also check the data type of L1 or the object type of L1. It returns you list. Similarly you can also check the type of ts. It gives you tuple because we converted that string to a tuple. Now let's explore how you can convert a tuple to a list. Let's say you have a tuple called t and it has a list of names. Let's say John, we have Mary, then we have, let's say, Mark. Now to convert into a list, we'll use the list function again. Let's say L2 equal to list of t, and let's print L2. So this is a list because it is present inside square brackets. You can check the type of t. So t is a tuple, you see here. If I change this to L2, it gives you list. Cool. Now moving to the next section where we'll see how to convert integer to binary. Suppose I have a variable called a equal to 10, then I have b equal to bin of a. Let's say we have another variable which is c, and here I want to convert my integer into a hexadecimal value or a octadecimal value. For that you can write d equal to, use the OCT function for octadecimal value. Okay, now we are going to print them one by one. So I'll write print of b, print of c, and then we'll print what is there inside d. We'll run it and you can see the results here. So binary of 10 you see here, hexadecimal of 10 you see the value here. This is an hexadecimal value. Then we have the octadecimal value of A. Okay. Now moving to the final section of this demo. Now you can convert a number to its corresponding ASCII character. Let me show you how to do it. Suppose I have n1 equal to 76. Now if I write chr of n1 and run it, it gives me L. Now let's see our ASCII table. So this is my ASCII table, and for 76 you can see here the character is L. So this chr of n1 will return the corresponding ASCII character for that particular number. So here 76 belongs to L. Let's say we have another number n2 equal to, let's say, 100. Now if I write chr of n2 and run it, it gives me lowercase d. We'll see the table again, and if you see for 100 we have lowercase d. Now here you have a list of characters. These are special characters. You have uppercase characters, you have @ you have numbers. Each of them have their own ASCII values. Cool. Now you can convert string character into Unicode values. Now let me tell you what Unicode value is. So computers on a basic level deal with numbers. So letters that appear on computers are stored by computers as a list of numbers. So the Unicode standard provides a unique number for every character and supports multiple languages and all special characters. So let's say I have a string S which has the value of capital A or uppercase A. If I write R, which stands for result, equal to ORD, so this is the function which converts a string to a Unicode value. I'll write ORD of S and will print R. If I run it, it gives me 65. So 65 is the Unicode value of A. You can also have digits. Let's say I have 7. I'll run it. So 55 is the Unicode value of the string 7. Let's try for any other letter. Let's say V and run it. You have 86. Okay. So that brings us to the end of this demo session.
First, we will learn different number data types in Python. Then we will learn type conversion between number data types, and after that we will understand how to represent binary, hexadecimal and octal numbers in Python, and then we will understand different number functions in Python. A programming language needs to have support for numbers to carry out calculations. In Python, the numbers are categorized into different data types. Types are implemented in Python as classes. There are 3 numeric types in Python: int for integers, float for decimal numbers, and complex for complex numbers. Let's explore these data types in Jupyter Notebook. I have opened my Jupyter Notebook, and now let's see different data types in Jupyter Notebook. For example, first we'll assign a number to a variable. Num variable equal to 7, and now we will check the type of this num variable. For that we'll write the command type round brackets num round bracket close, and then we'll run this command. We will get int as the data type. Now we will assign a decimal number to the num variable. That would be num equal to 7.7, and now we will check the type of the num variable. And run this command. What we get is the float as the data type for the num variable. Now we will assign a complex number to the num variable. And we will check the type for this num variable and run the command. We will get the complex data type as the result. Now, if you want to get the real part of this complex number, you just have to write the command num.real and just execute the command. You will get 6.0 as the real part of this complex number. Here you can see you just code the number in float data type. The complex number in Python are stored in float data types, whether it's the real part or it's the imaginary part. Now we'll see the imaginary part, num.imag, and now you will run this command. You will get 7.0. Here also you can see that the imaginary part is also stored as float in Python for complex number. Now we will perform different arithmetic operations with these data types. First we will mention arithmetic operations. Now we will assign numbers to the variables and perform different arithmetic operations. For that we will assign 17 as a number to the variable num1 equal to 17, and the second variable num2 we will assign the number 25. And now we will perform different arithmetic operations. First we will start with addition. So we will write the simple command that would be print num1 plus num2 and just run that command. You can see the result as 42. It's as simple as that in Python. You just have to write print and in round brackets just write the operation you wanna execute. Now we will see the subtraction part. We will write print num2 minus num1 and execute this command, and we will get the result as 8. Now we will see multiplication. Print num1 into num2 and execute this command, and we will get the result as 425. Now we will divide. Print num2 divide by num1 and execute this command, and we will get 1.47. Here you can see, as we have assigned int values to the num1 and num2 variable, we got the result for addition, subtraction and multiplication as int data type only. But for division, we got it as float. This is because Python always gives the output for division in decimal numbers only, just to have minimum accuracy loss. So, if you want to just get the output of the division as an int value, you just have to perform this print num2 and 2 slash signs and then num1 and then execute the command. You will get 1 as the output. So to just get int as the output of the division, you can use 2 slashes. Next command we'll see is to raise a number to another number. So to just get 2 to the power of 4, we'll write the command print 2 asterisk symbols and 4 and just execute this command. You will get the output as 16. We got 2 to the power of 4 by just using 2 asterisk symbols. Now to get the remainder of the division, we just have to use the modulus symbol. So for that, print 4 modulus 2 and just execute the command. You will get 0 as the remainder. You can perform the same operations on float numbers and complex numbers. Now we'll see an arithmetic operation on complex number. So we will assign a complex number to a variable, that would be g equal to 1 plus 5j, and another variable we will assign the value 2 plus 3j, and we will assign the operation I equal to g slash h, that is division, and print the output and we'll execute the command, we will get the following result for the division of two complex numbers. Now we will see type conversions in Python. For that we will move. There are mainly two types of conversions between numbers in Python. First is using arithmetic operations, that is implicit type conversion, and second is using built-in functions, that is explicit type conversion. Let's understand the concept of conversion with the help of Jupyter Notebook. So here we will write first conversions. First, we will assign a number to a variable, that would be a equal to 196, and we have seen in the previous examples that its type is int. Now if we put this number into double quotes, and now we will check its type, that would be type a, and run the command, we will get it as string. So in Python, when we just put a number in double quotes, it will see it as a string. And to get this number as an int, we just have to use explicit type conversion. For that we will write b equal to int a, and now we will check its type b, and run the command. We will get int as the data type for the b variable. The a variable is still the string data type, and b variable has now turned as int data type. And now to turn a as a float data type, we can write c equal to float a, and check its type c, and run the command, and here we can see that it has turned into the float data type. So a is still the string data type, but c has been converted the a variable into the float data type. We can also convert the a string data type into complex data type. Just we have to write t equal to complex, and in brackets we have to write a, and we can check its type, and we can print the t complex number, and we have just execute the command, and we can see that the complex number is 196 plus 0j. And we can also check its type by just writing print type d, and we will run the command, and we can see that the class is complex for the variable d. We can define the complex data type by different methods. One of the method is we just have to write print complex, and in round brackets we just have to assign both real and the imaginary numbers, that would be 3, 6, and just execute the command, and here we got a complex number, that is 3 plus 6j. Now we have seen the explicit type conversions. Now we will see some implicit type conversions, that is using arithmetic operations. For that we will assign a float number, that would be 2.6, to a variable a equal to 2.6 and b equal to 6, and we will assign an arithmetic operation, that would be c equal to a plus b, and print the output and execute the command. By using just arithmetic operations, we have seen that the addition of a float number and the integer number turns out to be a float number. So now we have seen the implicit type conversion example. Now we will see the representation of binary, hexadecimal and octal numbers in Python. All the integer numbers can be represented as binary, hexadecimal and octal. To represent it as binary in Python, we have to prefix it by using 0 small b or 0 capital B. And for octal, we can prefix it by using 0 small o or 0 capital O. And for hexadecimal, we can use 0 x or 0 capital X. Let's see this representation in Jupyter Notebook. First we will write representation of binary, hexadecimal and octal numbers. Now, we will first see binary to decimal conversion. For that, we will first write 0 b 1 1 0 1 1 0 0 0, and then we'll just run it and see 216 as the decimal conversion of this binary number. Now we'll see the same for the octal. For that we'll write 0 small o 12 and just run this command, and we can see that it has turned 10 in the decimal number system. For hexadecimal, we will write 0 small x and 12 and just run the command, and we can see 18 as the decimal conversion of the hexadecimal number system. We can also use 0 capital X 12 and just run the command. We'll see 18 the same output as of 0 small x 12. Let's see some operations with fractions. For that, first we will comment fractions. Now we will import the fraction module. For that, we'll write from fractions import fraction as f, and first we will execute the addition operation for fractions. For that we'll write print f 1, 3 just for the fraction. Numerator would be 1 and the denominator would be 3. Now we'll write the operation addition, and f the second fraction, that would be, okay, we will write the same only, 1, 3, and on execution of the command we will get 2 by 3 as the output. We can also perform different operations. Okay, we will just see the reciprocal of the fraction. For that we will write print 1 upon f 5, 6 and just run the command. Here we can see the reciprocal function that would turn out to be 6 by 5. Now we will explore different number functions. First one that we would explore would be absolute. Absolute function would turn any negative number into the positive number. For that, we'll just assign a number that would be x equal to minus 9.8, and we will just apply the absolute function abs on the variable x and just run the command. Here we can see that it has turned x equal to minus 9.8 to 9.8. Now we will see some different functions. For that we will import the math module, import math, and we have different values stored in the math module. For example, pi, we will print the pi value, print math.pi and run the command. Here we can see the value of the pi 3.141592653589793. We also have exponential value in math module. For that we will write the command print math.e and execute the command. Here we will get the value 2.718281828459045 for the value of e in the math module. Now we will also see exponential to the power 10. For that we will write the command print math.exp round brackets 10 and execute the command. We will get the value 22026.465. We can also perform log operations. For that we will write the command print and we will get the log of 1000 to the base of 10. For that we will write math dot log to the base 10. The value would be 1000 and we will execute the command and we will get 3.0. We can also get the factorial by the math module. We will write print math dot factorial of 6 and we'll execute the command and we got the factorial of 6, that is 720. Now if we want the square root of a number, we'll write the command print math.sqrt and in round brackets we will write the number for which we need the square root. We will write 25 and execute the command and we will get 5.0. This square root number gives the float number as its output. And we can also find out the maximum numbers from a bunch of numbers. For that we have to write the command max round brackets and the bunch of numbers from which you want the maximum value, like 1, 33, 55, 7, 99, and just execute the command. You will get the maximum number, that would be 99. And if you want the minimum number, you can write the command min and in round brackets just write the bunch of numbers 1, 3, 66, 88, 7 and just execute the command. You will get the minimum number, that would be 1. Now we will see the ceiling function. For that we will write the command print math dot ceil and in round brackets we'll write the number for which we want to use the ceiling function minus 43.5 and execute the command. You will get minus 43. So what the ceiling function does is it would give the highest value or the greatest value for the number we have entered in the ceiling function. Now we'll see the floor function. For that we'll write the command print bracket math.floor and we'll write the number for which we want to use the floor function minus 43.5 and execute the command. We'll get minus 44. So the floor function will give the output value just below the or just the lowest value of the value entered by us in the floor function. Now we'll see the power function. For that we'll write the command print math.pow and in round brackets we'll write the number 2 and the power which we want, that would be 6, and just execute the command. Here we can see that 2 to the power 6 we have got the output value as 64. Now we'll see some trigonometric functions. First we'll see cos of x. Like Python number method cos returns the cosine of x radians. For that we'll write the command print math dot cos of 0 and just run the command. It will give 1 as the output. So this method returns a numeric value between minus 1 and 1, like which represents the cosine of the angle. We will see another example for cos. For that we'll write print math.cos and in brackets we'll write the angle math dot pi, and we'll execute the command and we'll get the output as -1. Now we'll see tan trigonometric function. So the Python method tan, it returns the tangent of x radians. For that we will write the command print math.tan of angle 0, and we will execute the command. We will get 0 as output. This method returns a numeric value between -1 and 1, which represents the tangent of the perimeter x. We will also see another example for tan. We will write print math.tan math.pi by 4 and execute the command. It gives us 0.99999, that turns out to be 1. Now we will explore some random number functions. For that we will write the command import random and import the random module. Now we'll see the first function, that would be randrange. For that we'll write the command print random dot randrange, and in circular brackets we will write the range from which we want the random number. That would be 10, 20, and execute the command. Here we got 12 as the random number. Now we will define a list, that would be x equal to square brackets 1, 2, 3, 4, and 5. Now we'll see another function, that would be choice, and it would give any random number from string, list, or tuple. So for that we'll write the command print random dot choice, and in circular brackets we will write, or we will pass any list, string, or tuple. Here we will pass this list x and execute this command. We will get the random number 3.
Okay. So we'll understand what is a string in Python and how to create strings in Python. Then we look at the different string methods and how to perform string indexing, and all these we'll see with the help of hands-on demonstrations on the Jupyter Notebook. So let's understand what is a string. So a string in Python is an object that represents a sequence of characters. In Python we have str as the data type of string. Now you can create strings using single quotes or double quotes. So here is an example where we have used a single quote to write a string. So our string is Hello India, which is inside a single quote. Below, if you see, we have the same string written within double quotes. So these are the two methods in which you can create strings in Python. Now you can also use triple quotes, which are generally for multi-line strings or doc strings. So here is an example. We have a string called str3, and the content it has is human psychology is an interesting subject. Now if you print the string, it will be printed in 2 lines and not in a single line. Now we'll be exploring much more in detail in our demo session, so please wait for a while. Next, we have string indexing. So if you want to extract a few characters from your string, you can use the indexing method. So in Python, a string starts with the index number 0. So here we have a string which is healthy, and the first element is present at the 0th index. So at the bottom you see the forward index, on the top we have the reverse index or the negative indexes. So in Python, as I said, the first index is at the 0th position, so H is at 0, E is at the first index, A is at the second index, so on and so forth. Now similarly, if you look at negative indexing, it starts with -1 in reverse order. So we have -1 for y, -2 for h, -3 for t, and so on and so forth. Now let's head over to our Jupyter notebook where we'll learn about strings in Python in detail. Okay, so I'm on my Jupyter notebook. First, I'll create a new notebook. I'll click on new and then select Python 3. Okay, so here let me rename my notebook as strings in Python demo. I'll click on rename. Okay, now let's start with our first example. I'll create a variable called str1 that will have a string. You can see here I am using single quotes now. I'll write hi Sam. So here str1 is holding a string called hi Sam, and let's go ahead and print the string str1. I'll hit shift enter to run it. You see here I have my string printed hi Sam. Now if you want to check the data type that str1 holds, you can use the type function, and inside the type function I'll pass in my variable str1. If I run it, you see here it gives us str, which means it is of type string. Now let's create another string str2 using double quotes this time. So I'll write, let's say, hello Angela. I can give exclamation mark. Okay, now let's just print the second string. You see here this is my second string, which is hello Angela. If you want, you can also use the print function here and run it. You get hello Angela. Now let's write a multi-line string using triple quotes. So I'll write str3 equal to, I'll use triple quotes, and then I'll say hi everyone. Go to the next line. I'll write today we will learn about. I'll go to the next line and I'll write strings in Python. Then I'll again give triple quotes to close my string, and let's just print this str3. If I run it, you can see it here. I have now written a multi-line string. Hi everyone, today we will learn about strings in Python. Let me just add a s. There you go. Okay, now coming to the next topic, we'll learn about indexing. Alright, let me declare a string str1 which has value as Simplilearn. Now to use indexing and extract certain items in a string or values in a string, you can use square brackets, and inside the square brackets you can give the index position. For example, if I write str1 and in the square bracket I'll give, let's say, I want to find the element or the value present at the 0th index. Let's run it. It gives me s, because as we learnt in the slides, the first index in a string starts with the 0th number. So I have s in my 0th index, so hence it has printed s. Let's explore a few more. If I write str1 of, let's say, I want to know what is present at the 3rd index. If I run it, it gives me p. You can check now. So s is at the 0th index, I is at the 1st index, m is at the 2nd index, and p is at the 3rd index. Let's say I'll write str1 of, let's say, 12. We can see the difference now. It gives us an error. It says string index out of range. The reason being, Simplilearn does not have any value at the 12th index, so it's printing an error saying string index out of range. Now let's change this to 6 and see what we have. At the 6th index we have L. If you count here, S is at the 0th index, I is at the 1st index, M is at the 2nd index, P is at the 3rd index. The first L is at the 4th index, again I is at the 5th index, and then we have the second L at the 6th index. So we have L printed here. Now let's see how to use a slicing operator using colon. I'll write slicing operator. Okay. I'll use the same string str1. Let me print it once again. We have Simplilearn. Suppose I write str1 within brackets. I'll use the slicing technique now. I want everything starting from the 0th index. I get Simplilearn. So here I am printing everything that starts with the 0th index. Next, let's see what we have if I print my string str1 and write 1:6. I'll run it. It gives me IMPLI. So if you notice here, I want to extract whatever is present from the first index till the 6th index, but excluding the 6th index. So in Python, the indexing method or the slicing method will exclude the last index. So here, if you see, I is at the first index, M is at the second index, P is at the third index, L is at the fourth index, and then we have I at the fifth index, and we have excluded the sixth index, that is the second L. So hence it has returned us IMPLI. Now similarly, we'll see another example. I'll write str1. This time I'll use colon 6. If I run it, you get simply. So it has printed everything starting from the 0th index till the 6th index, but excluding the 6th index. So you have all these values from 0th index till the 5th index. Okay. Now you can also reverse a string. For that you can use negative slicing using 2 colons. If I write print str1 and within square brackets I'll give colon -1. Let's run and see the result. There you go. If you see this, it has printed my original string, which is Simplilearn, in reverse order now. So this is a very simple method. If someone asks you to reverse a string or print something in reverse order, you can use the negative slicing method. Now let's explore a few more examples. If I write str1 and within brackets I'll give -1 and run it, it returns me n, because in my original string, if I go on the top, I have n at the last index, which is here -1. Similarly, let's see what we have at -3. We have a here. If I go to the top, you see here n is at -1, r is at -2, and a is at -3, and hence it has given us a. Now let's say I'll write str1. I want to print -2 colon, and let's see the result. It has given us r and n. So here we are printing only the last 2 elements in the string, hence we have used -2. Okay. Now Python does not allow you to reassign values in a declared string. Let me show you what I mean. I'll give a comment here. Reassign strings. Suppose I have the same string str1, which is Simplilearn. Say I write str and I want to replace the value present at the third index with, let's say, O. And if I were to print str1 now, Python will throw an error saying str object does not support item assignment. So it is immutable, like tuples, where you cannot reassign any values. You can also delete a string. Say I have another string called str2, which has a value of, let's say, Python programming. You can use the del keyword and write str2, and now let's print str2. You will see that it says name str2 is not defined because we have already deleted str2 in the above step. Okay. Now let's go ahead and see some of the important string operations. Okay. Say I have str1 which has Python. Now one thing to note, I am using either single quote or double quote. You can use whatever you want. Let's say I have another string which has programming. So these are my two strings. Let's perform a few operations on these strings. Say I write str1 multiplied by 3 and I'll run it. You can see here it has printed Python thrice because I have said str1 multiplied by 3. So in str1 we have Python, and multiplying 3 returns Python 3 times. Now let's say I'll write str1 plus str1. It has merged Python twice, so I have Python and Python repeated. Let's say I write str1 plus str2. We'll see the result. It gives us Python programming. So basically, if you use the plus operator with two strings, Python will perform a concatenation operation, which means it will merge both the strings. Now if you want to find if a specific character is present in a string or not, you can use the in operator for this. Let's say I'll print whether W is present in str1. If I run it, it gives us false because in str1 we have Python, and if you see here we don't have the letter W in Python, and hence it has given us false. Now let me copy this. I'll paste it here. Let's try whether O is there in string 1 or not. It gives us true because we have an O here. You can see here we have an O. Similarly, let's say I want to find whether LA is there in string 2 or not. If I run it, it gives us false because in string 2 we have programming and we don't have any LA present in programming. Let's say we'll see whether RO is present in string 2 or not. This time it returns us true because if you see here we have RO in programming, and hence it has given us true. Now you can also print a raw string using the R alphabet. So the way to write is I'll write R, give a single quote. Let's say I'll give a location C drive 2// and let's say I'll write Python 3.7 and run it. It gives me a raw string. Now let's see some formatting methods. I'll write a comment saying format methods. Okay. I'll write a print statement. I'll give double quotes, and here let's see the first example where I'm using curly braces. I'll write and I'll give another curly braces. You'll get to know what I'm doing once I finish this. Let's say I have a message, both are best friends. Then I'm going to use my format method, and inside this I'll pass in my two values for these braces. So these curly braces will be replaced by the words that I pass in, or the values that I pass in within the format method. So here I'll write, let's say, James, and my second person would be Brad. Now let me run it. You see here, what Python does is it replaces the curly braces with the names that I have passed within the format method. So it takes the first argument for the first curly brace and the second argument for the second curly brace. So my statement becomes James and Brad both are best friends. Now let me just copy this. I'll show you another example. This time I'll give 1 and 0 inside the curly braces. Now if I run this, there you go. So here James is at the 0th index. So this is basically a list where James is at the 0th index and Brad is at the first index. So if I write 1 and 0, it will take Brad here, and then for 0 it will take James. So now my message becomes Brad and James both are best friends. Now let's try out another example. I'll paste it here. I'll use two variables, let's say A and B, and inside my format method I'll write A equal to James and I'll assign B as Brad. Let's run it. There you go. We have our message printed. James and Brad both are best friends. So here A refers to James and B refers to Brad. Cool. Let's explore another example. I have a variable called name and that has a value Angela, and then I have another variable, let's say salary of $100,000. I'll use a print statement. I'll print a message. Her name is, I'll use %s for string, give a \n for next line, and I'll write her salary is, then I'll write %d, this is for numbers, and then I'll give another percentage, and let's say I'll write my two variables name and salary. Let's see what we have in the result. I need to close my double quotes here. I'll exclude it from here. Let's run it. There you go. So I have my message here. Her name is Angela. Her salary is $100,000. I'll just delete the space here. We'll run it again. Okay. Now this %s refers to the name, and we have declared her name is Angela. So my first statement or the message becomes her name is Angela, and the next message is her salary is %d. So %d here refers to the salary where we have 100,000. So the next message is her salary is 100,000. So these are the very basic and important print methods or formats that you can use while working with strings. Now we'll explore a few functions that are readily available in Python to operate with strings. I'll take my same string str1 as Simplilearn, and then I'll create another variable called str2. I'll write str1 dot, I'm going to use the capitalize method. Okay, let me make one correction. I'm going to write everything in lowercase so that we can see the difference, how we can capitalize the string. So I'll write my print statement, print old value. This is going to my message. I'll give a colon followed by my double quotes, and I'll pass in my variable str1. Okay, now I'll copy this. In the next line we have a new value as str2. Let's run it and see the difference. There you go. So here my old value has Simplilearn in all lowercase, but when I used the capitalize method, so Python has converted my first letter in Simplilearn to uppercase or capital keys. Cool. Now let me copy this. I'm going to use the same example for the next three methods. Let me show you how the case fold method works. This time I'm going to pass my input string in all uppercase. I'll write Simplilearn in uppercase, and instead of capitalize I'll write case fold. Let's run it and see the difference. There you go. Initially we had Simplilearn in uppercase, and now we have converted into case fold, so all the letters are in lowercase. Now moving ahead, you can also use the upper method to convert a string into uppercase. Let's say I have a string where few of the letters are in uppercase and few of the letters are in lowercase. This time I'm going to convert everything into uppercase, so I'll use the upper function instead of case fold. Let's run and see the result. There you go. So this time Python has converted my original string into uppercase. And likewise you can also use the lowercase. Instead of upper, if I write lower, you see here everything has been converted to lowercase. Cool. Okay, now I'll show you how the title method works. So in title method, all the words, basically the first letter of all the words will be in uppercase. So suppose I have a string which is Simplilearn company. So I'll write, let's say this is my string, and I'll convert my str1 to title case. Let me run it. So this is the difference you can see. The first letter of the first word is uppercase. Again, the first letter of the second word is also in uppercase. So this is how the title case works. Now you can also count the occurrences of a particular element in a string. Suppose I have string 1 that has Python programming. In str2 I'll write str1 dot and use the count function to count how many times, let's say n, the letter n is present. Then I'll print saying occurrences, give a colon here, and then I'll pass in my variable, that is str2. So this will count the number of times n is present in my original string. So if you see here in Python programming we have n present twice. Similarly, let's check for G. The letter G is also present twice. Let's see for Y. Now Y is present only once, which you can see here. Okay. Next, let's see how the replace function works in Python. I'm giving a comment as replace. So let's say I have a string str1 which has Hamburg is located in France. So Hamburg is a city which is actually located in Germany and not in France. So using the replace method, we are going to replace France with Germany. So what I'll do is I'll create another string str2 equal to, I'll write str1 dot, and then I'll use the replace function and I'll say replace my string France with country Germany, and then we'll print str2 and see the result. There you go. So we have changed Hamburg is located in France to Hamburg is located in Germany. Now coming to the final method that we are going to explore in this Python strings demo, which is using the split function. Okay, so you can split the values or each word in a string as separate words and store it in the form of a list. So I write str1, I'll just copy this, I'll paste it here, and I'll change France to Germany because Hamburg is actually present in Germany and not in France. And then I'll create another variable called str2. I'll write str1 dot and then use the split function. Now let me print both the strings. First I'll print str1 and then I'll print str2. If I run it, you see my original string was Hamburg is located in Germany, and then using the split function we have segregated or divided each of the words present in the original string into separate words, and this time it is present in the form of a list. Okay. Let's see what operators are in Python. Now operators are generally used to perform operations on values and variables in Python. These are standard symbols used for logical and arithmetic operations. The value that the operator operates on is called the operand. So here on your screens you can see the different types of operators available in Python. First we have arithmetic operators. So arithmetic operators are used to perform mathematical operations. It returns either true or false according to the condition. So these are the comparison operators. You have less than, greater than, less than equal to, greater than equal to. We have not equal to, and we have equal to equal to. Third, we have assignment operators. So assignment operators are used in Python to assign values to variables. So these are the assignment operators. You have equal to, you have plus equal to. So for example, you have a variable called x, and if you say x plus equal to 7, this means it is x equal to x plus 7. Similarly, if you say x minus equal to 7, this means x equal to x minus 7. And similarly, you can see the other assignment operators here. Next up we have the logical operators. So logical operators are used in the expression evaluation to make a decision. If both the expressions are true, then the condition will be true for an AND operator. For an OR operator, if one of the expressions is true, then the OR condition will be true. Now for NOT, if an expression A is true, then NOT A will be false. We also have bitwise operators. So bitwise operators act on operands as if they were strings of binary digits. It acts on bits and performs bit by bit operation. So hence it is called bitwise operator. So here each value is evaluated as zeros and ones. Then we have identity operators. So identity operators are used to check if two values are located on the same part of the memory. Two variables that are equal does not imply that they are identical. We'll understand each of these operators in the demo session on the Jupyter Notebook. And finally we have membership operators. So membership operators are used to test whether a value or variable is in a sequence. So you have is and is not as identity operators. In membership operators we have in and not in. Now let's head over to our Jupyter Notebook and we'll see and explore all these operators one by one. So I am on my Jupyter Notebook, operators in Python. So let's first start with arithmetic operators. I'll just give a comment here saying arithmetic operators. Okay. First up, we'll see the addition operator. For that, let me assign two variables. So I have assigned a variable x to a value 10, and let's say we have the second variable y equal to 4. Now if I say print x plus y, it will perform an arithmetic operation, that is addition, and will sum the result of x and y and gives me 14, because 10 plus 4 is 14. Now let's say I'll write print x minus y, that gives me 6 because 10 minus 4 is 6. Similarly, you can have multiplication as well. So I'll write x asterisk y, that gives me 40 because 10 multiplied by 4 is 40. Similarly, let's say x divided by y. It gives me 2.5, which is basically the quotient of these two operands. Alright. Now, if you were to find the remainder, you can use the modulus operator. So I'll write x modulo y. It gives me 2. So you divide 10 by 4. The remainder is 2. Now you can use the double asterisk operator, which is basically known as power. So the left operand is raised to the power of right. I'll write print x, give 2 asterisks, and then say y. It gives me 10,000. So what basically Python does is it will raise 10 to the power of 4. So 10 is multiplied 4 times and the result is 10,000. You can also try out another example. Let's say 2 raised to the power of 4. This gives me 16. If I say 2 raised to the power of 3, that is 2 cube, and the result is 8. You can also perform floor division. So floor division results into whole number adjusted to the left in the number line. So if I write print x, and floor division is given by 2 forward slash, then I'll write y, that gives me 2. So it returns a whole number. A generic division gives me 2.5, that has the floating point value, but a floor division will give me a whole number adjusted to the left on the number line. Alright, so these are some of the basic arithmetic operators that are very popular in Python. Next, we'll move on to assignment operators. I'll give a comment as assignment operators. Okay. Let's assign a value x equal to 7. So here we are assigning the value of 7 to x, and your equal to is an example of assignment operator. Now if I print x, it will give me 7. Now let's say I'll again write x equal to 7, and in the next line I'll write x plus equal to 3, and will print x. So what Python does is it adds 3 to my original value that x holds, that is 7. So here x plus equal to 3 means x equal to x plus 3. So x equal to x plus 3 can be written as x plus equal to 3. Similarly, you can also write x minus equal to something. Say x equal to 7, and then I write x minus equal to 3. Then we'll print x. This gives me 4 because we are subtracting the original value of x by 3. So here x minus equal to 3 means x equal to x minus 3. Okay. Similarly, let's say I'll write x asterisk equal to 3. If I run it and print the value of x, it gives me 12 because our previous x value was 4, and now we have multiplied x by 3. So x value now becomes 12. Let's say I'll write x divided by 3, and I'll print x. It gives me 4.0. This is a floating point number. So we are dividing 12 by 3, and the result is 4.0. Cool. If you want, you can also perform an exponent operation or a power operation. So let's say I have x equal to 7, and then I write x double asterisk equal to say 2, and then we'll print x. Okay, there is an error here. Let's debug the error. I have put a space here. Let's delete that space. You have to keep this in mind. Now let's run it. There you go. So 7 raised to the power of 2, which is basically 7 square, is 49. You can change the values and run other examples. Let's say 10 raised to the power of 3. We have 1000 as the result. Okay. Now moving ahead. Now we'll understand about comparison operators. So I'll give a comment as comparison operators. Okay. Let's say I have x equal to 7 and then I have y equal to 3. If I print x equal to y, it will give me false. The reason being the value that x holds is not equal to the value present in y. These are two different values that x and y hold. So x is not equal to y, and if we print x equal to y, it will give us false. Now I'll just copy this code. I'll print it here, and instead of equal to, I'll give not equal to. So not equal to is represented by an exclamation mark followed by an equal to. If I write x not equal to y, this gives us true because x and y are two different values and they are not equal. I'll print my code again, and this time let's say I'll write x greater than y. It gives us true because 7 is greater than 3. If I write x less than y and hit shift enter, that gives me false because 7 is not less than 3. I'll print the code again. This time we'll see if x is greater than equal to 3. If I run it, it is true because 7 is greater than equal to 3. And now let's check for less than equal to. This is false because 7 is not less than equal to 3. Okay, so these are some of the basic comparison operators that are available in Python. Now moving ahead, we'll see how logical operators work in Python. Okay. First, we'll look at the AND operator in Python. Suppose I have a value of 7 stored in x and then I have a value of 12 stored in y. If I write print x greater than 2 and y less than 10, let's run it and see the result. It gives us false. Now AND logical operators will return true if both the conditions are true, and it will return false even if one of the condition is false. So here x is greater than 2, which means 7 is greater than 2 is true, but y less than 10, which is 12 less than 10, is false, and hence our entire expression becomes false. Next, let's say I have x equal to 5 and then I'll print x greater than 3 or x less than 10. If I run this, it returns us true. The reason being x greater than 3 is true, which means 5 is greater than 3, that is true, but 5 is not less than 10. But since one of the conditions is true, so the OR operation in Python returns us true. Now let's see another example. I'll write x equal to 5 and y equal to 10. I'll print x greater than 10 or y less than 20. If I run this, it returns true. So let's see our expression. X greater than 10, that is 5 greater than 10 is false, but y less than 20, so 10 is less than 20 is true. So our OR operation will give us true since one of the condition is true. Now moving to the next logical operator, we have NOT. I'll give an comment here as OR, and now we'll see NOT. Let's say I have x equal to 5, and then I'll print x greater than 3 and x less than 10. This should ideally give us true. The reason being x is greater than 3 and x is less than 10. Let's run and verify. Okay, so this is true. Now let me copy this and I'll paste it in the next cell. Now I'll replace my above print statement with a NOT operator, and we'll close our print function with another bracket. Now let's run it. So this will give us false because my expression evaluates to true, but not true is false. Okay, now moving ahead, let's discuss identity operators in Python. Alright, so we'll start by assigning a value of, let's say, 505 to x, and then in y I'll have 500 plus 5, so which is also 505. So x and y hold the same value of 505. Now I'll print x comma y. So you can see here both the values are same, 505 for x and y. Now I'll use the logical operator, that is double equal to or equal to. I'll write x equal to y. This will give us true because x and y hold the same value of 505. But let's check with the identity operator. So I'll write x is y. If I run this, it gives me false. The reason being x and y both refer to objects whose value is 505. They are equal, but they are not referencing to the same object. Now this you can verify using the id function in Python. If I write id of x, this will give me the memory location that x has. You can see this is the memory location of x. Now if I write id of y, there you go. So this is a separate memory location in which y is holding the value of 505, and hence x is y is different, and hence it is false. Now suppose I write x equal to 100 and I have y equal to 200. If I write x is not y, this gives us true. The reason being x and y both are holding different values, so x is not y is true. Let's see another example. This time we'll define two lists. So I have a list called A that has value, let's say 5, 6, 3, 7, 1, let's say 9. And then I'll have another list that will also have the same elements. I'll copy this and I'll paste it here. Okay, if I write C equal to A, and then we'll print A is C. If I run this, it gives us true because we are assigning the variable A to C, and hence the memory locations are the same for both, and hence A is C gives us true. What if I write A is B? Now this gives us false. So here A and B are both less. They are equal but not identical. It is because the interpreter in Python allocates them separately in memory, although they are equal. Okay, now let's talk about membership operators in Python. I'll give a comment as membership operators. Okay, let's say I have a list A that has the above values 5, 6, 3, 7, 1 and 9. I'll copy this and I'll paste it here. Okay, I have another list B that has different types of elements. We have 4, next element is Python, then we have 2, 7, let's say Simplilearn, and then I have 9. I'll run this first. So I have my two lists A and B. I have printed them. Let's explore how the membership operator works. So we saw in the slides in and not in are two membership operators. If I write 5 in A and run it, it returns me true because you see here 5 is present in A and hence 5 in A will return true. What if I write 55 in A? This gives us false because you see here in the list A we don't have an item 55 in A. So it gives us false. What if I write 4 in B? This gives me true. You see here in B we have the element 4, so 4 in B is true. One thing I wanted to show you is what if I write Python in B? You see here it gives us false. Though we have Python in our list B, but the Python I'm trying to check is not present in B. The reason being here Python is written in lowercase, but what I'm checking Python P is in uppercase, so it is case sensitive and hence this gives me false. Let's say I'll declare a dictionary y equal to, and within curly braces I'll give my key A and I'll assign the value of India. Let's say I have another key B and that has a value, let's say USA. Now if I check A in Y, it gives me true because your key A is present in Y. Now what if I check India in Y? Now this gives me false. So here the membership operator won't work on the values, it only works on keys in a dictionary. Now let me go ahead and change the keys to numbers. I'll give 1 that has India and the second key I'll have 2. Now if I change A to 1, it will work fine. It gives me India, but if I write USA in Y, it gives me false. As I said, the membership operator won't work on the values, it only works on the keys in a dictionary. Cool. Now coming to the final section of our demo, we'll explore about bitwise operator. Okay. So Python bitwise AND operator returns 1 if both the bits are 1, otherwise it will return 0. So first let's see 7 ampersand 2. If I run it, it gives me the value of 2. So what Python does is, it will first convert the numbers 7 and 2 to their binary equivalents, that is in the form of zeros and ones, and then it will perform the bitwise AND operation. So 7 ampersand 2, the value is 2. If I write 3 ampersand 5, the value is 1. Again, it will first convert 3 and 5 to binary equivalents in the form of zeros and ones, and then it will perform the AND operation, the bitwise AND operation. Now the Python bitwise OR operator returns 1 if any of the bits is 1. If both the bits are 0, it will return 0. So if I write 10 or 5, it gives me 15. So first it will convert 10 and 5 to binary equivalents, and then it will perform the bitwise OR operation. Let's see another example. I'll write 4 or 8. I'll run it. So the bitwise OR operation gives us 12 as the result. Alright.
First, we will learn about the lists in Python, its characteristics, and explore it in Jupyter Notebook. Then we will learn about tuples in Python, its characteristics, and we will also explore tuples in Jupyter Notebook. After that, we will have a look at dictionaries in Python, its characteristics, and we'll head to Jupyter Notebook to understand the dictionaries. So let's start with lists in Python. Imagine you have different values. You have numbers, you have strings. Now, if you want to group them together, you can do this job in Python with the help of lists. Or you have worked with arrays in any other language like C++ or Java. This is the similar stuff in here, which is list. A list can be defined as a collection of objects, values, or items of different types, and these collections are enclosed within the square brackets and are separated by commas. Let's understand this with the help of an example. We will create a list and name it as list1 and insert the elements in square brackets and separate them with the help of commas. List1 equal to square brackets 1, comma, Adam, comma, 107, comma, USA. And in lists, we have our first element at 0th index, and we have 1 at 0 index, Adam at 1 index, 107 at 2nd index, USA at 3rd index. And talking about the reverse index, it starts with -1 index value. We have USA at -1 index value, 107 at -2 index value, Adam at -3 index value, and 1 at -4 index value. We will explore the list with various examples in Jupyter Notebook in a while. Till then, let's look at the characteristics of lists. First, the lists are ordered. When we say that lists are ordered, it means that the items have a defined order, and that order will not change. If you add new items to a list, the new items will be placed at the end of the list. Second, elements of the list can be accessed by index values. Third, lists can store various types of elements, for example numbers, strings, or lists itself. Fourth, lists are mutable. The list is changeable, meaning that we can change, add, and remove items in a list after it has been created. Lists allow duplicate elements. Since lists are indexed, lists can have items with the same value. Let's have a look at some methods of lists in Python. The first one is append. It adds an element at the end of the list. For syntax, we can write list1 dot append, and in round brackets we have to write the element which we want to append. The next is insert. It adds an element at the specified position. Its syntax is name of the list dot insert, and in round brackets we'll write the index at which we want to insert the element and comma, and after that the element which we want to insert. Third is extend. It adds the element of a list to the end of the current list. Its syntax is list1 dot extend, and in round brackets we will add the element like list2 which we want to extend in the list. The next is index. It returns the index of the first element with the specified value. And its syntax is list1 dot index and the element which we want to fetch the index. The next is remove. It removes the item with the specified value. Its syntax is list1 dot remove, and in round brackets we write the element which we want to remove from the list. The next is sort. This method is used to sort the list. Its syntax is list1 dot sort. The next is reverse. It reverses the order of the list. Its syntax is list1 dot reverse. Let's move to Jupyter Notebook to explore these methods. Let's start with creating a list. We'll name the list as list1 and we'll create equal to, and we'll start with square brackets and we'll write our first element, that would be apple, comma, space, next element orange, comma, space, the next element banana, comma, space, the next element kiwi. Now we will get this list printed. For that we will write the syntax print, and in round brackets we will write the list name, that would be list1, and run the command. You can see here that the list is printed. Now let's create a different list with some different elements. List2 equal to, and in square brackets we will write apple. Now we will insert a list in a list. For that we will write a list in square brackets 8, 4, 6 and comma, the next element, that will write orange, the next element banana, now we'll print this list. To print this we'll write print, round brackets we'll write list2 and run the command. Here we will get the list 2 printed. We can access any element in the list. So for that we'll write the syntax print. We want to access the second element, that will be the third element from the list 1. For that we'll write the syntax print list1, and in square brackets we'll write the index 2 and run the command. We will get the third element from the list 1, that is banana. Now we will access an element from the list 2. For that we'll write the command print list2, and in square bracket we will write 1, and in square bracket we'll write 2 and run the command. What we get is 6. So to access an element from a list that is already inserted in a list, we have to write this syntax. So this syntax tells us that we will first access the first index element, that is 846, the list, and in that we will access the second index value, that would be 0, 1 and 2, that is 6. So this is the syntax to access an element in a list that is already inserted in a list. Now we will see a reverse index order. For that we will write the command print list1, and in square brackets we will write the index -1, and we'll run this command and we get kiwi as output. Now we'll see slicing in Python. We can access a range of items in a list by using the slicing operator. Now we'll see an example to see the slicing operator work in Python. For that we will write the syntax print list1, and in square brackets we'll write 1 slicing operator 3 and run the command. What we see is orange and banana as an output from the list 1. When you write 1:3, that is 1 slicing operator 3, it gives you the elements at index 1, 2 and not 3. So we get the output as orange, banana. Now we will see another example for the slicing operator. We'll write print list1, and in square brackets we'll write 3 and slicing operator. Run the command. Here we can get only kiwi. When we write a single number before slicing operator, it would print the value at that index value and all the other elements that are present in the list. But in this list we have only kiwi as the last element, so it would print third index value and not more than that. Now we'll see append function. For that we'll write the syntax list1 dot append, and in round brackets we'll write the element which we want to insert at the last of the list. We'll write guava and run it, and now we will print the list to see the result. Here we can see that guava is added at the last of the list. Now we'll see extend function. For that we'll write the index list1 dot extend, and in round brackets we will write in square brackets the particular elements we want to insert in the list. So we will write watermelon, and the next element we want to insert would be muskmelon. That would be in inverted commas. And we also want this list to be printed, so we'll write print list1 and execute this command. Here we can get watermelon and muskmelon added just after the list, just at the last elements of the list. Now if you want to delete a particular element from the list, you can delete it with the syntax del space the list name you want to delete the element, and in square brackets you will write the index for the element you want to delete. We have written the 5th index value, so we'll run this command and we'll get the list printed. We can see that the 5th index value, that is watermelon, is not there in list1. It's been deleted. Now you can also do this with another method, that is remove. For that we'll write list1 dot remove, and in round brackets we'll write the particular element we want to remove. We'll write that is kiwi, and we also want the list to be printed, so we'll write print in round brackets list1 and run this command. We get that the kiwi is being removed from the list1. Now there is another method, that is pop. We'll write that command print in round brackets, we'll write list1 dot pop, and we'll write the index value what we want to remove from the list, that is 1. And we also want the list to be printed, so for that we'll write the command print list1, and we'll run this command. Okay, we have not written the name of the list correctly, so now list1. Now so at the 1 index, that was orange, that has been removed from the list, and now this is the new list. Now we can see another method, that is clear, that removes all the elements from the list. So this we will apply on the list2 dot clear method, and we'll also write another command, that would be print list2 and execute this command. We can see that the list2 is empty now. All the elements from the list2 have been removed. Now we'll see another method, that is reverse. For that we'll write the command list1 dot reverse and round brackets, and we also want the list1 to be printed. For that we'll write the command print list1 and execute this command. Here we can see that the list1 is being reversed: muskmelon, guava, banana, apple. Now if you want a particular index element to be accessed, you can have the syntax. For that you can write that print list1 dot index, and in round brackets you just need to write the element for what you want to get the index, and just run this command. You will get the index of the element guava, that is 1. We have another method in list, that is count. So count is used to give the number of times the particular element is present in the list. So for that we'll write the syntax print print, and in round brackets we'll write the list name list1 dot count, and in round brackets we'll write the particular element for which we want to get the number of times that has been present in the list. We'll write muskmelon and run this command. It would give us the value 1 because it's been present in the list for only a single time. Now let's move to the tuples. So tuple is almost same as list. We can have different types of values in tuples. The difference in list is we can change value because list is mutable and tuple is immutable. That means you cannot change the value. A tuple can be defined as a collection of objects, values or items of different types, and these collections are enclosed within the circle brackets and separated by commas. Let's understand this with the help of an example. We will create a tuple and name it as tup1 and insert the elements in round brackets and separate them with the help of commas. So tup1 equal to round brackets, the first element is 1, comma, and the second element is Adam, third element is 107 and the fourth element is USA. Now, in tuples, we have our first element at 0th index and we have 1 at 0 index and Adam at 1 index and 107 at 2nd index and USA at 3rd index. And for the reverse index, it starts with -1 index value. We have USA at -1 value, 107 at -2 index value and Adam at -3 index value and 1 at -4 index value. We will explore the tuples with various examples in Jupyter Notebook. But till then, let's look at the characteristics of tuple. So the first is the tuples are ordered. When we say that tuples are ordered, it means that the items have a defined order and that order will not change. Elements of the tuples can be accessed by index. Tuple items are indexed. The first item has index 0, the second index has 1. Third, tuples can store various types of elements, that is, strings, arrays, and many other elements. The next is tuples are immutable. Tuples are unchangeable, meaning that we cannot change, add, or remove items after the tuple has been created. Next is tuples allow duplicate elements. Since tuples are indexed, they can have items with the same value. Let's have a look at some methods of tuples in Python. First, that is index. We can use the index operator to access an item in a tuple where the index starts from 0. Its syntax is the name of the tuple dot index and in round brackets we'll write the element for which we want to access the index. The second is slicing. We can access a range of items in a tuple by using the slicing operator. For that, we'll write the syntax tup1 and the range for which we want to slice the tuple. The third is concatenation. Here we will add two tuples, that is, we just have to write the name of the tuples to add them and we'll place the plus operator just between them. The next is repetition. We can have the same item multiple times in a tuple. For that, we will just have to write the syntax, the name of the tuple and the multiplication operator into the times we want that value to be present in the tuple. The next is count. It returns the number of items a specified value occurs in a tuple. So for that, we have the syntax tup1.count and in round brackets we will just write the element for which we want to count the number of times that specified value has been occurred. We also have another method, that is index. It searches the tuple for a specified value and returns the position of that where it was found. Now let's move to Jupyter Notebook to explore these methods. So let's start. First we will comment, that would be tuples, and we will move to the next column, and first we will create a tuple. For that we will write the command tup1, that would be the name of the tuple, and in round brackets we'll insert the elements, that would be apple, comma, orange, comma, banana, comma, kiwi. Now we will print this tuple. We'll just have to write print and in round brackets the name of the tuple and run the command. We'll get the tuple printed. Now If you just want to insert a single element in a tuple, for that you will write the command tup2 equal to, in round brackets, you will write a single element, that would be apple, and run that command. The tuple is being created, but this tuple is not being considered as tuple in Python. It's been considered as string. So let's check the type of this tuple. For that we will write print type, and in round brackets we'll write the name of the tuple we want to check. We'll run this command. Here we can see that it is showing a string. So a single element is been shown as string in Python. If you want that it should be tuple, for that you just have to insert a single comma in the tuple, and now run this command. You will get this type as tuple. Now if you want to access any element in a tuple, for that you just have to write the command print tup1, and in square brackets the index value, that is 0, and here you quote the value apple, that is at 0th index value in tup1. Now you can also access the element in the reverse order. For that we'll write the command print tup1, and in square brackets we'll write the index value -1 and run the command. Here we can get the value kiwi from the reverse index order. Now we also have the slicing operator in tuples also. For that we'll write the command print tup1, in square brackets the index values where we'll run this command print tup1 index value 1 slicing operator 3. So it has printed orange and banana. So what does it means? It prints the index value 1 and 2 and not 3. We also have a repetition method in tuples. For that we just have to write a simple syntax like print, in square brackets the element you want to repeat. We will write the element as repeat only, and comma to just consider as tuple, and just after the bracket we would have to write the multiply operator and the number of times the element should be repeated in the tuple. Now we'll run this command. You can see that the tuple has been created with the element repeat, and the number of times is 3 that we have written just after the element. So the tuple has been created. Now we'll see the count method. For that we'll write the command print the name of the tuple dot count, and in round brackets we'll write the element for which we want to know the number of times it's been present in the tuple, and we'll execute the command. It gives us 0 as our tup1 doesn't consist guava as an element, so it gives us the count as 0. Now we'll see another method, that would be index. For that we'll write the command print tup1 dot index, and in round brackets we'll write the element for which we want to fetch the index of that element, banana, and we'll run this command. We will get the index of the element banana, that is 2, 0, 1, 2. So we get the index of the element banana. Now if we want to use the append method in tuples, we have to first create the tuple into the list. For that we'll write the command y equal to list, and in round brackets we'll write the name of the tuple which we want to convert in the list. Now we'll use the append method to the list, that is y dot append, and we'll insert an element that would be guava, and now we would just assign the y list to a variable tup1. We have now converted the y list to the tuple with this syntax, that is tuple y, and we have assigned it to the tup1 value. Now we will print this tuple and execute the command. Here we can see that we have used the append method in the tuple. First, we have changed the tuple to the list by this command y equal to list tup1. Then we have used the append method y.append and appended the element guava. Then we have changed the y list to the tuple, that is tup1 equal to tuple, the name of the list, and then we have printed the tuple. We can also add two tuples by another method. For that, we will write another tuple, that would be tup3 equal to, we will insert an element that would be cherry, and now we want it to be added in tup1, so we will write tup1 plus equal to tup3, and now we will print the final tuple, that would be tup1, and run the command. Here we can see that we have added two tuples, that is tuple1 and tuple3, which consists of cherry, and here we get the whole tuple as tuple1. Now to execute loops in tuples, we'll write the command. For that, we'll write the syntax for space a variable x in the name of the tuple colon, and then we will print the particular element one by one, and we'll run this command. Here we can see that all the elements have been printed from the tuple. Now let's understand dictionaries in Python. In lists, you can fetch the elements with the help of index numbers. But if you want to specify a different type of index for it, example, if you have a list of 8 values and you want to fetch the 5th one, you will use the index. But if you have key for each element, then you can use the key to access that element. Example, phone book. If you want to fetch a number, you will use a name and you get a number. And officially, if we talk about dictionary, if you want to understand the meaning of a word, you go to that page and you look at the word and understand the meaning of it. So this type of concept where you have a key and corresponding to that you have a value, we can achieve this with the help of dictionaries. Python dictionary can be defined as a collection of objects, values, or items of different types stored in key value pair format. These multiple key value pairs created are enclosed within the curly braces, and each key is separated from its value by the colon. Let's understand this with the help of an example. Dict1 equal to curly braces, the first key is A, and corresponding to that we have value, and that is separated by colon. And after the key value pair, that is separated by a comma. The next is B key, and that has a corresponding value 2. After that we have inserted a comma to separate it from other values. Now we have a third key, that is C, and corresponding to that we have a value 3. Let's see some characteristics of dictionaries. The dictionaries are ordered from Python version 3.7. When we say that dictionaries are ordered, it means that the items have a defined order and that order will not change. Second, that is, elements of the dictionaries cannot be accessed by index. Third, dictionaries can store various types of elements. Fourth, dictionaries are mutable. Dictionaries are changeable, meaning that we can change, add, or remove items after the dictionary has been created. Fifth one is dictionaries doesn't allow duplicate elements. Dictionaries cannot have two items with the same key. Now let's see some methods in dictionaries. The first is clear method. It removes all the elements from the dictionary, and its syntax is the name of the dictionary dot clear. The second is get. It returns the value of the specified key. The syntax is dict1 dot key, and in square brackets we have to write the key name. The third is keys. It returns a list containing the dictionary's key. Its syntax is dict1 dot keys. The next is pop. It removes the element with the specified key. Its syntax is dict1 dot pop, and in round brackets we would write the particular key name. And the next method is pop item. It removes the last inserted key value pair from the dictionary, and its syntax is dict1 dot pop item. Let's move to the Jupyter Notebook and execute these methods. First, we will add a comment that would be dictionaries. And now we'll create a dictionary. For that, we'll write the syntax name of the dictionary equal to curly braces. First, we'll write the key value, then colon, and the value corresponding to it. We'll write apple, then separate it by comma, and then the second key value, colon, and the value corresponding to that key, that would be orange. When it would be separated by comma, then we'll assign another key value that would be 3, colon, and the value corresponding to that would be banana, comma. Next, with the key value would be 4, colon, and in inverted commas we'll write the value corresponding to it, and we'll print this dictionary, print dict1, and execute this command. Here we can see that the dictionary is printed. With 1 key value we have the corresponding value apple, with 2 key value we have the corresponding value orange, with 3 key value we have the corresponding value banana, and with 4 key value we have the corresponding value kiwi. Now, to access a particular element, we can't do that in dictionary, but we can access a particular value with the help of key. We can do that in dictionary. For that, we would write the syntax print the name of the dictionary, and in square brackets we'll write the key value, that would be 1, and run the command. We would get the value corresponding to the key value, that is apple, that is corresponding to the key value 1. Now we will see a get method in dictionary. For that, we'll write the command print name of the dictionary dot get, and in round brackets we'll just write the key value and run this command. We'll get the corresponding value to the key value, that is apple. Now we will use another method that would be pop. For that, we'll write the command print dict1 dot pop, and in round brackets we'll write the key value for the value we want the element to be removed from the dictionary. We'll execute this command and we get kiwi as the output. Now we print the dictionary, print dict1. We can see that the 4th key value and the value corresponding to that key value has been removed by the pop method. Now we can also print the length of the dictionary. For that, we'll write the command print len, and in round brackets we'll write the name of the dictionary and just execute the command. We will get 3 as the output, as it has been considered 1 unit, 2nd unit, and 3rd unit. So the length is 3. And we have another method that is sorted. For that, we'll write the command print sorted and the name of the dictionary dict1. We'll execute this command. It would give us all the key values in a sorted manner when executed with this command. Now we can see another method, that is keys. For that, we have to write the command print round brackets name of the dictionary dot keys round brackets, and we'll run this command and we'll get all the keys that are present in dictionary. There is another method, that is values. For that, we'll write the command print dict1 dot values round brackets, and we'll execute this command. We'll get all the values that are present in the dictionary. Now we'll see another method, that is update, that is used to update the particular value corresponding to the key value, or update the dictionary with more values to be inserted in the dictionary. For that, we'll write the command dict1 dot update. In round brackets, first we'll write the curly braces, the key value, semicolon, and corresponding to that we'll write its value which we want to update. watermelon, and we'll also print the dictionary. We'll execute this command. We will get that the second value, that is watermelon, that's been updated. Previously it was orange and now it's watermelon, so it's been updated by this command. And we can also use this command to add more elements to the dictionary. For that, we'll write the syntax dict1.update round brackets, curly braces, and the key value colon, and corresponding to that we'll write the value muskmelon, and we'll print the dictionary, and we'll execute this command. Sorry, we just omitted the name of the dictionary, dict1.update. Now we will execute this command. Here we can see that the value has been added to the dictionary. Now we'll see another method, that is pop. For that we'll write the command dict1.pop, and in round brackets the key value for which we want the value to be removed from the dictionary, and we will print the dictionary and execute this command. Here we can see that the second key value has been removed from the dictionary, and we will see another method, that would be dict1.pop item, and then we will print the dictionary and execute the command. Here we can see that the pop item has removed the last element from the dictionary, and we are left with only 2 elements in the dictionary. Now we will see some loops in the dictionary. For that we'll write the command for x in the name of the dictionary, that is dict1 colon, and then we'll write print dict1 and in square brackets the variable x, and we'll execute this command. So with this loop we can print all the values corresponding to the key values in the dictionary. Now to print both the key and values corresponding to it, we can run a loop. For that we'll write the command for x comma y in dict1 dot items colon print x comma y, and run this command. We can get the key and the values corresponding to it. Now if you want to copy the particular dictionary in another dictionary, you can write the command. First you will name the dictionary you want to create and copy the elements. We will name it as mydict equal to, now we'll write the command dict1 dot copy, and then we will print the new dictionary, that is mydict, and we'll run this command. Okay, we have not inserted the round bracket here. Now run this command. Here we can see that we have printed the mydict dictionary and it has the same values as dict1. Now we'll see another method to delete the whole dictionary. For that we'll write dict1 dot clear. It would remove all the values from the dictionary and will also print the dictionary after that. Run this command. Here we can see all the elements from the dictionary have been removed.
In programming languages, conditions play a very crucial role. They help us develop programs that can satisfy all the business conditions and perform well. So conditional statements are useful when we have to decide that a certain condition or certain part of a code should run only if the condition is true. So the if statement is an example of conditional statements. The program will first evaluate the test condition and will only execute the code block if the test conditional expression is true. So here you can see the syntax of if statement. First we have the if keyword, and inside parenthesis we are going to pass the condition, and if this condition evaluates to true, then we go inside the body of the if statement, which is this part of the syntax. Now, while developing a code for a business problem, you might have to use multiple conditions. So the elif statement is used when we have to check multiple conditions. So here you can see if the first test expression evaluates to false, then you have the elif condition, and if the elif condition evaluates to true, then we go inside the body of the elif statement, which is this part of the statement or the syntax that I'm highlighting. Next, so sometimes you want to evaluate a condition and take one path if it is true, but specify an alternative path if it is not. So this is done with an else clause. So the else code block will run if the expression is false. So here you can see if the condition for the elif statement returns false, then we have the body of the else statement. And finally, after all the if, elif and else statements have been executed, we'll execute if there are any other statements which are present outside the if condition. Now moving ahead, we will use if, else and elif statements to write a program that will solve a business problem. So based on the location and total amount of the items, we are going to find the shipping cost. The locations are a few states in the United States. In the if statement project, we will ask the user to enter the amount of the package or the item, and we'll also ask the user to input the state name. So for the different states, we'll define the conditions using the total amount of the items and print the shipping cost. So let me take you to my Jupyter notebook where we'll do this project. Okay, so I am on my Jupyter notebook. Let me just rename this notebook. I'll say if statement and project. Alright, so let me go ahead and give a comment. I'll say package delivery cost based on the location and total amount. Alright, first and foremost, I'll go ahead and create a variable called total. Now this will be a user input, so I'm using the input function, and here I'll pass the message as enter the amount for the item. Alright, next I'll assign another variable called state. This is also going to be a user input, so I'm using the input function, and I'll say enter the state name in USA. So these are the two inputs we are asking from the user, that is to pass the amount for the item and the state in the USA. Alright, now we'll start with our first if statement. I'll write if state equal to, let's say my first state name is Texas. I'll give a colon. Make sure the syntax you are writing is correct. Now I'm going to use another if statement, so this becomes a nested if statement. Now I'll write if total, which is my item amount, so I'm checking if total amount is less than or equal to 150, then I'm going to print shipping cost in Texas is, let's say, $30. Alright, now I'll pass my next condition using elif statement. Since I'm using multiple conditions, so hence I'm going to use the elif statement. This time I'll write if total is greater than 150 and if my total amount is less than or equal to $250, then I'll say print. I made a spelling mistake, this should be shipping. I'll say print shipping cost in Texas is, let's say, $20. So usually if your amount of the item is high, then the shipping cost is low. So here you can see if the total amount for the package or the item is less than $150, then your shipping cost is $30. But if it is between $150 and $250, your shipping cost is less, which is $20. Then I'll say else print shipping cost in Texas is $5. So what basically this means is, if your total is less than or equal to $150, then the shipping cost would be $30. If your total amount lies between $150 to $250, your shipping cost is $20. And if the cost of the item or the package is more than $250, the cost is $5. So this is for Texas state. Now moving ahead, I'll write elif. This time we'll check the condition for state, let's say Florida. I'll use a colon here and say if my total is less than equal to $150, then we'll print shipping cost in Florida is, let's say, $45. I'll use the elif statement again. I'll say elif total, if it is more than $150 and if it is less than or equal to $250, I'll write print shipping cost in Florida is, let's say, $35. Next, I'll write my else statement. I'll say print shipping cost in Florida is, let's say, $10 if the cost of the item is more than $250. Now one thing to note here is the shipping cost is different for the different states in the US. Alright. Now we'll move on to our next state. Let me give a space here. I'll say elif state equal to, let's say we'll take Virginia now. I'll say if total is less than or equal to $150, we'll print shipping cost in Virginia is, let's say, $23. Alright, I'll just scroll down. Next, I'll write my elif statement. I'll say elif total is greater than $150 and total is less than equal to $250, then we'll print. I just copy this message, paste it here, and we'll say shipping cost in Virginia is $15. Next, we'll write our else statement, else print. I'll paste the message again. I'll say shipping cost in Virginia is $5 in case the cost for the items is more than $250. Now moving to our final state, I'll write another elif statement. I'll say elif state equal to let's say New Jersey, if total is less than equal to $150, then we'll print, just paste the message here. I'll say shipping cost in New Jersey is, let's say, $40. Now I'll say elif total, if it is greater than $150 and if total is less than equal to $250, we'll print, just put this within double quotes, and I'll say shipping cost in New Jersey is, let's say, $10. I'll say else print my shipping cost is free in case the total amount for the items is more than $250. Alright, finally we'll have our else statement where I'm going to print invalid state name in case the user enters any other state apart from New Jersey, Virginia, Florida and Texas. Alright, so we have our small project ready. Let me just run through it. So first we are declaring two variables, total and state, and we are taking this as user input. So the user is going to input the amount for the item or the amount for the package, and then the user will input the state. So we have the 4 states defined here, and we are checking the shipping cost for these 4 states based on the amount for the items. Alright, now let me go ahead and run it. So here you can see we have our first user input, enter the amount for the item. Let's see, I have my amount as $125, and the next input is enter the state name in USA. I'll say, let's say, Florida. If I run this, it gives me the shipping cost in Florida is $45. Let's go to the top and see what we have. Now our total was $125, which is less than $150, and hence it has printed shipping cost in Florida is $45. Let's run this again. This time I'll say, let's say my item costs $255 in the state, let's say New Jersey. Let's run it. You see here it gives us the message shipping cost is free. Now the reason being, if you see this part of the code, for state New Jersey, if the total amount for the items is more than $250, the shipping cost is free. Now let's try for another state. This time we'll see for Virginia. Let's say my amount is $190 and my state is Virginia. If I run it, it gives me the shipping cost in Virginia is $15. Let's check our code. So here I have entered my item amount to be $190, so it lies between $150 and $250, and hence it has printed the message that shipping cost in Virginia is $15. Now let me enter another state name that we have not defined in our code. Let's say I have my item amount as $290 and the state name I'll give is, let's say, Colorado. If I run it, it gives us the message as invalid state, which is present in the last part of our code. So since we haven't defined any shipping cost for Colorado, it has given us the message that the state I am trying to search for is invalid. You can check for another state or any other country name, anything that is not part of our project. Let's say I'll enter my amount as $100, and this time I'll enter my state name as, let's say, Ohio, and we'll run it. It again gives us invalid state. Let's try out one last time. I have my package amount as $350 and let's say my state is Alaska. Again it says invalid state name because we haven't defined any condition for Alaska state. So this was a very simple project that we did using our if statement. We saw how to write nested if, and we saw how to use the elif and the else statement. So what is a while loop in Python? A while loop specifies a condition or a block of code that is to be executed until the condition evaluates to false, or the loop is explicitly ended with a break statement. Moving on to the next slide. So here you can see the syntax of a while loop. So a while loop is defined using the while keyword, and then you have the expression followed by a colon. After that you have the statements inside the block. The statements are executed until the condition evaluates to false. Now on the right side you can see the flow chart to show all the steps to execute a while loop. So you can see here we have the test expression. If the test expression evaluates to true, then we execute the statements that are present inside the while block. But if the condition is false, we will exit out of the while loop. Now before I move on, I have a question for you. So here is a Python quiz question. I want you to tell me the output of the below code. So this is regarding a list. I have declared a list called alpha that has D, F and C as its elements. Then I'm saying alpha plus equal to KA, which is again a string since it is within the single quotes. Then I'm printing the list. Now you need to tell me what is the right answer. You have four options here, A, B, C and D. The first option is D, F, C, Ka combined. Then we have Ka in the beginning of the list followed by DFC. The third option or the C option is DFC Ka, Ka being individual elements, and the last option, the D option, is Ka DFC. Please go ahead and solve this question and put your answers in the comment section of the video. We'll be more than happy to know from you. Alright, now let's go ahead and start with our demo. So here I am on my Jupyter notebook. Let me rename my file. I'll say while loop in Python demo. Okay, so let me start by writing a simple while loop. I'll declare a variable called I equal to 0. Then I'll start with my while loop. I'll write my while keyword, and this will run till my I is less than 10, let's say. I'll give a colon, and if I hit enter, it will come to the next line. You can see the indentation here which is being maintained. I'll say I equal to I plus 1. So I am incrementing my I value. Then I'll say print I, and I'll use my end parameter, and I'll say end within single quotes. I'll say hash and give a space. Then let me say print again. So here my while loop will run until my I value is less than 10. So we are continuously incrementing the I value and printing the I value. Let me run it. There you go. You can see the result here. We have printed the I values starting from 1 till 10, and after that we have come out of the loop. And you can see the hash symbol being used here because we used our end parameter as hash. So by default it is a new line character, but we have explicitly defined our end parameter as hash followed by a space. Cool. Now let's move on to our next example in this video on while loop. I'll define a variable called count, and I'll assign a value 0. I'll say while my count is less than equal to 5. I'll give a colon, come to the next line, and I'll print the condition is true, and then I'll say count equal to count plus 1, and then I'll say print end of loop. Let's run and see our result. You can see here we have printed our message. The condition is true 5 times because our expression is being evaluated 5 times here. In the 6th time our count is no more less than equal to 5, so we end the loop, and here you can see the message end of loop. Cool. Now moving ahead, you can also use the break statement in a while loop. Let me show you how to do it. I'll say while true, so I am declaring my while loop to be true, and I'll say please type your name, and I'm going to take my name as input from the user, so I am specifying the input function. I'm going to check if my name is equal to let's say Gilly. Then I should give a colon here. I'll break out of the loop, and then will print thank you, you typed the correct name. Alright, so what I am doing here is I'm going to run this loop till the user enters the correct name. So I have declared my name as Gilly. If you enter any other name apart from Gilly, this while loop will continue to run and execute. Let's run it. Okay, so here it says please enter your name. Let's say John. If I run it, it is again asking me please enter your name. Let's say this time I'll say Amy. You can see here it is again asking for the name, so I'll enter my name. Let's say Hopkins. Again our entered username doesn't match the name that we have provided in the code. Let's say this time I'll say Gilly. If I hit enter, you can see we have our message, thank you, you typed the correct name. Okay. Now moving on to the next example, we will see how to find the least common multiple of 4 and 7. So I'll give a comment as LCM of 4 and 7. Now you would know it is 28, but we are going to find out with the help of a Python while loop. So first I'll declare a variable x equal to 0. I'll say while my expression is true, I'm going to increment my x value to 1. I'll say x plus equal to 1. This means x equal to x plus 1. I'm going to use an if statement and say if not, and here we'll pass the condition x percentage 4 or modulo 4 or x percentage 7, then I'll say break. Finally, we'll print our message saying x comma, and I'll say is divisible by 4 and 7. Say both 4 and 7. Okay, so what I am doing here is I am taking my expression while true. I'm incrementing the value of x each time and checking if this is true or not. Now at the first instance, when my number x is divisible by both 4 and 7, I am coming out of the loop and we are going to print this. Now let's see what's the answer. There you go. You can see here 28 is divisible by both 4 and 7, and hence the LCM of 4 and 7 is 28. So this is the least number which is divisible by 4 and 7. Alright. Now you can also use the continue statement. How you use the break statement to come out of the loop, you can also use the continue statement to continue running the loop. So I'll say I equal to 0 while I is less than 10. So this is my expression. My loop is going to run until I is less than 10. I'm going to increment the value of I. I'll say I plus equal to 1 if, let's say I set my condition, if I equal to let's say 6, then I'll say continue my execution and skip the current step where I value becomes 6. Then I'll say print I. Let's run it and see the result. Okay, you can see here we have printed 1, 2, 3, 4, 5, and here you can see we have skipped the execution where I value became 6 and continued with the next iteration 7, 8, 9 and 10. So this is how you can use the continue statement and the break statement in a while loop. Alright. Now moving ahead, you can also use the else statement in a while loop. Now let me show you how to do it. I'll say I equal to 1, then I'll write while I is less than, let's say 5. I'll say print I, then I'm going to increment the value to I plus equal to 1. Now here you can use the else statement and say print I is not less than 5. Let's run it. You can see here we ran our loop until I value was less than 5. So we printed 1, 2, 3 and 4. When I value became 5, we printed I value is not less than 5. Cool. Now moving ahead, so you can use inbuilt functions inside a while loop. Let me show you how to use the pop function and remove the elements in a list using a while loop. So I'll declare a list of numbers, let's say 1, 2, 3, 4 and we have 5. So these are the 5 elements that are present inside list A. I'll say while A, so I'm iterating over all the elements in my list. I'm going to say print a dot, I'll use the pop function. So what pop does is it is going to remove the elements from the end of a list. Then I'll say else print there are no elements left in the list. Alright, let's run it and see the result. You can see here we are removing the elements one by one from the end of the list. So first we popped out 5, then 4, 3, 2 and 1, and after that we had no more elements left in the list, so we printed there are no elements left in the list. Okay. Now the next program, we will take numbers as input from the user and calculate the average as long as the user enters a positive number. So I'll give a comment, average of positive numbers. Cool. Okay. So I'll start my program. I'll declare a variable called num which has a value 0. I'll declare a variable called count which also has a value 0. Then I have sum which has a value of 0. I'll write while my number is greater than equal to 0. So this condition is for accepting only positive numbers. I'll say num equal to, I'm going to take the positive numbers from the user. So I'll pass an input function. I'll say enter any positive number. Then I'm going to say if my number is greater than 0, I'll say count equal to count plus 1. Let's make this greater than equal to 0. Then I'll say sum equal to sum plus my number. So here I am keeping track of the numbers that we have entered, and here we are calculating this sum, that is the cumulative sum. Then I'll say AVG, which is to find the average. I'll say sum divided by my variable, that is count. Then I'm going to print total. I'll say total sum of numbers, give a colon followed by a space, give a comma, I'll say sum, then I'll say average, give a colon followed by a space, and I'll pass in the variable avg. Alright, so here I have my program ready where we are using a while loop and an if statement to take numbers as input from the user and calculate the average as long as the user enters a positive number. So let me run it. Okay, it says enter a positive number. I'll say, let's say 5. Again it's asking for a positive number. I'll say 7. Let's say 10. And this time I'm going to enter a negative number, so I'll say minus 6. If I run it, you can see here the total sum of numbers 5 plus 7 plus 10 is 22, and the average is 22 divided by 3, which is 7.33. Alright, let me give a space here for more readability. We are going to try it again. I'll say 40, 50, 30 and let's say 100. This time I'll enter a negative number, let's say minus 90. Okay, so you can see here I have entered 4 positive numbers 40, 50, 30 and 100. So the sum of numbers is 220 and the average is 40 plus 50 plus 30 plus 100, which is 220 divided by 4, which is 55. Cool. Now moving on to the last demo in this while loop with Python tutorial. So here we are going to guess a number. So the user is going to give a number between a certain range, and based on a random input generated from the program, we are going to guess the random number. Alright, so for that I'm going to start by importing my library called random. I'm going to say n equal to random dot randint, which is a function to generate random integers. I want to generate between 1 and 100. Let's go ahead and print that number n. Then I'll use a variable called guess, which is going to be a user input. So I'll say input, which is my function, and I'll give the message enter an integer between 1 to, let's say, 100. Okay. Then I'll start my while loop saying while n not equal to my variable, that is guess. I'll say if my guessed number is less than n, I'll print the message as your guess is, let's say, low. Then again I'll say guess equal to, I'll take the user input. I'll just copy this message and we'll print it here. Okay. Now I'll say elif if my guess is more than my random integer, will print, I'll just copy this, we are going to print your guess is, let's say, high. Then we are again going to ask the user to guess a number between 1 to 100, and after that I'll say else will print you guessed it correctly. Then we'll break out of the loop, and finally I'll just print it. Okay, so what we are doing in this game is, before that let me just give a comment as guessing game in Python. So first of all, we are generating a random integer using the library called random. So the integer will lie between 1 and 100. I am going to print that integer. After that I am taking a user input. So I'm asking the user to enter an integer between 1 to 100, and I'm checking if my random integer is not equal to my user input, that is guess, and if that guess is less than my random integer, I am going to print your guess is low. Then I'm again asking the user to input an integer between 1 to 100. Then I'm saying if the guessed value is more than the generated random integer, will print your guess is high. Then after that I'm again asking the user to input an integer, and in case the random integer matches with the guessed number, will print you guessed it correctly. Alright, let's try this out. Okay, so here you can see, so my program generated a random integer 48 that lies between 1 and 100. So our loop will only stop executing when we enter our number as 48. Otherwise, it will keep on running and asking you to enter an integer. Let's say I enter 50. You see here, your guessed value, that is 50, is more than the random integer 48. So we have the message, your guess is high. Let's say I'll say 30. This time my guess is low, you can see it here. Let's say I'll take my number as 300. You see here, this time my guess is high, which is more than 48. But if I say my user input to be 48 and if I hit enter, there you go. We have our message printed. You guessed it correctly. Alright. So that brings us to the end of. So what is a for loop in Python? A for loop in Python is used to iterate over the items or elements present in a sequence. The items present in a sequence can be in the form of a list, tuple, dictionary, or even a string. A for loop in Python uses the range function to iterate over a specific number of times. Now let's have a look at the syntax of a for loop. So here on the left you can see the syntax of the for loop. So we have the for keyword followed by the iterator variable. Then we have the in keyword followed by the sequence. It can be a list, you can use the range function, it can be a dictionary, a tuple, anything. And after that you have your colon followed by the statements that you want to execute in the for loop. And below you have the rest of the code. And here on the right you can see this is the flow chart of a for loop. So you have for each item in sequence, then we check the condition. If you have reached the last item, if that is true, you exit out of the loop. But if it is false, you keep on running or executing the statements that are present inside the for loop. This will continue until and unless you have reached the last item in your sequence. Okay. Now let's head over to our Jupyter notebook where we'll see for loop in detail and we'll explore a lot of code examples. Okay, so here I am on my Jupyter notebook. Let's start by writing a simple for loop. Suppose I have a variable, say s, and it has a value which is a string, let's say Simplilearn. Okay, now the way to write a for loop is I'll say for I, which is my iterator variable. It can be any valid variable name in Python, in my variable that is s. So here s becomes my sequence. I'll say print I. So what this for loop is going to do is it will iterate over all the characters that are present in my string and print them one by one. Let me run it by hitting Shift Enter. You see here, using this for loop, we have iterated over all the letters that were present in my string that is Simplilearn and we have printed them one by one. Okay. Now the print function in Python provides a parameter called end. So by default, the value of the parameter is \n, that is the new line character. Now you can end a print statement with any character or string using this parameter, which is end. Let me show you what I meant. So I'll again have my same string Simplilearn. I'll say for I in my variable or my sequence s. I'll say print I, comma, then I'll use my end parameter equal to, and my end parameter will have a value of asterisk. Now let me run this. You can see here this is sort of a pattern that we have printed. So between each letter in my string Simplilearn we have an asterisk. Okay. Moving ahead, let's see how to use for loop in a list. Alright, I'll declare a list called programming, and this list will contain a few programming languages. Let's say we have Java, and then the next item we have in the list is Python. Next we have Ruby, and then we'll have HTML. Okay, so I'm going to print all the individual items that are present in my list using the for loop. So I'll use the same syntax. I'll write for. This time I'll use my iterator variable name as iter, which means iterator. For iterator or iter in my sequence, which is programming, I'll say print iter. Let's run it. You see here we have printed all the items in my list one by one: Java, Python, Ruby and HTML. Alright, now let's see an example how you can find the average of a list of numbers using for loop. So I'll give a comment saying find the average of a list of numbers. Okay, so here first of all we'll declare a list of numbers with variable list underscore num equal to, it will have a few numbers, let's say 20, 25, 10, 50 and 40. Let's make it 45. Now to find the average of a list of numbers, first I'll declare a variable called sum that will have a value of 0. So we have initialized the sum variable to 0. Then I'll start my for loop for I in my sequence, that is list underscore num, which is this variable. I'll give a colon. I'll write sum equal to sum plus I. So here just give a space to make it more readable. So I'm adding all the numbers in my list and we are storing the result in the variable sum. Then we'll say print sum equal to, I'll pass in my variable that is sum. Then I'll say print average equal to, now our average will be my variable sum divided by the length of my list that has all the numbers. Let's run this. You see here, so our total sum of all the numbers present inside the list is 150 and the average of all these numbers is 30. So 150 divided by 5 is 30. Alright. Now let's see how you can use a for loop using a tuple. So let's declare a variable called num. This is going to be a tuple of numbers, and we have 30, 45, 60, 50 and let's say 70 as the numbers inside the tuple. I'll say sum equal to 0. Then we'll have our for loop for I in my sequence, that is num. I'll say sum equal to sum plus I. So here we are just adding the values that are present inside the tuple. I'll say print sum. So here you can see we have printed all the values present inside the tuple one below the other. Now if I shift my print statement to here, you can see here this is my sum of all the numbers that are present inside the tuple. So make sure you have the current indentation. Now let's see how you can use the range function in Python. Okay, so you can use the range function to iterate over a range of values or numbers using a for loop. The way to do is I'll say for I in my function range, I'll give my first index at 1 and my second index at, or my end index at 10. So this will go from 1 till 9 and exclude the 10th index. I'll say print I. You see here, for I equal to range 1 to 10, we have printed all the numbers starting from 1 till 9. So the last index, that is 10, is exclusive in the range function. Now in the range function, you can also give a third parameter that stands for step, so that you can skip a few steps and print the next value. Let me show you what I mean. Say I write for I in range 0, which is my starting index, 10, which is my end index, and I'll have a step size of 2. Give a colon. I'll say print display values with a step size of 2. Give a comma here and my variable, that is I. Let's print it. There you go. So we have printed the values with a gap of 2. So it starts from 0, then we are jumping 2 steps and then we are printing 2, then again 2 steps, we have 4, 6 and 8. So we are skipping one value and printing the next value in my sequence ranging from 0 to 10. Alright, now let's write a program to print a table of a given number. So I'll give a comment as program to print table of a given number. Alright, so I'll pass my variable n, which is going to be a user input. So I'm using the int function, and inside the int function I'll use the input function to take the user input. I'll give my message as enter the number. I'll say for I in range from 1 till 11, I'll say multiply, which is mul here, n asterisk I. So basically what I'm doing here is I'll take a user input of the number. Let's say we want to print the table of 5. So from 1 till 10 we'll have the product of the numbers. Let me print it. I'll say print n comma, within double quotes I'll give my asterisk comma I comma, within double quotes I'll say equal to, and then we'll have our variable mul. Let's run this, enter the number, I'll give 5 and hit enter. There you go. So here we have the multiplication table of my number 5. So you say 5 into 1, which is 5, 5 into 2 is 10, then we have 5 into 7 35, 5 into 9 is 45, then our last index which ends at 10, so we have 5 into 10, that is 50. Alright, so this is how you can create a simple multiplication table using for loop in Python. Now we can also use the range function with a sequence of items. The len function can be combined with the range function to iterate through a sequence using indexing. I'll show you an example here. Let's say we have a list called list2, and here we have a list of programming languages, let's say C++, you can either use a single quote or a double quote to represent the text values in a list. The next programming language I have is Java. Then let's say I have Python, and we have R. Okay, so I can write for I in range. Here I can use the length function, and I'll say list2, give a colon, then we'll print hello, and I'll say list2 of I. So what it does is, my iterator will iterate over the list of programming languages I have here, and it will keep on iterating till the length of the list. And then I'm printing my message as hello, and it will take each item from the list using the index number. If I run it, you can see here it says hello C++, hello Java, hello Python, and hello R. Cool. Now let's see how you can use nested for loops in Python. I'll say nested for loop as my comment. Let's say I have a list of company names. My first company I have in my list is Google. Let's say Apple, PwC, and then we have Uber. So here I'll write for I in companies, I'll say print, we will display each letter of, I'll say plus I. Now I'll use my second for loop saying for letter in I will print the letter. Let's run it and see our result. There you go. So here we have used two for loops, so that becomes a nested for loop. We have my outer for loop, and then we have our inner for loop. So in the outer for loop we are just printing the name of the company. So here we say we will display each letter of plus I, which stands for my company name Google. So you can see below we have displayed each letter of Google using the inner for loop. Similarly, we have for Apple, you can see APPLE, we have PwC, and then we have Uber. So this is how you can use multiple for loops in Python. Now let's see how you can use a for loop with else clause. So I'll give a comment for loop with else clause. So I'll write for I in range 0, 10, I'll give a step size of 3. I'll say print I, and after this Python gives you the flexibility to use an else clause after the for loop. So I'll write else print the loop has completed execution. So this is my message that we are going to print after we have printed all the elements that are present inside this range function. Let's run it. You can see here we have printed the value starting from 0 with a step size of 3. So we have 0, 3, 6 until 9, and then after that we have our else block printed, which has the message the loop has completed execution. Cool. Now let me show you two more important features that you can use while writing a for loop. One is called the break statement, the other one is called the continue statement. So in Python you can break the for loop and end it before it has actually run all the elements in the iterable using the break statement. So let me show you a simple example. If I write for, just give a space here, I in range, let's say from 1 to 10, I'll use an if condition saying if I equal to 6, then break and come out of the loop. Next we'll print I. So here what we are doing essentially is we are iterating over all the values from 1 to 10, and whenever the I value becomes 6, we come out of the loop and print all the values we have iterated so far. Let me run it and we'll see the result. There you go. So here our I value started from 1. We printed 1, 2, 3, 4, 5, and then our I value reached 6. Then we use the break statement to come out of the loop. Alright. Now you can also skip the execution of further statements in the for loop during that iteration using the continue statement in Python. So when a continue statement is executed, the for loop continues with the execution of the next element in the iterable. It does not complete all the statements in the for loop body. So again I'll give a comment, say continue. Okay, so I'll write for I in range, again from 1 to 10, give a colon. I'll say if my I value is equal to 6, then I'll say continue. Then we'll print I. Let me run it and we'll see the result. Okay, so if you notice this output, so we have printed values from 1 to 5, and when my I value became 6, we skipped printing 6 and we moved on to the next element in the iterable, which was 7. Then we printed 8 and 9. So this is how you can use the break and continue statements in Python. Alright. Now we'll see a program to display the total goals a player has scored. So here we are going to iterate over a dictionary. So I'll give a comment, program to display the total goals a player has scored. Alright. So first of all, I'll declare a variable saying player name, and let's say we have the player name as Carmelo. Alright. I'll declare a dictionary called goals, and within curly braces I'll have my first player name addition. Let's say addition has scored 14 goals. Then we have, let's say, Burnett. So Burnett is my key here, and then we'll have value in terms of goals, let's say 3, and then we have our third player, let's say Carmelo, and Carmelo has scored, let's say, 7 goals. Now I'm going to write my for loop. So I'll write for my iterable name here is player, in my sequence name is goals, so I'll say goals. I'm going to check if my player is equal to player name. I'll say print the goals scored by the player. So I'll pass my dictionary name, and within square brackets I'll say player. Let's use the break statement, and then I'll say else will print. My message would be no player with that name found. Let's run and see the result. Alright, so here what we did was, initially I declared a variable called player name that had the value Carmelo, and since Carmelo was present inside my dictionary named goals, you can see here we have Carmelo who had scored 7 goals. So I iterated over my sequence goals and I checked if my iterator, that is player, is equal to the player name, which is Carmelo. Since this Carmelo is present inside my dictionary name, so we printed the goals that were scored by Carmelo, that is 7. Now let's say I change this player name to, we have, let's say, Messi. Now since Messi is not present inside my dictionary goals, if I run this, it will print no player with that name found. The reason being Messi is not present inside my dictionary called goals. Cool. Now we'll see two more examples. This time we are going to print the cube of numbers using for loop. Alright, so first of all I'll declare a list which will have a list of numbers, let's say 2, 5, 7, 4, 8 and let's say 6. Then I'll pass in a empty list, so I'll declare within empty square brackets. I'll say for I in my sequence name, that is num, I'm going to use my empty list cube and then followed by the append function, and inside the append function we'll have our cubes of the number. So I'll write I'll use the double asterisk operator and then I'll say 3. After that we are going to print my list name, that is cube. Let's run it. There you go. So you can see here, first we have the list of the numbers here, and then we have printed the cubes of these numbers in a pattern. Let's say I bring this print statement here and I'll run it again. Now this is much more readable. You have 2 cube is 8, 5 cube is 125, 7 cube is 343, then 4 cube is 64, 8 cube is 512, 6 cube is 216. Alright, now coming to the last example in our demo section of this for loops in Python video, we'll write a program to print a pattern. I'll say pattern printing. Alright, so we are going to print a right angle triangle. For that I'm going to take my first variable called n, which is going to be a user input to enter the number of rows. So using the input function I am passing the message enter the number of rows. I'll say for I in range 0 till my user input n, give a colon. I'll use my inner for loop. This is going to be the number of columns, so I'll say for j in range 0 comma I plus 1, give a colon, and I'll print my star pattern, so I'm using asterisks, and I'll use my end parameter. I'll have my double quotations and then we'll say print the pattern. So here what I'm doing is I'm taking the number of rows from the user and I'm iterating from 0 till n, which is my user input, and then we are assigning another for loop for the number of rows, so that ranges from 0 till I plus 1. Then I'm printing my star. Let's run it and see the output. Let's say I'll enter the number of rows as 6. If I hit enter, you can see here we have our right angle triangle printed here. So initially my I value is 0. So here my j value becomes from 0 till 1. So we have just 1 star printed. In the next iteration my I value becomes 1. So from 0 to 1 plus 1, that is 2, we have 2 stars printed. In the next iteration my I value becomes 2. So 2 plus 1 is 3 again. So we have 3 columns here. So 3 stars printed, so on and so forth. Okay, so I'm on my Jupyter notebook. First of all, let's rename our notebook to looping techniques. Okay, I'll just increase the size. Alright. Okay, so let's see how you can arrange the values in a list using for loops with Python sorted function. So I'll create a variable called num and I'll assign a list. Let's say it has values 2, 5, 10, 4. I'm taking just random values. Let's say 36, 50 and 49. So this is my list. Now I want to arrange the items in this list in either ascending or descending order. So for that I can use a for loop. I'll say for I, which is my iterator variable, in, and after this I'm going to use the Python sorted function, and inside the function I'll pass in my variable which is num. Then I'll give a colon and say print I. So let's hit shift enter to run it. Okay, you can see here, so Python by default has sorted the elements in the list in ascending order. So we have 2, 4, 5, then 10, 36, 49, 50 and 50. Now let's learn how you can sort the values in a list using a for loop in descending order. So I'll just copy my above cell of code. We'll paste it here. It will help save us some time. So I'll say for I in sorted, I've given my variable num. After this, I'm going to pass in another parameter called reverse equal to, I'll say true. Now reverse equal to true will make sure Python will sort the list in descending order. If I run it, you can see the difference. We have sorted the elements in the list num in descending order now. So we have 50, 50, 49, 36, 10, 5, 4 and 2. Okay, so this is one of the techniques that you can use to sort the elements in a list using a for loop. Now similarly, you can also sort string elements alphabetically in a list in ascending or descending order. So for that, I'll create a variable called players. Let me just scroll down. Then I'll create a list which will have the names of football players. Let's say we have Messi. Then let's say we have Ronaldo. Then we have Salah. And then we have, let's say, Harry. Okay. I'm going to say for I in my function sorted, I'll say players, I'll give a comma and again use reverse equal to true. So this is going to sort the items in my list players in descending order of the alphabets. Then I'll give a colon and say print I. Let me run it. You can see here the names of the different football players have been sorted in descending order of alphabets. So we have S appearing first, then R, M and H. So Salah, Ronaldo, Messi and Harry. Alright, now let's move ahead. Now we are going to create a dictionary of key value pairs and sort it. So I'll create a dictionary called D, which will have a few key value pairs. So my first key is F and the value is, let's say, 1. Then my second key, let's say, is B and the value is 4. I'll give a comma. My next key is A and the value is, let's say, 3. After that, my next key is E and the value is, let's say, 9. And finally we have our last key, which is C, and the value is 2. Now to sort this dictionary, I'll say for I in sorted, I'm going to use the items method. I'll say sorted d.items and then we'll print I. Let me run it and show you the result. You can see it here. Our dictionary has been sorted in ascending order of the dictionary keys. So we have A, B, then C. There is no D here. After that we have E and then F. Cool. Now you can also sort the keys and values separately. Let me just copy this and I'll show you. I'll paste it here, and instead of d.items, I'll just say d.keys. If I run it, you can see here we have sorted only the keys in my dictionary. Now to sort the values, instead of items, you can just write values, and here you can see we have sorted the values in the dictionary D in ascending order again. So we have 1, 2, 3, 4 and 9. Alright. Now we will understand how to use the reverse function in loops to reverse the items in a list. So I'll again create my list called players, which will have Messi. Let's say again the next player is Ronaldo, and then we have Salah, and then we have Harry. Okay. Now to reverse the elements in this list called players, I'll say for I in, then I'll use the reversed function and pass in my list called players, give a colon and then say print I. Let's run it. Here you can see we have reversed the elements in my list called players. So we have Harry first, then Salah, Ronaldo and Messi in the end. Cool. Now moving ahead, we'll see how to use the filter function in a loop and filter specific elements in a list based on some conditions. Now to give the condition, we'll be using an anonymous function in Python that is often called as the Lambda function. To do this, I'm going to create a list called animals. I'll give my square brackets, and inside these square brackets I'm going to pass in the elements in the form of a dictionary. So to pass in a dictionary, we need to have key value pairs. So my first key is name. Let's say my animal is dogs. I'll give a comma. Then my next key is the age. Let's say dog's age is 11. So this is my first list element, which has been passed in the form of a dictionary. I'll create another curly bracket and we'll have the same keys. This time let's say my animal is lion. Let's make it dog instead of dogs. Okay. I'll give a comma and then say age. Let's say the age of the lion is 30. I'll give a comma. We'll go to the next line, and this time we are going to have another animal. I'll say elephant. Give a comma. Let's say the age is 63. I'll give a comma. And then we'll have our final element in the list. Let's say the name of the animal is leopard, give a comma, then we'll have the age of the leopard. Let's say the age is 18. So we have our list ready. Now using a for loop, we'll filter the elements in the list giving a specific condition. Let me show you. So I'll write for animals in, I'm going to use the filter function, and inside the filter function I'll give an anonymous function called lambda. I'll say lambda I colon I of age if it is divisible by 2. So I'll say age divided by 2 equal to 0, give a comma, then we will print that animal. I'll give a colon, I'll say print animals. So what I'm doing here is I'm using the filter function and passing my condition, that is, if the age of the animal is divisible by 2, then print the animal, or just print the list. Rest we don't need. Alright, now let me run it. It says there is an invalid syntax. Let me debug it. Okay, there is a spelling mistake here in lambda. This should be MBDA. Okay, now we'll run it. There you go. So here in the list that we had created, only the age of lion and leopard were divisible by 2. So 30 and 18 were divisible by 2. So Python printed us only those two elements in the list. The rest it ignored. 11 and 63 are not divisible by 2, so we did not get dog and elephant. Cool. So this is another interesting looping technique where you can use filter as well as an anonymous lambda function. Alright. Now in the next example, we'll see how to remove items in a list using a while loop. So far we have been using only for loops. Now we are going to see a few examples using while loop. Okay, I'm going to create a variable called country. So this variable will hold a list of elements of the different country names. I'll say India. Let's say my second country is Canada, and let's say my third country I have is Brazil. My fourth country I have is Japan, and then we have, let's say, Israel. Okay, now I'll use a while loop. So I'll say while my list, that is country, then to remove the elements in the list I'm going to use the pop function. So I'll say print country dot, I'll say pop, and I'll pass -1 as the parameter so that it removes the elements from the end of the list. If I run it, you can see here we have Israel, Japan, Brazil, Canada and India. Now you can just print country. You can see here, since we have removed all the elements from my list country, there is no element left here, so it gives us an empty list. Cool. Now let me show you how you can use while loops in just one line. So for that I'll create a variable called num and I'll assign a value of 10. I'll say while num is greater than 0, I'll say num equal to num -1. I'll give a semicolon this time, and then I'll say print num. Let's run it. You can see it here. We have printed 9, 8, 7, 6 up to 0. So in the first iteration my num value was 10. So 10 greater than 0 was true. So we decreased the value of num by 1. So num became 9 and we printed 9. In the second iteration, num, which was 9, was greater than 0. Then we decreased or reduced num by 1 again, so it became 8. Then we printed it, and the loop continued till we reached 0. Cool. Now had this condition been num equal to num plus 1 or num plus equal to 1, the loop would have run for infinite number of times. Alright. Now I'll show you an example how to run an infinite loop. So I'll say while true, I'll create a variable called num. Now this num would be a user input, a user integer input actually. I'll pass in the message as enter an integer, give a colon followed by a space, and then we'll say print the product of, I'll give a comma, say num, I'll give another comma, I'll say is. Now we'll pass in our multiplication. I want to multiply any user given number by 5. So I'll say 5 multiplied by num. Okay, let's run it and see here, enter an integer. If I say, let's say 3, so 3 multiplied by 5 is 15, the product of 3. Here I can change the message as multiplied by 5. You can say is. Okay, now let's run it. Okay, so let's say I enter my integer as 3. I have the message the product of 3 multiplied by 5 is 15. Let's enter another value 10, the product is 50. Let's say I have 20, the product is 100. Let's say I am taking 35 multiplied by 5 is 175. So this loop will continue until and unless you don't interrupt it. So I'm going to interrupt my kernel to stop executing this loop. Okay, now we are going to explore the enumerate function in Python, but before that let me tell you what enumerate function is. So the enumerate method or the function in Python allows us to number list indices of the items as they are coming out of the array. Python will automatically put this indices into a tuple. Let me show you how it works. So I'll directly start with my for loop. I'll say for I in, I'll use the enumerate keyword, and within brackets I'll pass in my elements in the form of list. I'll say the, let's say, then we have brown. The next word I have is for. Let's say, then we have jumped. This is basically a sentence broken down into different words, and those words we have put as elements in the list. The next word I have is the, give a comma, I'll say lazy. Then we have dog, give a comma, and finally we'll have our full stop or the period. Okay, then I'll give a colon and I'll say print I. Now let me run it. You can see here using the enumerate function we have given the indices to the different items in my list. So it starts from 0 and goes till 8. So there are total 9 elements in my list. Okay. Now you can see here the result has been printed in the form of a tuple or tuple. I'll just copy the above code and paste it here. Now I'm going to replace I with key and value, and print also I'll say key comma value. Let me show you the result. You can see here this time it is no more a tuple, and here we have the indices and then we have the items. So basically these indices have now become the keys and the items are the values. Okay. Now you can print the different elements in the form of a sentence. Let me show you how to do it. I'll just paste it here, and instead of key I'll say value, and I'll use the end parameter in the print statement. I'll say end equal to, I'll give a space. Let's run it. You can see here, okay, this should be brown fox and not for. Let's run it again. So we have the sentence, the brown fox jumped over the lazy dog. Okay. So similarly, you can iterate through the letters in a word or a string and print the letters along with the indices. I'll declare a variable called company, and this will have a value, let's say Simplilearn. I'll say for I, comma j in, I'll use the enumerate function. Within brackets, I'll say company, give a colon, then I'll say print I, comma j. Let's see the result. There you go. So here we have indices assigned to the different letters in my word Simplilearn. Okay. Now moving ahead. So by default the index position starts at 0, as I told you. Now you can also mention the starting index position using the start parameter. So what I'll do is I'll copy my above code, I'll paste it here. Now we are going to make some changes. I'll say for I in enumerate company, and then I'm going to give my start parameter. Let's say I want to start the index position at 10. Now if I print it, okay, let's say print I, there you go. Here you can see my first letter starts at index 10, then we have 11, M at 12, P at 13, and finally we have the last letter, which is N in Simplilearn, is at the 20th index. Cool. Okay. So now let's explore the zip function in Python and how you can use it to loop it through two arrays at once. So the zip function returns a zip object, which is an iterator of tuples where the first item in each past iterator is paired together, and then the second item in each past iterator is paired together, and so on and so forth. So if the past iterators have different lengths, the iterator with the least items decides the length of the new iterator. Let me show you the first example that will help you understand how the zip function works. So I have a list called first, and I have names of few football players. We have Lionel, then we have Cristiano, give a comma, and let's say we have Mohammed. I'll declare another list called last, which will have values like Messi, then we have Ronaldo, basically the surnames of Lionel, Cristiano and Mohammed, then we have Salah. I'll write my for loop. I'll say for I in my zip function or the method, I'll pass in first comma last, which are my list names. I'll say print I. Let me run it. You can see here, using the zip function, we have iterated through both the lists. So we have Lionel Messi, Cristiano Ronaldo, and then Mohamed Salah. Alright. Now you can combine the elements of 3 lists as well. So I'll just paste the code here and we'll create another list called num, and this is going to be a list of numbers, let's say 7 and 8. Okay, now here I'll say for I in zip first, last and num print I. If I run it, you see the result here. It has zipped only the first 3 items in the list, first, last and num. So we have 3 items printed. Okay. Now coming to the final section of this demo on looping techniques in Python, we'll explore about zip_longest. So Python's iterator tool or iter tool is a module that provides various functions that work on iterators to produce complex iterators. So iterators in Python is an object that can iterate through sequence data types such as list, tuple, string and so on. So the zip_longest iterator falls under terminating iterators. It prints the values of the iterables alternatively in sequence. If one of the iterables is printed fully, the remaining values are filled with the values assigned in the fill value parameter. So to use this function called zip_longest, we need to import zip_longest from the iter_tools module. So I'll say from iter_tools import zip_longest. Okay. Then I'll create my first list. I'll say, let me go to the top and copy the elements because we are going to use these same elements again. I'll paste it here. Okay. And let's say I'll give a comma and we are going to, and I'm again going to use the 3 elements. Okay. Now I'll create another list called last and we are going to copy the items from the top, paste it here, and now I'll say for, let me just scroll down, I in zip_longest within brackets I'll say first comma last. We're going to print I. Let me run it and show you the result. This should be zip_longest. Okay, you can see the result here. For the first 3 items it has printed Lionel Messi, Cristiano Ronaldo and Mohamed Salah, which you can see here. But for the last 3 items in the first list it has given us none, none and none because there were no values. Now to overcome this problem you can use a parameter called fill value. Let me just copy this and I'll paste it here, and the only change that I'm going to do here is I'm going to say, I'll give a comma, I'll use the parameter called fill value equal to, I'll say NA. If I run it, you can see here for the last 3, now we have whatever we have defined within fill value parameter. You can change this to, let's say, not defined. There you go. Alright, so these were some of the interesting examples that we implemented using looping techniques in Python. So we are going to look at what is a function in Python, then we'll see the different types of Python functions. Then you will understand the various advantages of using Python functions, and finally we'll head out to our Jupyter notebook to understand Python functions in detail with hands-on demonstrations. Okay, so what is a function in Python? So a function is a bunch of statements that are defined to perform specific operations. A function in Python helps to divide your program into smaller and modular chunks, thus allowing you to make extensive programs more organized and manageable. It also avoids repetition and makes the code reusable. So let's understand the types of Python functions. First we have built-in functions. So these are the functions that are built into Python. So by default, the inbuilt functions are available in Python. Then we have user-defined functions. So functions defined by users to carry out certain tasks are called user-defined functions. They don't have a fixed name. So here on this slide you can see the different built-in Python functions that are available. So you have power, length, next, max, absolute, we have print, range, slice, sorted, round, and there are many more. So these we will explore in our demo session. So wait for a while. Now let's understand about the user-defined functions. So these functions are defined by users to perform specific tasks, and these are the steps that you need to create a user-defined function. So first you need to create the function and then call the function. Now moving to the next slide. So here you can see the syntax of writing a user-defined function. So we use the def keyword to define the function, followed by the function name, and within brackets you have the parameters or the arguments of the function. Then you have the function block, and if you want to return a value from the function, you can use the return function followed by the expression. So here is an example where we are just printing hello Python using a user-defined function, and in this case my function name is called my underscore function. Now if I call my underscore function, it will return me hello Python. Cool. Okay, now let's understand the advantages of using Python functions. So with the help of functions, you can avoid rewriting the same logic or code again and again in a program. So in Python, you can call functions anywhere multiple times in a single program. You can also track an extensive Python program easily when it is divided into multiple functions. And the most crucial feature or the advantages of Python functions is that of its reusability. Cool. Now let's head over to our Jupyter notebook and we'll explore the inbuilt and user-defined functions in detail. Okay, so I'm on my Jupyter notebook. First I'll go ahead and rename my notebook as functions in Python. I'll click on rename. Okay. First of all, let me just increase the size. Okay. I'll give my comment as built-in functions. Okay. So we'll start by looking at the absolute function in Python. So absolute or ABS function returns the absolute value of a number. So I'll say, let's say a equal to, I'll use the absolute function which is represented as ABS in Python. Suppose I write ABS of, let's say 10.75, and if I print a, it gives me 10.75, which is fair enough. Let me just copy this code. I'll paste it here. I'll say b equal to ABS. This time I'm going to use the negative symbol or the negative sign. I'll say minus 10.75 and we'll print b. Let me run it. You can see here Python has automatically removed the negative sign and it has just given us 10.75. So this is how the absolute function works. So ABS returns the absolute value of a number, which is always positive. Now let's see another inbuilt function, very popular, which is called the length function or len. I just give a comment saying len. Above also let me just give a comment as ABS. Okay, so later we can have a track of whatever functions we have learned in the demo. So the length function returns the length of an object. It could be an iterable such as a list, it could be a tuple or even a dictionary. Let me show you how it works. I'll say list1 equal to, I'll create a list within square brackets. Let's say I have a few letters. Let's say IN, then I have D, I again, and A. So I have all the letters in my word India. Now if I say x equal to len of list1, then I'll print x. It gives me 5 because the length of all the characters in my list is 5. You can count here INDIA. So there are only 5 elements, and hence it has returned us 5. Now we'll explore another function which is called as all. So the all function returns true if any item in an iterable object is true. So I'll say my underscore list equal to, let's say I have 0, 1 and 0. I'll say x equal to, then I'll use the all function, and inside the function I'll pass in my list, which is my underscore list, and will print x. Hold on for a second, and can you please guess what this x will be? It gives us false. The reason being, we have two false values, 0 and 0 here, and there is only one true value, which is 1. Suppose I had 1, 1 and 1. If I run this, it would have given us true because all the elements in my list or the iterable are true. If any one of the elements is false, it will give us false. Okay. Now moving to our next function, which is called sum. So Python sum function is used to get the sum of numbers of an iterable. Let's say I have s equal to, I'm using the function sum, and inside the sum function I'm going to declare a list of numbers. Let's say we have 20, 35 and let's say 70. Let me create another list called s1. I'll say sum, and now let's say we'll pass in a tuple now. So I'm using another bracket. We have, let's say, 7, 5 and 9. Now if I write print s, and let's say I want to print s1, you can see here my sum function has returned the sum of all the numbers in the iterable. The first one was a list, and next we have a tuple. So 20 plus 35 plus 70 is 125, and then 7 plus 5 plus 9 is 21. So this is how the sum function works. Now moving ahead, we have the max function next, as well as the min function. So as the name suggests, the max function will return the maximum number of an iterable. So I'll create a variable called m1, and I'll use the max function. Let's say we have a few values, 7, 10, 3, 12, 61 and 40. Now let's go ahead and print m1. Now if I run it, it returns me the maximum number that is present inside my list of numbers or the tuple that I have passed in. Here you have the maximum number as 61. Now let's use the max function over a dictionary. So I'll create another variable called m2, and I'll say max, and inside the max function I'm going to pass in my values in the form of a dictionary. So I'm using curly brackets or braces. I'll say, let's say 7, 90, we have 3, let's say 150, 67 and 44. Now let me go ahead and print m2. If I run it, you can see it here, it has given us 50, which is the highest element in my dictionary. Okay. Now similarly, you can use the min function. Let me just copy this and I'll paste it here. I'll say m3. Instead of max function, we are going to use the min function. So the min function will return the minimum number in an iterable. Let's say I'll pass in m3 as a list this time, and if I say print m3, it gives me 3, which is the lowest number or the lowest value in my list. And similarly, you can have the lowest value printed from a dictionary. I'll just change the variable to m4, and instead of max we'll use the min function, and here also I'll use the variable as m4. If I run it, you can see here we have printed the minimum value in my dictionary, which is 3. Okay. Now moving ahead, we'll explore another function called iter. So Python iter function returns an iterator for the given object. So the iter function creates an object which can be iterated one element at a time, and the next function returns the next item in an iterator. Let's use both iter and next function in our next example. So I'll create a list called my list, and I'll say equal to followed by using the iter function, and inside the iter function I'm going to pass in a list which will have letters of India. I have N, D, I, and then I have A. Now I'll create another variable called X, and then I'll pass in the next function, and inside the next function I'll pass in my list, and we'll go ahead and print X. So it will print the first element in my iterable, that is I here. Now if I copy this and I'll paste it here, if I run it again, you can see it here, the iter function returns the second iterable which is N in my list INDIA. I'll paste it again. If I run it, we have the third item in the list which is D. Okay. Now coming to using the power function in Python. So Python POW, or the power function, returns the power of the given numbers. Let's say x raised to the power 3. So I'll declare a variable x1 and say POW. Let's say I want the value of 3 raised to the power 3, and let's say I have another variable called x2. I'll use the POW function, and this time I want to know what is 2 raised to power 4. We'll go ahead and print x1 and x2, and as you guessed it, 3 raised to the power 3 or 3 cube is 27, and 2 raised to the power 4 is 16. Cool. Now coming to using the range function. So the Python range function returns a sequence of numbers starting from 0 and increments by 1. So this is by default and stops before the given number. So let me show you. If I say x equal to, I'll use the range function, and inside the range function I'll have my value as 6. Then I'll say for n, now here n is my iterator variable, I'll say for n in x, print n. Let's run it and we'll see the result. You can see here the range function has returned us the number starting from 0, and it has gradually incremented the iterator by 1. So we have from 0 till 5. Now I'll show you another example. I want to change the default starting value, that is 0. So I'll say if x equal to range, I'm going to start from 40 till 50 with a step size of 2. So you can pass it as the third argument, so it will skip one value and print the next value. So then I'll say for n in x, I'll give a colon, let's print n, and we'll see the result. You can see here it starts with 40 and has a step size of 2. So we have 40, 42, 44, 46 and 48. Cool. Now let's move ahead and we'll explore the round function in Python. So the round function rounds off a number to the given number of digits. Let's say I have x equal to, I'll use the round function, and then I'll have a decimal value, let's say 8.62475, and I want to round it to 2 decimal places. Let's print x. If I run it, you can see here my Python has returned a rounded up value to 2 decimal places. So we have 8.62, and the rest it has just skipped. Now moving ahead, we'll explore the sorted function in Python. So the sorted function returns a sorted list of the specified iterable object. You can specify ascending or descending order. So I'll create a list called A, and we have the elements, let's say again India. So I have I, N, D, I, and I have A again. If I say X equal to sorted A, and if I print X, you can see it here, Python has sorted the elements in the list in ascending order of the letters. So we have A appearing first, then D, again I, and then finally we have N. Now suppose you wanted to print the letters in descending order, you can use another argument here. I'll give a comma and say reverse equal to true. So this line will ensure my list is sorted in descending order. You can see it here, it has just reversed the above result. So we have N appearing first, then I, D, and A. You can do the same for a list of numbers. Let's say we have 12, 50, 38, 76, let's say 27, 80, and 5. I'll say X equal to sorted A and will print X. If I run it, you see it here, we have sorted the numbers in the list in ascending order now. If you want to sort it in descending order, just add reverse equal to true. There you go. Here my list has now been sorted in descending order of elements. Now we are going to look at the final built-in Python function, which is slice. So the slice function returns a portion of an iterable as an object of the slice class based on the specified range. Suppose I have a list called A. Okay, let's not define a list, we'll define a tuple. So this has the letters in the word Simplilearn. So I have S, I, M, P, L, I, again L, I have E, comma, I have A, then we have R, and finally I have N. So these are the letters which have been represented as a tuple. Simplilearn, then I'll use the slice function and I'll give my range as 5 and will print A of X. Let's run it. You see it here, the slice function has sliced the first 5 elements in my tuple. So we have S, I, M, P, and L. Cool. So we have explored all the important built-in Python functions. Now let's head over to using user-defined functions or learning user-defined functions in Python. I'll give a comment first, user-defined functions. Cool. So as we had learned in our slides, to define a user-defined function, we will use the def keyword and a function name. This should be a valid Python name. So I'm using func1 followed by parenthesis and then we'll have a colon. And now we'll define the body of the function. I'll say print hello world. This is the same example that we had seen in our slide. Now I'm going to call the function using the function name, which is func1. If I run it, you can see it here, I have my message printed hello world. So this is a very simple user-defined function and it does not carry any arguments or parameters. Now let me show you another user-defined function. I'll say def hello. Again, we are not giving any parameter to this function or arguments to this function. I'll say name equal to str. This time we are going to take the input from the user, so I'm using the input function. I'll say enter your country name I'll give a colon and a space, and then we'll say print. I'll print the message hello followed by a space, give a plus sign, and we are going to convert our name to string. So this is my function. Let me run it. Now I'll call hello. It is asking me for entering country name. I'll say Japan. If I hit enter, it says hello, then my country name, which is Japan. So hello Japan. Let me run it again. This time I'll say USA. I'll hit enter. You can see here my message is hello USA. Cool. Now moving ahead to our next example, where we'll see using functions with different parameters. So we'll start with a very simple example. I'll say def. I want to convert feet to centimeter. I'll say my function name as ft_2_cm. So I'll pass in a value for feet, and that feet will be converted to centimeters. And this time inside parenthesis I'm going to pass in my parameter as ft. I'll use the formula for centimeter. I'll say my variable centimeter equal to feet multiplied by 30.48. So 1 feet is actually 30.48 centimeters. So centimeter becomes feet into 30.48. Then we are going to use the return keyword, and I'm going to return the output, which is centimeter. Let's run it. Now to call the function, I'll use my function name, which is ft_2_cm. This is my function name. And then I'm going to pass in a value for feet. Let's say I want to convert 6 feet into centimeters. If I run it, there you go. You can see it here. 6 feet is actually 182.88 centimeters. Let's say 5.8. If I run it, it is 176.784 centimeters. So here you saw how to pass in arguments to a user-defined function. Now again, you can pass in multiple arguments. Let's say I'm going to find the sum of two values. For that I'll create a function called def. My function name is add. I'm going to add two values x and y. So I'm passing in two parameters x, y. I'll create a variable called sum that will store the value of x plus y, and then let's print sum. Okay, let me just scroll down. I'll hit shift enter to run it. Okay, we have created my function, that is add. Now let's add 40 and 50. You have to pass in two arguments because we have declared x and y in the function, so it needs at least two arguments. If I run it, you have the sum of 40 and 50, which is 90. Let's say I have minus 20 and 30. If I run it, you have the result. Minus 20 plus 30 is 10. Alright. Now similarly, you can also multiply two numbers. Let me just copy this. I'll paste it here, and instead of add, I'll give my user-defined function name as multiply. I'll say product equal to x asterisk y, and I'll print product. Let's run it. I'll call my function using the function name multiply. Let's say 4 multiplied by 6. So the result is 24. Cool. Now moving ahead, we'll explore another example. Let's say I want to print the absolute value of a number. So I'm creating a function called def. My function name is absolute, and I'll pass in one parameter, which is x. I'm going to use if-else statement. I'll say if x is greater than or equal to 0, I'll give a colon, then I'll say return x, else give a colon, I'll say return minus x. I'll run it. Now if I print absolute of, let's say, 56, the result is as expected. Since 56 is greater than 0, we have just returned 56. Let me just copy this. I'll paste it here. Let's say absolute of minus 56 is again 56 because we are returning minus x, so minus of minus 56 becomes plus 56. Now if you wanted to return minus 56, you need to make some modifications. I'll put another minus and keep this within brackets. Let me run the function again. And now if I print absolute of minus 56, you have the result as minus 56. Okay. Now let's see another example how to find the factorial of a number using a user defined function. So we'll define our function as def. I'll use the function name as factorial. I'm going to pass in a parameter called x. I'll say if x is equal to 0, then we'll just return x or return 1. I'll say else, give a colon, return, I'll say x asterisk or multiplied by, I'll use the function name factorial, I'll say x minus 1. Now let's run it. I'll call my function factorial. Let's say I want to find the factorial of 5, the result is 120. Let's say the factorial of 10, the result is 36,28,800. Cool. Now let's see how you can pass in default arguments to your function or default parameters. Okay, suppose I have a function defined called welcome. Here I'm going to pass my argument as name, and in the argument itself I'll pass in the value, a default value, let's say Paul, give a colon, and I'll print hello. This would be within quotes and the name. Cool. Let me just run it. Now I'm going to call the function welcome. This time I'm not giving any value to my function. If I run it, it has automatically taken the default argument, which was Paul, so my message becomes hello Paul. Now let's say I'll pass in a value welcome, and within quotes I'll say Racy. Now the message becomes hello Racy. So if you pass in a value to your function welcome explicitly, it will take that value instead of the default argument. Cool. Now you can also have multiple arguments in your function, as we saw above for the addition and multiplication functions. I'll create a function called message, and we'll have the arguments as name1, name2 and name3. Give a colon, I'll say print a message that is hello. I'll give a space, give a comma, we have name1, give a comma, and then I'll say comma please tell, give another comma, I'll have my name2, give a comma followed by the message that, then I have name3, this should be a comma instead of a period, then I'll say is waiting. Make sure this is within quotations again, just give a exclamation mark. Okay, so I have my message. Let's run it. Now I'll call my function message. We need 3 arguments now, so I'll pass in 3 names. Let's say my first name is Gilly, my second name is Rachel, and my third name is, let's say, Shaw. I'll run it, and you can see here we have my message printed hello followed by name1, which is Gilly. So hello Gilly, please tell name2, which is Rachel. So please tell Rachel that name3, which is Shaw, that Shaw is waiting. Cool. Now we'll understand about scope of variables in a function. Now your scope could be a global scope or a local scope. Let's define a function called func3. Now inside the function I'm going to create a variable called z, which has a value of 7. Now I'll just print z and I'll call in my function 3. If I run it, you have the value printed of z, that is 7. Now if I want to access my variable, that is z, outside the function, if I run this, it throws me an error because this variable z was defined locally, that is inside the function, and you cannot access z outside the function. Now to overcome this issue, let me just copy this. We are going to declare z as a global variable. So I'll have z outside the function. I'll say z equal to 7, and then I have my function defined. I'll just change the name of the function to function 4, and then we'll print z, and I'll call the function 4. If I run it, you can see it here. I have the value of z printed, that is 7. Now if I want to access z outside the function, then also it's fine because we have defined z outside the function, that is z is now a global variable, so its scope is throughout the function. Now another thing to note here is you can't change the value from inside a local scope. So if I say z equal to 7, and then I'll define my function func, let's say 5, I'll give a colon, and I'll say, let's say I want to alter the value of z to, let's say, z plus 7. I'll print z, and let me now call func5. If I run this, it throws me an error. As I said, it says local variable z referenced before assignment. So you can't change its value from inside a local scope. For that, you're going to explicitly define the variable z as global. Let me show you how to do it. I've just copied this code. I'll paste it here. I'll say z equal to 7. I'll define my function, let's say func6. Here I'm going to say global z. So I've explicitly defined my z as a global variable. Now if I call the function 6, you can see here we have altered the value of z from 7 to z plus 1, that is 7 plus 1, which is 8. Okay. Now asterisk args in function definitions in Python are used to pass a variable number of arguments to a function. Suppose you don't know the exact number of arguments you need, so you can use the argument with an asterisk symbol. Let me show you how to do it. I'll say def welcome, and here I'm going to pass in asterisk followed by the name of my argument, which is names. I'll say print. I'll print my message as hello, comma. Then I'm going to say names, the first name, which is with index value of 0, comma, followed by a space. Then I have name 1. I'll give a comma followed by a space, and then we'll have names This should be names. Okay, let me run this. Now I'll call my function welcome. Now you can see here I have passed in my argument, that is names, 3 times. So let's call 3 names. Let's say we have Steve, then we have Bill, and then we have, let's say, Yash. Now if I run this, there you go. We have a message printed, hello, Steve, Bill, Yash. Okay. Now coming to the final section of our demo. Here we are going to find out the area of a circle and a sphere. So we are going to define 2 functions, one for circle and another for sphere. So first of all, let me define the value of pi, which is 3.14. I'll start with def. I'll give my function name as circle area, and inside that I'll pass in my argument, that is radius. I'll give a colon, and we are going to return the area of a circle, which is pi r square. So I'll have radius, again an asterisk symbol, and then radius. So this becomes pi into radius, which is pi r square. Okay, now let's define another function called def. I'll say sphere area. I'll have my argument as radius, give a colon, and say return 4 pi r square, which is the area of a sphere. So I'll have 4 multiplied by pi multiplied by radius multiplied by radius. So this becomes 4 pi r square. Now we are going to define the main function. So I'll say define main, where we'll just have our print statement. So I'll say print circle area with radius 15. I'll give a comma and say circle area, which is my function name, and we'll pass in the value of the radius, which is 15. I'll just copy this message and we'll print it here. I'll say sphere area with radius 15 is, I'll just change this to sphere, and let's say we'll have radius for 10 instead of 15. Okay, finally I'm going to call my main function. So I'll just say main. Now let's run it. Okay, there is one error here. This is an indentation problem. Now we'll run it again. There you go. So the circle area with radius 15 is 3.14, which is the pi value multiplied by radius into radius, that is 15 into 15. So the value is 706.5. And similarly, the sphere area with radius 10 is 4 into 3.14 into 10 into 10, that is 1256. Alright. So what is a lambda function? A lambda function is one of the simplest ways to define a function in Python. A lambda function is an anonymous function defined without a name and does not have the def keyword. It can accept any number of arguments but can only have one expression. So the function is always defined using the lambda keyword, which you can see it here. So here we have the syntax for lambda function. We use the lambda keyword followed by the arguments, and then we have a colon. After that we have the expression that we want to evaluate. Cool. Now moving ahead, let's look at an example of using lambda function in Python. Now if you were to add two numbers in Python using a function, you would ideally use the def keyword followed by the function name and then pass in the arguments. You can see the arguments here, a and b. Then use the return statement to get the value of the addition. So we have return a plus b, and finally you will call the add function and pass the argument values to get the result. Now this operation can be done using the lambda function as shown here. So we have defined a variable called add, which is equal to, and then we have used the lambda function followed by the two parameters or arguments. So here a and b are the arguments, and then I have my expression a plus b. See, all this you can do it in one line. And then to call the function you use print followed by the variable which is add, and then you have the arguments 3, 8. So the addition of 3 plus 8 would be 11. Now you can see that instead of using the def keyword, we have used the lambda keyword, and there is no parenthesis required. Anything after the lambda keyword is treated as a parameter or argument. So we use a colon to separate parameters and the expression. In our case, the expression is a plus b. Now moving ahead, we'll look at the pros and cons of lambda functions. So lambda functions are suitable for simple logical operations. So when we want one expression in return, we can use the lambda function. Now lambda function is used as a parameter to different functions such as map, filter, reduce. We will see all this in our demo session. Now coming to the cons of using a lambda function. So lambda functions can only evaluate one expression, as I told you earlier. You cannot write a docstring to explain all the inputs, operations and outputs as you would do in a normal user-defined function that uses the def keyword. And finally, lambda functions are generally not preferred when you have to declare a function with multiple lines of code. Now let's head over to our Jupyter notebook where we will learn about lambda functions and how to use it in different ways. So I'm on my Jupyter notebook. Let me just go ahead and will rename the notebook as Lambda Functions in Python. Okay, I'll just click on rename. Cool. First of all, I'll write a general user-defined function using the def keyword. Let's say I want to add two numbers. So this example we have already seen in our slide. So the way to do is I'll use the def keyword followed by the function name, and then I'm giving my arguments or the parameters. After that, let's say I want to store the addition of a plus b in a variable called result. So I'll say result equal to a plus b, and then I want to return my output, that is result. So I'll say return result. So this is how you will normally create a function in Python. If I run it, and then I'm going to call my function using the function name, that is add, and then I'll pass in my parameters a and b. Let's say my a is 3 and b is 4. If I run this, I will get the result 7, which is fair enough. Now if I want to do the same operation using a lambda function, I would do something like this. Let's say I'll create a variable called add, and then I'm going to use the lambda function followed by the arguments a comma b. Then I'll give a colon and say a plus b. After that, I'll just say add and then pass in my parameters 3, 4. If I run it, you have the same result, that is 7. Now let's see another example using lambda functions to add a number. This time I'm going to pass in only one argument. So I'll say add equal to lambda, my argument is x, I'll say x colon x plus, let's say I want to add x with 100. I'll say print add, let's say I want to add 50 with 100. If I run it, I have the result 150. Alright. Now in Python, there is no need to assign a lambda to a variable. You can directly call it. Let me show you how to do it. I'll say lambda a comma b, which are my arguments. Again, this time I'm going to use a multiplication operator since I want to do a product of a and b. And after that, using another parenthesis, you can directly pass in the arguments. So there is no need to explicitly assign a lambda to a variable. So if I want to find the product of, let's say, 15, 30, if I run it, I have the result 40. Let's change the arguments. Let's say I want to find the product of 5, 7. The answer is 35. So this is known as an immediately invoked function expression, or IIFE, which is often pronounced as IFE. Now you can also use keyword arguments using lambda functions. Let me show you what I mean. I'll create my lambda function and assign it to a variable called product. I'll say lambda. Let's say my arguments are x, y, and z. After that, I'll give a colon and say x multiplied by y multiplied by z. Next, I'll say print my variable, that is product, and here I'm going to use keyword arguments. So I'll say, let's say, z equal to 5, x equal to 10, and y equal to 4. You can see here this need not be in an order as you have defined the arguments. If I run this, I have the result. The product of 5 multiplied by 10 multiplied by 4 is 200. Now you can also use default arguments. Suppose I say add equal to, I'll use the lambda function and say x, comma, y I am assigning a default value of, let's say, 15, and z, let's say I'll assign a default value of 24. Then I'll give my colon followed by the expression, that is x plus y plus z. Now I'll say print add. Now here I'm going to only pass in my value for x, since I've already given a default value for argument y and z. So my function only needs one argument, that is x. So let's say I want x to be 20. If I run this, you see the result here. So 20 plus 15 plus 24 is 59. Now you can also use the asterisk args parameter, or args. So this allows you to define as many arguments as you want. So I'll say addition equal to lambda, then I'll say asterisk args. So this will allow us to pass in as many arguments as you want, and I want to find the sum of args. So I'm using the inbuilt sum function in Python. Now I'll say print my variable name, that is addition, and let's say I want to find the sum for 4 values or 4 arguments, let's say 20, 2, 40, and let's say 50. If I run it, so the value is 112. So 20 plus 2 plus 40 plus 50 is 112. Cool. Now lambda functions are also used with higher order functions, which take one or more functions as arguments or return one or more functions. Let me show you. So I'll define a variable called higher underscore ord underscore fun, which stands for function, and ord stands for order. So I'll declare my lambda function. Suppose the parameters are x, and then I have a function, and then followed by a colon, I have my expression as x plus function of x. Now I'll say higher underscore ord underscore fun, and I'll pass in my 2 arguments. Let's say my x is 20, and for this function I'll have a lambda function defined. I'll say lambda x colon x multiplied by x. Now let me just run this and I'll show you the result. Okay, so what it did was it added my value of x, that is 20, with function of x or fun of x. What is fun of x? Fun of x is x multiplied by x. So 20 multiplied by 20 is 400. So this becomes 400 plus x, which is 400 plus 20, hence the result is 420. So this is known as a higher order function. Now let me show you another example. Let's say I want to display odd or even by taking the value of x. I'll say lambda x colon. Here I am going to pass in my expression. If x mod 2, give a space here, I'll say and odd or even. Now I'll give my argument value, let's say 30. The result is even because 30 is divisible by 2. I'll just change this to, let's say, 15. If I run it, the answer is odd because 15 is not divisible by 2. Let's say I have 150, the answer is even. Now moving ahead, so let's write a lambda function that checks if a string is a substring of the given string. So I'll create a variable called sub_string. Now I'll assign this variable with a lambda function. I'll say lambda, my argument, let's say string. I'll give the colon and pass in my expression string in. Let's say my string has this message, welcome to Python functions tutorial. Okay, so we are going to check if a string, let's say in, to, welcome, Python, Java, anything, whether it's present inside this string which is welcome to Python functions tutorial. Now let me go to the next line. I'm going to print sub_string, and let's say I want to check for my string, let's say Java. If I run it, it gives me false because the word Java is not present inside my string welcome to Python functions tutorial. Suppose I write Python. Now one thing to note here is the P is small and here the P is in capital letter. If I run it, it again gives me false because Python is case sensitive. Now if I make this as capital P, it will result in true. Let's say I want to say, instead of tutorial, let's say I have training. If I run it, it tells me false because this word training is not there in the string welcome to Python functions tutorial. I'll change this to tutorial. You see here I have my result as true. Alright. Now let's see how to use lambda functions using filter function. So we are going to filter a list of numbers using a specific condition. So I'll create a list called num. Let's say it has values 40, 10, 40, then we have 56, 27, let's say 33, 15 and 70. So this is my list. Now I am going to use my lambda function along with the filter function. So I'll pass in my variable as greater. I'll say list, then I'm going to pass in the filter function, and inside the filter function I'll use the lambda function, and I'll have my argument as num and my expression. Let's say I want to filter only those values which are greater than 30. So I'll say num greater than 30. This is my expression or the condition that we want to check. I'll give a comma and I'll have my next argument as num, and let's go ahead and print the variable greater. If I run this, there you go. You can see here we have all the values from the list or the numbers from the list that are greater than 30. So we have 40, 56, 33 and 70. So 10, 27 and 15 are less than 30, and hence those three values were not printed. Now let's say you want to filter a list of numbers that are divisible by 4. So I'll create another list called list1, and let's say I'll have the same values in the list, so I'll just copy it and I'll paste it here, and I'll create my variable, let's say divide. I'll say divide equal to list1. I'll use the filter function followed by the lambda function. I'll say x colon, then I'll have my expression x mod 4 should be equal to 0. I'll give a comma and pass in my next argument as my list1. Now I'm going to say print divide. Okay, I'll remove the bracket here. There is no need of a bracket here. Cool. And we'll delete here as well. Now let's run it. Okay, there is one error here. This should be list1. Let's run it again. Okay, there is some error. Let's debug it. Okay, so this should be the function list. Cool. There you go. So here you can see we have two numbers 40 and 56 that are divisible by 4. The remaining numbers are not divisible by 4 and hence were not printed. Alright, now let's go ahead and explore how you can use the map function along with the lambda function. So the map function accepts two arguments, a function and a list. It takes that function and applies it to every element of the list and returns the modified list. So we'll create a list called list2. I'll say equal to, and again we are going to have the same values in the list as above. So I'll just copy those values or the numbers and I'll paste it here. Okay, now let's say I want to find the value of a number multiplied by 2. So I'll say, let's say the variable name is double the num or double the number. I'm going to use the list function followed by the map function this time, and then we'll have our lambda function. I'll pass in my argument as x colon followed by the expression, so x multiplied by 2. I'll give a comma and then we'll have the list, that is list2. There's a spelling mistake here. This should be list2. Alright, now I'm going to say print double underscore the underscore num. Make sure there is no space in the variable name. Now if I run it, you can see here we have multiplied every number in the list by 2. So 10 multiplied by 2 is 20, 40 multiplied by 2 is 80, similarly 30 multiplied by 2 is 66, 15 multiplied by 2 is 30, and again we have 70 multiplied by 2 is 140. So this is how you can use map function with lambda functions. Now suppose you want to find the power of a number. Let's say I want to find the power of a number raised to 3. So I'll create a list called list3. Let's say I have values 2, 5, 10, 6, 4, and then let's say we have 12. I'll say cube. So I want to find the value of a number raised to the power 3. So for that I'm going to use the map function followed by the lambda function. I'll pass in my argument x, and then here I am going to use the inbuilt power function in Python. So POW, my argument x, and this x I want to raise it to the power of 3, and then I'll have my next argument, which is list underscore 3 or list 3. Okay, now let's print the list. So I'll say list of cube. I'll run it. You can see here, so 2 raised to the power 3 or 2 cube is 8, 5 cube is 125, 10 cube is 1000, 6 cube is 216, 4 cube is 64, and 12 cube is 1728. Now coming to the final section of the demo, where we'll see how to use the reduce function in Python along with the lambda function, and then we'll use a lambda function within a user-defined function. So first let's look at how to use reduce in Python. So reduce applies a rolling calculation to all items in a list. You can use it to calculate the total sum or to multiply all the numbers together. So reduce function is a part of functools module. So to use the reduce function, you need to import the functools module first. So I'll say from functools import my function, that is reduce, and then I'll say, let's say I have my list 4 this time. I'll create a list. I'm going to take the same values as above and I'll pass in within a list. And now I want to find the sum of all the numbers that are present inside this list called list 4. So I'll do that using my reduce function followed by the lambda function. So I'll say x comma, and I'll give my expression as y colon x plus y, give a comma and pass in my last argument, which is my list itself, which is list 4. Alright, and then I'll say print sum. Let's run it. There you go. So 2 plus 5 plus 10 plus 6 plus 4 plus 12 is 39. So this is how you can use the reduce function in Python. Suppose you wanted to find the product of all the numbers present inside the list, so you can just use the asterisk instead of the addition operator. Now if I run this, you have the product of all the numbers that were present inside the list, that is list 4. We have 28,800. Now let me show you the final demo, that is using a lambda function in a user-defined function. So first of all, I'll create a user-defined function to calculate the value of a quadratic equation. So for some of you who don't know the formula of quadratic equation, it is ax square plus bx plus c. So we are going to use that formula in our function and find the value using lambda function. So I'll create a user-defined function called quadratic, and it will have 3 arguments, a comma b comma c. I'll say return, and here in the return expression I'm going to pass in my lambda function. I'll say lambda x, which is my argument. I'll say x colon, and then I'll have my equation, which is a x square. So I'm saying a multiplied by x raised to the power 2. So I'm using double asterisk plus b multiplied by x. So this becomes ax square plus bx plus I have my constant, that is c. Now just go to the next line. I'm going to create a variable, let's say f. I'll have my user-defined function name quadratic. I'll pass in the values for a, b and c. Let's say a is 2, b is 3 and c is, let's say, 5, and I'll call a of 1. The value of x is 1, the value of a is 2, the value of b is 3, and the value of c is 5. Now let's run it and see the result. So ax square plus bx plus c for a equal to 2, b equal to 3 and c equal to 5, the result is 10. Now let's change it to, let's say I want the value of x as 2. If I run it, you have the equation evaluated and the result is 19. Alright. So what is a class in Python? A class is a virtual entity or a blueprint for creating objects. A class in Python provides a means of bundling data and functionality together. You can think of a class as a school. So here school becomes your class. A school has attributes about the students, classrooms, labs, playgrounds, etc. Hence the school can be called a class, and classrooms, labs, desks, playground, assembly are the attributes or objects of a class. A class comes into existence when it is instantiated or initiated. We can create as many objects as possible in a class. Now in Python, a class is created using the keyword called class followed by the class name. The first string inside the class is called docstring and has a brief description of the class. Below you can see the syntax of creating a class in Python. We have the class keyword followed by the class name. This should be a valid Python name, and then you have a colon. Below that you have the statements that should be present inside the class. Now let's look at an example of a class in Python. So here you can see we have created a class called student, and we have two variables, the student ID and the name of the student. And after that we have created a function using the def keyword. So this is a user defined function, and the name of the function is called display. And inside the display function we are giving a parameter called self. So here the self parameter refers to the current class object and accesses the class variables. We can use anything instead of self, but it must be the first parameter of any function which belongs to the class. Now moving ahead, so let's look at what is an object in Python. So an object is also called an instance of a class, and the process of creating this object is called instantiation. Now you need to create an object of the class if you want to use the class attributes in another class or method. Now the procedure to create an object is similar to a function call. So below you can see we have created a object called stu, and we have called the class student using parentheses. So this is how you create a class, and after that we are displaying the message to be printed by calling the class name followed by the function which is present inside the class. So this example will create a new object instance named stu. We can access the attributes of the objects using the object name prefix. Now moving ahead, let's understand the initialization or init method in a Python class. The init method is similar to constructors in C++ and Java. All classes in Python have an init function. It is always executed when the class is being initiated. You can use the init function to assign values to object properties or other operations that are necessary to do when the object has been created. So the init function is called automatically every time the class is being used to create a new object. So here you can see we have used the init method. We have defined using the def keyword. Then we have parameters self, name and age. So we are calling the class using this object called s1, and then we have passed in the values for name and age, that is delay, and his age is 27 years, and after that we are printing the age and the name as well. Alright, now let's get started with our demo on classes and objects in Python on the Jupyter Notebook. So I am on my Jupyter Notebook. Let me first go ahead and rename my notebook to classes and objects in Python. Alright, I'll click on rename. First of all, let me show you how to create a simple class. So I'm creating a new class using the class keyword. So this is the keyword class, and followed by the keyword I have my class name called new class. One thing to note here is the class name should always be a valid Python name. I'll give a colon, and in the next line I'll just say x equal to 50. So this x is a variable which is present inside my class called new class. Now if I run it, I have my new class created. Now if you want to display the value of x, you can just say new class dot x. Now if I run this, you can see here I have my value printed, which is 50. Now we'll see another simple example to create a class and to call that class using an object. So I'll say class, then I'll say new class, let's say 1, give a colon, and I'll create a variable called x equal to 100. So my x is a variable which is present inside new class 1 and holds a value 100. Now I'll give a comment, create object. So to create an object, I'll define a variable called r. Let's say r stands for result, and then I'll say new class 1. So I'm calling my class, and then I'll say print r, which is my new object, dot x. Let's run it. You see here I have my value printed of x, which is 100. So this is how you can create or initiate a class using an object. Now let's see how you can use the self parameter in a class. So I'll go ahead and create a class called student, give a colon, then I'll have some variables or the attributes of a student. Let's say the student ID is 10 and the name is Anderson. Now inside the class I'm going to create a user defined function called display. So I've used my def keyword followed by the function name, that is display, and inside the display function I'll use self as my parameter, and then I'm going to say print self.id. I'll give a comma and I'm going to print my name. So I have written self.name. So I'll run this, and then we're going to create an object called s, and we'll call our class, that is student, and I'll say s.display. Now let's run it and see the result. You can see it here. We have called the class using this object called s, so it's displaying the ID that is 10 and the name that is Anderson. Cool. Now we are going to see an example where we'll pass a doc string. So in the slide we discussed that the first string inside the class is called a doc string and has a brief description of the class. So let me show you an example how to pass in a doc string. I'll create a class, again let's say called student, give a colon, and then we'll have our message, which is essentially a doc string. I'll say this is a student class. Then I'll create a variable called age. Let's say the student's age is 14, and then I'll create a user defined function called welcome and have my self parameter. After that I'll say print my message, let's say hi, comma, welcome to section, let's say B, and then I'll come out of the class and we are going to print class name, that is student. I'll say student.age, and then I'll say print, I'll just scroll down, student dot, then I'm going to use the function name, that is welcome, and after that to print the docstring message I'm going to say my class name, that is student dot, I'm going to use underscore underscore doc underscore underscore. Now we have created a class called student that has a variable called age, so we are going to display the age of the student, and then we are going to display the docstring. So here we are not going to print the message which is present inside the function called welcome. Let's run it. You can see it here. We have the message printed. So first we are printing the age of the student, and then we have the docstring message, that is this is a student class. Alright, now let's move ahead. We are going to see how to use the init function in a class. So I'll say my comment init function. Alright, I'll scroll down, I'll create another class called student. This time we are going to use the init function. So I'm writing def space underscore underscore init underscore underscore. Then we'll have our self parameter. Let's say the next parameter is name, and then we have the date of birth of the student. I'll say self dot name equal to name. Then I'll say self dot dob or date of birth equal to my parameter, that is dob. And then I'll say my object, let's say s1. I'm going to call my class student, and it will have values of name and date of birth. Let's say the name of the student is Harry, and the date of birth, let's say it is 29th October 1992. Alright, and finally we are going to print s1.name, and then I'll say print s1.date of birth. Let's run it. You can see it here. We have the name and the date of birth of the student printed. Cool. Now you can also modify the objects that you have created. Suppose I want to change the name from Harry to Virat, because my object was s1.name Harry. I want to change this to Virat. Let me show you how to do it. This is very simple. I'll just give a comment, that is modify objects. The way to do is you just say the object name, that is s1, followed by the parameter, that is name, equal to, let's say, Virat. Now if I print s1.name, I'll have Virat instead of Harry. Okay. Now if you want to delete the object properties, let's say I want to delete one of the properties. Let's say I want to delete name property of the student. To do that, I can use the del keyword followed by the object name, that is s1, and say s1.name. Now if I print s1.name, it will throw an error saying student object has no attribute name, because we are first deleting it and then we are trying to print it, and hence Python cannot recognize this attribute name. Now you can also delete objects, that is all the objects, using the del keyword. So this means we can delete both the objects that we created above, which is name and date of birth. So the way to do is I'll just say del s1. So it will delete all the objects, that is s1 in this case. I'll run this, and then let's say I want to print s1 dot date of birth. You see it here. Python says name s1 is not defined because we deleted it. Cool. Now coming to the final section of the demo, we're going to create a simple class with init method again. So this time my class name is, let's say, animal. Give a colon, and then I'll write my init method using the def keyword. I'll say self comma name, that is the name of the animal, as the parameter. I'll say self dot name equal to name, and then I'm going to create another function called def, which is essentially a welcome or a greet message, and that has a parameter, that is self. I'm going to print the greet message or the greeting. I'll say hi, my name is, give a comma, and then say self dot name. Now I'm going to create my object a1 to initiate my class. So I'll say animal, which is the class name. Let's say the name of the animal is puppy. Then I'm going to say a1 dot greet. I'll use parenthesis. Let's run it. There you go. You see here we have a message printed, hi, my name is, then using the self.name argument or the parameter, we are passing in the value that is puppy. Alright, so that was a demo session on Python classes and objects. So we saw how to create a simple class in Python, and then we saw how to create objects to call a class, and then we saw how to use the self parameter. After that we saw how to print a message that is present in the docstring of a class, and then we checked a few examples on using the init method in a class. Then we learned how to modify objects and delete objects in a class, and finally we saw another example on init method. Alright,
Let's glance at the topics. Object-oriented programming in Python, some major principles of object-oriented programming, and then we will touch upon topics like class in Python, objects, methods, inheritance, the concepts of inheritance, the different type of inheritance, then the definition and examples of polymorphism, encapsulation, and abstraction. So all these topics will be supported with examples and the relevant terminologies and definitions. Now, what is object-oriented programming? Python is an object-oriented language like any other programming language like Java, C++, and the object-oriented programming language concept is not new, and each and every mature programming language has these concepts imbibed in it. Now, the concept of object-oriented programming in Python focuses primarily on creating project objects and making reusable codes. So whenever we start programming at a large scale or for a big project, it is very important to identify the objects within that particular project which you want to define. Now, for example, in this presentation, what you are seeing is that we are covered with full of objects like car, dog, tiger, tree, or a balloon. So these are typical examples of objects which you encounter in day-to-day life. Now, what are the major principles of object-oriented programming? So these are the different kind of terminologies. Classes are there. There are objects. There are methods. Then on these classes and objects, you apply inheritance, polymorphism, encapsulation, and abstraction. Now, what is a class? Class is nothing but a collection of objects, or we can say a user-defined data type, right? So basically, it's a complex data type which has a collection of objects, and within the objects, you have primitive data types like int, string, float, etc. So a class also holds the methods, the functions which basically perform operations on these objects, right? And also it also holds on to the attributes of the objects. So let's see with an example, right? So if you have an employee class, then it would contain attributes and methods such as email ID, name, age, salary. These are the attributes. And on the methods like, perform task, give presentation, increase salary, etc., etc. These will be the methods. Now let's talk about what are objects in Python. Now, object is known as instantiation of a class, right? An object is a group of interrelated variables and methods. So when a class is defined, only the description for the object is defined. Therefore, no memory or storage is allocated at that point. So for example, if you see in this, motorbike is a class, but the different objects of that class are different kind of bikes by different brands like BMW, Suzuki, Royal Enfield. So they all have inherited the attributes of the class motorbike, and then on top of it define certain variables, additional variables and methods on top of it to enhance the motorbike and make it look different or function differently. Now, what are methods in Python? Methods are functions defined inside the body of a class, right? So basically methods are something which you perform on a attributes of a class, right? Method is a function that is associated with an object. So you create an object of a class, and on that object then you can execute those functions. In Python, a method is not unique to class instances. Any object type can have methods. And the methods define the behavior of an object. So that's why a BMW motorbike will be different from Royal Enfield, because the behavior is different. The methods are different. So if you see the example over here, you have a class bike, and in that there is an init function which will get invoked when you initialize the object of class bike, and then you can set the brand name and the year of manufacturing for that particular object. Now, inheritance. What is inheritance? Inheritance is something which you derive from a parent. So, inheritance is like creating a new class that uses all the properties and behavior of another class. Now, the new class is called the derived class or the child class, and the existing class whose properties are inherited is known as a base class or parent class. It provides, and the basic functionality, the usage of inheritance is that reusability of code. So if anything is defined in the parent class, then you don't need to rewrite that particular code in the child, you can just inherit it. So as I mentioned, let's take a look at the different types of inheritance which are available. You have single level, in which only one child is inheriting the properties and the attributes from the parent. Then you have multi-level, in which first child has inherited from the class A, class B has inherited, and then you have another class C which is inheriting from class B. So this is an example of multi-level, and we will be supporting all these concepts with an example in our Python notebook. Then there is hierarchical. Then there are two different classes which are inheriting from a single class, and then multiple inheritance, that single class is inheriting from two different parents. So these are different set varieties of inheritance basis what is the demand, what is the business requirement, you can define. Now what is polymorphism? Polymorphism in Python, what does it means? Polymorphism consists of two words, poly and morphs. Poly means many and morph means shape. So basically it means many shapes. So it means using a familiar interface for multiple forms, right? So you can use a single name of the method, and which can perform different behavior based on the object in which it is invoked. So in simple terms, we understand that a task can be performed in various ways. Let's support it with an example. Like you have a plus operator. Now the plus operator can be used for integer data types to perform arithmetic operations, whereas when you use plus operator to in string data types, it can be used for concatenation. So it's a very typical example, very good example in terms of how an same operator can behave differently basis what data types are being used. Now let's talk about encapsulation. Using OOPS in Python, we can restrict access to methods and variables. So basically in Python you can create something like as private variables, but of course you can't use a private keyword unlike Java. So in Python we use underscore or double underscore in order to define private attributes. So basically these attributes can be only used within the class and cannot be exposed outside a particular class. So we will see this with an example. Now, what is abstraction? Data abstraction and encapsulation are often used as synonyms. Abstraction is used to hide internal details and show only functionalities. For example, You know how to turn on or off a light using a switch, but you don't know what is happening behind the socket. Similarly, an abstract class cannot be instantiated, which means you cannot create objects for this class. You can only define the methods which have to be implemented by the classes which are inheriting the abstract class. So basically, abstract class provide only the method signatures, and rest the other functionalities and the implementation has to be done by the child classes. So let's now move to the our Jupyter notebook and we will start performing certain examples. Now, as we are saying, like Python has objects. So let's create an object. We will create a class bikes over here, and within the class we will define the init method, and in the init we will instantiate two variables, brand name and year. Now we will create an object of bike which we are calling as BMW, and another we will create an object called Ducati. So what we are doing in this two scenarios is that we are just instantiating the bike object with variable BMW and Ducati. We are instantiating. Now let's print the year in manufacturing year, the brand name and the year for BMW and for Ducati, and let's see. Right, so what we have done is we have created an object for bikes, one we are calling BMW and one we are calling Ducati, and how we are differentiating between these two bikes is basis the brand name and the year of manufacturing. Now let's take a look at the example of methods. I'm going to rewrite my init method, and now I am creating a function, a method of top speed and a function of type now. I'm going to create an object of bike. Now this method, this object bike, can invoke methods top speed and type because they belong to the same class bikes. So initially when I created my object bikes, I'm instantiating it with BMW and the year, and then I am making a call to the method top speed, and then I'm making a call to the method type and printing. So basically I'm printing the output of the function top speed and output of the function BMW, form the object BMW which is of class bikes. Now let's take a look at an example of single level inheritance. Let's create a parent class called animal and create a method called sound, and let's create a child class cat which inherits animal, And let me just put a method over here. Here's the indentation. Okay, so now I have object parent class animal, child class cat, which has inherited animal, and the parent class method is sound and the child class method is meow. So now I'll create an object called cat, and with this object I'll be able to invoke both child class method and the parent class method. And as you can see, the child class has inherited both parent and child class functions, methods. Now let's take a look at multi-level inheritance example. I'll start off with creating exactly the same parent class called animal. Then I'm already created another class. I'll create same child class cat, and now I'll create another class which will inherit cat class. So cat has inherited animal and cat child has inherited cat. Let's validate its syntax. And similarly now I'll create an object for cat child, and this cat child now can invoke the same methods which are in child, parent and the super parent. So this is an example of multi-level. This is an example of single level inheritance. Now let's take an example of polymorphism. We are going to create a class parrot and define the function fly and swim. Now we are going to create another class. Mind you, there is no inheritance here. We are just creating an independent class called penguin, and same methods now, the same name, fly and swim. Okay. Now let's make a function in which we will pass an object, and basis that what is the instance of the particular object bird, the corresponding method will get invoked. So let's see, in the method flying test, whatever instance of the bird object will be, the corresponding method will be called. So now let's create a object of parrot class, and then let's create a object of penguin class. Now in my flying test method, first I'll send a object of instance parrot, and then I'll send the object of instance penguin. So now basis the instance type, when this bird.fly method will be called, it will be called basis the instance. So in the first case, the parrot, it will call this method, and in case of penguin, it will call this method fly. So please note what is the output. The output is a parrot can fly, but a penguin cannot fly. And it has been decided by the Python at the runtime that which particular method to be invoked basis the instance. So it's a very important concept. Now let's take an example of encapsulation. I'll make a class cars, define its init method. Now within that init method, I have created a private variable with underscore underscore max price and given a value of 9 lakh. Now I am creating another function called sell, and in that I am printing the max price. And then I am creating another function in which I am modifying the private variable set max price. So I will pass any value in the set max price and it will replace the max price which I have set during the initialization at this point. Now let's create an object of class cars and see if I sell this, then the selling price is 9 lakh, what I had set at the time of initialization. Now what I'm trying to do is I'm trying to modify a private variable directly c underscore underscore max price, and I want to check if I'm trying to create modify a private variable, will it still show me 9 lakh or 10 lakh value? And it's still showing me the 9 lakh value. It means that I can't directly approach or access the private variable. I can only modify it if I access it through a method which is set max price. In this, now I am setting the max price to 1000, and now if I print what is my max price, it will print as 1000. So this is the concept of encapsulation. You have a private variable which is accessible within only the methods of the class. You can't access it directly. Now let's take a look at hierarchical inheritance. I'll create a class employee and create an init method. Within that, you have three variables: name, age, and salary. So an employee has name, age, and salary. Now I'm going to create a child class called child employee 1, which is inherited from employee, and child employee 2, which is also inherited from employee. So what I'm going to do is I'm going to create a object per child class and print. So this is a typical example in which you have two child classes which have inherited from the single parent, hierarchical inheritance. Now let's take a look at our last concept, which is abstraction. So now I'll create a class car and define a method mileage, but I am not giving any definition to it. I'm just giving a signature mileage. The child classes which will inherit abstract class will be giving the definition. So I'm creating a class BMW, which has inherited the car ABC car, but given the definition now. Similarly, I am creating another class Jaguar, which has inherited the class car, but now it is giving a different definition. It's printing mileage 25 km/h, and another class Range Rover, and another class Renault. Okay, so 4 classes which have implemented the abstract class method mileage in a different way. Now I'll create an object of first BMW and invoke method mileage. So it has invoked the method mileage on BMW car and printed mileage is 30 km. Similarly, I'll do for Renault. Jaguar and Range Rover. So if you see, the parent class, abstract parent class, has not implemented the method but just given the signature of the method, and all other classes have implemented it, and that's the concept of abstraction. We're going to talk about the concept of inheritance, the types of inheritance which are applicable. So the different kind of inheritance which we're going to talk about are single level inheritance, multi-level, hierarchical, and multiple inheritance, and we're going to support each concept with an example. Before we begin this session, I just want to highlight that inheritance is not a new concept in any of the programming languages. Just like in Python, this concept is applicable across multiple programming languages like Java, C++, etc. Now, what is inheritance? Inheritance provides the reusability of a code. It allows you to inherit what you have written in a particular class or a piece of code, and you don't need to rewrite it. You can inherit it. So that is the main purpose of inheritance. It is creating a new class that utilizes the properties and behavior of an existing class. So we will support this with an example. So if you take a look at the syntax, the sample syntax over here, you have a base class and you have certain attributes, functions associated with the base class, and then you have a derived class in which you extend, basically you inherit the base class and you inherit the properties of the base class. Now, the new class formed is called the derived class or the child class. You can call it anything, derived, child, or subclass. And the existing class whose properties are inherited is known as the base class, parent, or superclass. These are synonymous. So anywhere you hear that, okay, you're working on a child class or derived class, you can easily figure out that you're talking about a derived class. And whenever there is a reference to a parent or a superclass, it means we're talking about the base class, right? Now, with this concept, with this idea, let's move ahead and look at the different types of inheritance which are possible in Python. Now here we are trying to display pictographically, diagrammatically, the different kinds of inheritance, and this will make understanding more clear. Now let's talk about first single level inheritance. You have a class A and you have a class B. So basically only till class B, only single level child is inheriting the attributes, the properties of class A. So that is what we call as single level inheritance. Multi-level is you have multiple level of inheritance. In, for example, class B here inherits class A properties and class C inherits class B properties. So ultimately you can see that the properties get trickled down till class C, right? So that is the example of a multi-level, right? Next is hierarchical, in which two classes are inheriting from a single class. Class B is also inheriting from class A and class C is also inheriting from class A. So both class B and class C are kind of siblings to the parent class A, right? Multiple inheritance, it means that a child class is inheriting properties from two parent classes. So in this example, the class C is inherited the properties of class A also and class B also. So we will be looking at these examples when we will be running in Python. Now let's take this example with a real world object, right? Let's first try to give you a view of how we are going to, how, what we want to explain in the inheritance with real world objects, right? Now here we are taking an example of a black and white TV and a color TV. Now, single level inheritance. In this type of inheritance, there is only one single derived class from a single base class, as I mentioned earlier. So, for example, you can assume there is a class called black and white TV. And what are the attributes of a simple black and white TV? It has a regulator, it has a sound adjustment. Now, there is a child class called color TV which inherits the basic attributes. Of course, a color TV also has a regulator, a sound adjustment, but additionally on top of it, it also provides new features like color picture and cable connection. So now, what do you understand by this is that the child inherits the basic properties from the parent class, but it also adds on the new additional features. So the color TV does not need to rewrite or the functionality of a regulator and the sound adjustment, it has inherited it. Multi-level, very similar to single level, but now we are adding more features. So like in the previous example, color TV inherited the features of black and white TV. Now we move a step ahead. Now there is another classification, another advancement of Wi-Fi LED TV. So that has also inherited the features from color TV, right? So it's a multi-level inheritance. So just to reiterate, the black and white TV had channel, regulator, dish antenna. The color TV added additional features of color picture quality and cable connection. And the Wi-Fi enabled TV added the new smart features to the TV, which it inherited from the color TV. Multiple inheritance. Now, in multiple inheritance, the derived class is inherited from more than one base class, right? So now, for example, over here, you have a class called Android, which is an Android operating system based class. And one is the Wi-Fi LED class, which has the Wi-Fi features of like sound, picture, Wi-Fi enablement. And if you combine all these features and bring it into another child class, that class is the Smart TV class, which has the features of Android and the features of Wi-Fi LED TV. And then you call it as a Smart TV. It has all the Android applications, it has the Wi-Fi features and etc. So this is the example of multiple inheritance, getting the best of all the parents. Hierarchical, if more than one class is inherited from the base class, right? So now if we just tweak our prior example and just rephrase it, what we are saying is now from the black and white TV you can also make a color TV, you can also make a smart TV, or you can also make a Wi-Fi LED TV, right? So there is no restriction as such. So basically the color TV is also inheriting the features of a black and white TV. Smart TV is also inheriting the features of a black and white TV. and the Wi-Fi LED TV also is inheriting the features from black and white TV. So it's a very typical example of a hierarchical inheritance. So now let's quickly look at the examples. Okay, so let's start off with a very simple single level inheritance. Let's make a class and create a function called speak, and print something. Okay, now let's make another class. So what we did was we created a class called Homo sapiens, and now we are creating a class called man, which inherits the attributes of Homo sapiens, and we say create a function which is specific to man. So Homo sapiens has a function which called speak, and man has a function called talk. And let's print it. Now let's create an object of man. Now what does this signify? The man class is also inheriting whatever is there in Homo sapiens. So man can even talk and he can even speak, right? So what we are going to do is, first we are going to execute the function speak. So the base class function got called speak, and it is printing Homo sapiens speaking, and also we can call the child function man talking. Okay, so if you see, this is the basic difference which we want to highlight, that just you have created the object only for the child class, not the parent. So now by making the object of the child class, you can invoke the parent class function as well as the child, because the child has inherited the parent features. Now let's take an example of multi-level. So we will continue from our previous example. We will create a class Homo sapiens, define an function speak, and print. Now we will make another class man. Now we are saying man can walk, so we are saying man walking. Now this is the third level, this is the multi-level, man child, and we are saying that a man child can eat. So ultimately the man child can speak, can walk, can eat. All three operations can be performed. So we are going to make an object of man child, and now Python will allow us invoke walk function, speak function, and eat function. So this is a typical example of multi-level hierarchy. Now moving to our next type of inheritance, which is the multiple inheritance, where the child is deriving attributes, properties from two parents. So we will now create a class called calculation1 in our example, and let's make a function sum, and it will return a calculation x plus y. Second, calculation 2, and let's create operation subtraction, and it will return x minus y. Okay. Now we will create the derived class which is inheriting both calculation 1 and calculation 2, and let's create its own function called multiplication. Okay, so derived class now has a sum function, subtraction function, and multiplication. Okay, so let's create an object for derived, and now let's invoke the relevant functions. So sum 120, subtraction, it should say minus 40, and multiplication 1000. So if you see, it's a different from multi-level, it's multiple. It means that the child class has inherited from two parents its relevant functions, right? And that's how we are able to call them in the derived class. Now let's take another type, hierarchical inheritance. Okay, so in hierarchical inheritance, let's go back to our example of, first we have the black and white TV, and we will create a function called antenna. Print channels are telecasted through antenna. Then we will create color TV, and we will define its own function called cable connection, plus it has inherited the function called antenna from black and white TV. Here it is. Okay, now we are going to create another class called as Wi-Fi LED TV, which is also inheriting from black and white. Now in this we are defining Bluetooth tethering function. Okay, and let's make another smart TV. Okay, and then we are gonna, you can watch Android applications on OTT platform, right? So this is the class of smart TV. Okay, so what we have done eventually over here is we have created a black and white TV. Color TV also inherits from black and white TV. Wi-Fi LED also inherits from black and white TV. Smart TV also inherits from black and white TV. Okay, now let's try to create the relevant objects. We will first create an object of color TV, then we will create Wi-Fi LED TV, and then we will create smart TV. Okay, now we will have the relevant functions available to invoke. So both all the children objects now will have an antenna function, A1, A2 and A3. All three are having the antenna function, so we can just try to print it. Okay, and then we can invoke the relevant child functions. A1, cable connection, Bluetooth tethering, and Android applications. So if you see, this is an example of hierarchy. You have color, Wi-Fi, LED, and smart TV all inheriting the black and white TV features and its own features. Okay. Now, along with this concept, let me just also introduce some relevant concepts which are applicable along with the inheritance concept, which will be helpful. I also want to show you the example of init function. Init function is a constructor in Python language, and it is called by default whenever you instantiate an object. So let me give you an example over here. So here you have a class person, and we are just defining the init function, the constructor. Okay, and we are just defining certain attributes, instantiating certain attributes in the person, first name and the last name. And another function which I am calling is the print name. And I'll print the name. It's a straightforward function. Okay, so what I'm doing is I am creating a child class now called as student, which is inherited the features, attributes of the person base class, and I'm also making a constructor for student, and from student I am invoking the constructor of the person class, right? So now if you see, I'm going to make an object of student and initialize it with the self, the first name and the last name, and eventually the parent class init function is being called, first name and the last name, and this function def print name, it will print James Anderson, right? As I have already initiated the parameters. Okay, so if you see now, what have I done? I have the attribute values in the parent class are getting printed by invoking the constructor of the child class. So what happened when you invoke student? By default, this init function got invoked. The parameters of James and Anderson got passed. Then from person, you invoke the constructor init. And here now, the first name and last name got initialized, and then it got printed. So this is the basic feature of a init function. Now, like the way I have called person.init over here, I can also make a call to super. There is a keyword called super keyword. So let's just take an example of super keyword. Okay, let me have my child class like the previous one, parent class, the person class, and I'll have to just make a change in my student class. In the init function, instead of parent dot init, I will call super dot init. This is the keyword super function, which will always invoke the parent class, gives you the handle to the parent class, and then you can invoke the relevant method, and the invocation methodology will be the same, and you can check the output. It's going to be the same, but it's that the syntax is different. There is another keyword which is available for you to invoke the parent. So you don't need to know the class of the parent. You can just make a call to the super. Now let's also take a look at another utility function called is subclass, right? So what we are going to do is we are going to create a function calculation1, calculation2. Okay, so we have created two classes, calculation1, calculation2, independent classes, no one inheriting each other. Now we are going to create a derived class. Now this is the example what we had done earlier, very similar to multiple inheritance. So we are just actually recreating a multiple inheritance example. Okay, so you have a derived class which has multiple inheritance from calculation 1 and calculation 2, summation, multiplication and divide. Relevant functions are there. Now we will check which class is a subclass of which one, right? So let's create an object of derived. Now what we want to print is that whether derived is a subclass of calculation 2 and it should return true. And let's see, another is calculation 1 a subclass of calculation 2, it should return false, right? Because these two are independent classes. So is subclass is another function which is available in Python which helps you decide, you can check whether which is a derived class and which is not a derived class. Next, let's take an example of another function called isInstance. Okay, we will take the same set of functions, create an object of derived and check whether the object D is of which, is it of a instance of class derived or not. It's true. So instead of derived, if I make it as calculation2, for example, now if I say C equal to calculation1 and say C is instance of derived, it should say false. But if I say calculation1, it should say true. And if I say calculation2, should say false, because calculation class is an independent class. D is a derived class from calculation 1 and calculation 2. So basically D is instance of both calculation 1, calculation 2. So it will always return true. We are going to talk about what is a Python iterator, what are iterables, right? What are the iterable objects, how an iterator works, and then we will also discuss about how to throw a stop iteration exception. Basically, when you reach the end of a list, then you can throw a stop iteration exception, and we will see that with an example. Now, what is a Python iterator? Python iterator is an object that can traverse through iterable objects in Python like lists, tuples, dictionaries, sets, and returns data one element at a time. So basically you can traverse through these lists one at a time and then you can use it as per your custom requirement. But iterator as an object is available to you, is a tool available to you in order to traverse through each and every element. Now, they are implemented within for loops, comprehensions, generators in Python implicitly. They are not visible upfront, but they are hidden in plain sight. So basically, when you're using loops, when you're using generators, comprehensions, implicitly, Python is actually converting them in the backend in an iterator object and giving you the results. Now, what are iterables on which you can iterate? Lists, tuples, dictionaries, sets, as I mentioned, are all iterables or iterable objects. Other than these, you can't perform any iteration. If you have not created an object of list, tuple, or dictionary or set, then of course your iterable will not be of any use. And these objects internally possess an iter method, ITER method which is used to get an iterator, a handle to an iterator, and then you can start looping it, or you can start accessing the elements of the iterator. Now, how iterator works? Python iterator implements internally these two methods which you are seeing on the screen, underscore underscore iter underscore underscore brackets and underscore underscore next underscore underscore brackets. Now these two methods are implicitly implemented by Python for any internal implicit iterator object. But if you have to write your own custom iterator, then you need to override these methods, and I'll show you in my examples in Jupyter Notebook. The iterator object is initialized using the iter method. So basically, whenever you have to create an iterator object, you need to initialize it with iter and then use next method in order to traverse through it. Now, stop iteration exception. So as I mentioned, when we reach the end of an iterable, right? Like suppose you have a list or a set which has a length of 4. When you have ended the fourth element and you're trying to access something beyond fourth element, which is fifth, then of course you can implicitly raise a stop iteration exception, or Python will throw it. So we will see that with an example, but you will get a stop iteration exception. Now, so to prevent, in order to handle it or manage it in your code, we use stop iteration statement to raise an error. You can raise your custom error. So you can catch this exception and then raise your custom error in the underscore underscore next method. So now let's support everything with our examples. Let's start with a very basic example of an iterator. Now let me create a list with just 4 numbers, and as I said, I'm going to initialize my iterator with iter method. So now I have created a list and now I am initializing it with iter. Okay. Now using next, I'm going to print my first element 4. Okay. So it means the iter internally has given me handle to the first element, and now as many times I move print next, I am moving to the next element. So now I'm also going to show you a different syntax. This is a syntax, but the output will be same. It's a different syntax to invoke underscore next. So its output is going to be same, but the syntax is only the difference over here. So you're going to get access to the next element and then my fourth element, which is 33. Now I have traversed through all my 4 elements. Now what will happen if I again do next? I have ended, I am at the end of my list. So I'll get an exception of stop iteration, right? And this is thrown by Python. Now let's take another interesting example. If I want to perform iteration on strings. So I have created a variable and I have initialized it with geeks. And now I have created an iterator on top of this string variable, and I'm going to traverse it till the time I reach the end of my string. So let me iterate it, and I'm going to iterate till the time I get the stop iteration exception. So also I'm explaining here how to cleanly handle the exception, accept, and then break. If I get the exception, I'll break out of this program. And here you get the result. All the letters of my string geeks has been printed individually. And I think it's a very important example, interesting example, that how a string has been converted. Now, point to be noted over here is that Python has internally invoked underscore underscore iter and underscore underscore next methods, which it has implicitly implemented for string iterators. So you don't need to do anything. Now let's take another example to how to traverse through a list using for loop. So I'm going to leave for object in list and just print the list. This is without an iterator. I'm just printing my list. So I'm just trying to show the difference, that if you use an iterator or you do not, but how you can access the elements in the list. Now let's take an example of how I can write my own custom iterator. Okay, so I'm creating a class where I'm overriding the init method, basically initialization of my class, where I'm gonna initialize a variable max with 0, and then I am overriding. This is the most important point over here. I am overriding iter method, and then I am writing another overriding the underscore next method, where I am adding 6 to my number and then incrementing my loop so that I can move further. So in this underscore next method, I am just moving beyond adding 6 and till the time I reach the max variable. So when I'll invoke my class, I'm passing 9. So it means that I should not go beyond uh, 10. Basically, I should start my iteration from 6 and will not go beyond 10. 9 plus 1. So I should get numbers which are between 6 to 10 as per my expectation. Now, before we diagnose the output, most important point is that how you have converted your class to an iterator over here. In order to make a class an iterator, it is mandatory you override iter and next methods, which you have done over here. So now let's print. Okay, so 6. So my number started with 0, initialized with 0, and I added 6 to it. So my first result is 6. And now if I keep printing, I will get one value incremented. 7, 8, 9, and 10, right? So this is the expected output, right? Now, another example on the same lines, I'm going to print the first 20 numbers using my iterator. So I am going to override the iter method and underscore next method, my numbers. Now in this underscore next method, I'm just incrementing my number by 1, not by 6, and I'm going to stop at the limit 20. So like I showed in my previous example, I'm going to initialize first my class and then initialize my iterator and just then gonna run a for loop on it. And here is the response output. I have printed the first 20 numbers because I have created this limit. So I'm initializing with 1 and going till the max 20 number. But the point is, it's not the output which is more important over here. The most important concept over here is that you have created your own iterator. We will talk about what is a generator in Python. We will talk about the advantages of using generators and the utility of the next function, which allows us to operate with generators and print the values within the generator. So we will see all these concepts with an example. Now, what is a generator in Python? Python generators lets you create your own iterative functions that return the traversal object with a sequence of values. So basically, when with iterators, you can only work on list, tuples, or sets, but with generators, you can convert your functions into iterative functions itself. And we will see that when we will be working on a Jupyter notebook. Now, another important feature in a generator function is that a yield statement is used rather than a return statement. So basically, the return statement terminates a function entirely if you use it within the function and basically return from the statement, while the yield statement pauses the function there it is and holding all its states, all its variables, the values in the variables, and then continue thereafter on the successive calls. So basically, in a generator function, you use yield functions and I will talk about the utility of this yield statement within the generator function, how it helps in generating pipeline. But just to hold a thought over here and understand the concept, the yield statement basically holds the processing of the function at that point. And if you make an invocation of that generator function again, it starts from there itself where you left it. As compared to return statement, return is a general exit. If you make an invocation of the return statement from a function, it will restart again from the beginning if you invoke it the next time, and that's the basic difference. So what are the advantages of using generators? It's very easy to implement. The code syntactically it's very simple. Within a few line of codes you are able to achieve the functions and able to implement the logic. You can generate infinite sequence. You don't need to provide the range values, the starting and ending. You can generate an infinite value, and I'll show you that with an example. And generators are very memory efficient. They are the most memory efficient ways of processing huge data sets. They process the data incrementally and do not allocate memory to all the results at the same time. They do that incrementally. They really come in handy when implementing data science pipelines for huge data sets in a resource constrained environment where you have constraint on the RAM and the other resources of the hardware. Now, another biggest advantage is pipelining with generators. Generator pipelines are a great way to break apart complex processing into smaller pieces when processing list of items. So basically you can break your complex code into smaller pieces and then invoke them as a generator recursively, and we will see that how. But basically, you are making the complex code look simple and making it invoke in a pipeline fashion. Now, the another most important function in order to deal and operate with the generator is the next function. The next function is used to retrieve elements from a generator object and then print it. So that's how you basically interact with your generate function. You cannot do that until unless you don't use next function. So now let's quickly jump to our examples which we are going to support for each of these concepts. Now let's start by basically creating our first generator function. I'm going to create a variable n and initialize it with 1, and I'm going to do a print. This is just for my logging and showing on the console that where we have reached, and then I'm going to say yield n. Okay, so now here we are not exiting the function, we are just saying that just this is the point. If you invoke the function again, the function will start from this point on. Now here you will increment, and again this is the second checkpoint in the code, and similarly this is the we're gonna have a last checkpoint in the code. Now in order to create my generator, now this is the my generator initialization, my gen. Now if I use the next function and invoke my generator, now my generator has been executed till this point, right? N equal to 1. Now if I make a second invocation, now it has moved ahead and printed the second. So it is behaving like a loop. It is now behaving like a loop. It is behaving like an iterator. But I have not created any list. I have not created any tuple, but I am basically traversing through the variables, through the sequence of the variables within my generator. And if I again print it. This is my last. This is printed at the last. So all the checkpoints within my generator have been executed. Now, the same example which I have over here, let me call it in a loop. Okay. So what I'm going to do is I'm going to remove these invocations and just replace it with a loop call, right? So this generator functions remain as is. Now, instead of writing my next function 3 times, I am going to just invoke my generator in the for loop, and this will get invoked the number of times I have yield in my generator, and my output should be the these logs which I have created, and of course the variables. Yeah, so see now what has happened is now the output is all these 3 print commands have been executed, plus the variable values of n has been printed at each checkpoint 1, 2 and 3. So when I initialize my item variable during the for loop, this item consists of the variable values which are there in my generator. Now I'm going to show you example of if I use a return statement in my generator. So I'm going to create another generator and provide a value. Now during this, in middle of this generator, I'm just invoking return, and then I am printing my second checkpoint and then the last checkpoint. Now I'm going to initialize my generator. Now if I invoke my first element of the generator, I'll get it. There's no problem because I printed the first item, I got the value of my yield, and then I returned. But now if I invoke my second element in the generator, but before invoking second, I have already given the return statement, my generator will exit and I'll get the stop iteration error. Now this is a Python generated exception which is denoting that you cannot move beyond the first item because you have returned from the generator over here. So that's the difference. If you just remove this, comment this out and then run it, you will get your second item. So it's not the code exits if you write return over here. So I hope you're able to understand the difference. Now let's take another example. Now here we are going to create a list, and how implicit list, like the legacy way we have been creating in Python, differentiates like the way we are creating a generator. So what I'm doing is I'm creating a list with random numbers, and then another list in which I'm just square rooting the numbers in that list. And similarly, I'm also creating a generator which I'm expecting the same output in the new list as the generator, but I'm going to show you different ways of traversing the generator as compared to a list. Now, if you see this list underscore, if I just make a print call to this list, it's going to straightforwardly square root the numbers and give me the output 4, 9, 64 and 100. But if I print the generator, I will not get the expected output what I'm expecting. I will just get the generator object, which is not what I desire. So basically you can't just print the generator like the list. You have to either use the next, or you have to use the for loop, which I had shown earlier, and print each and every item within the generator. Now this is the output which I was expecting. I was expecting the line by line output of each and every element in my generator: 4, 9, 64 and 100. Okay. Now this for loop is taking care that it is not exceeding the number of items, the length of the items in the generator. So this is automatically taken care by this syntax. But if you don't take care of it, then you will get an exception. Let me show you another example. If I create a list and now I'm creating a generator, which is square of all my elements. So now one by one, instead of the loop, I'm one by one printing the output. Second output, third element output, fourth element output. Okay, I have 4. Now if I try to again print, I'm exceeding the length of the list, I'm going to get an exception, stop iteration exception, because I'm exceeding the length, right? Either I use the for, or if I'm using individual print and next function, then I have to take care that, okay, how many elements are there in the list, and I cannot exceed beyond that, else the Python will raise an exception. Okay. Now I'll show another example of highlighting the difference between next and the for loop printing. I'm going to create a generator for 2 to the power n. So I'm initializing n with 0 and then just raising it 2 to the power n. Now here I'm initializing my generator and printing it. And I'm getting the expected output as 2 raised to the power 0, 1. Okay. Now another way of doing this job is I loop over this and I get the same output. So if you see, it's only, I do not have only one element. So either you use for loop or you print using next, the output is going to be same. Now, another important concept which I talked about, if you want to print infinite numbers, so, or you want to do some infinite calculations, I'm going to use print in all even numbers. So I'm going to write a generator which is going to print infinite number of even numbers. So I have created a generator and now I'm going to invoke this, and mind you, I have to kill this job because it's going to keep running. It's going to keep running because it's constantly generating the numbers, even numbers. So I would have to stop this. But if you see, otherwise this is not possible. In any for loop, the basic for loop, you have to give a range, start and end of the length, but using a generator, you can do infinite looping. Right, because here I have to kill this job, I have to do a keyboard interrupt. Now I'm going to show you an example of how you can use generators for creating a pipeline. So I'm going to take example of Fibonacci series, create an example of Fibonacci, two variables initialized with 0 and 1. And now I'm going to write the logic of Fibonacci, adding the two numbers to itself subsequently. And I'm going to add yield. Now this is my generator. This is my one generator, and I'm going to create second generator of square. So I'm going to show you in Excel what logic I'm going to apply and what will be my expected output. So I am now squaring the numbers which I'll get out as an output of Fibonacci. Okay. Now I'm gonna I'm creating a pipeline like this. First, I'm going to generate Fibonacci series for the first 10 numbers. Then I'm going to find the square of each of the Fibonacci numbers and add it. So if you see this representation in Excel, I'm going to generate, these are the two variables which I've already initialized, X and Y. And from here on, these 10 are my first 10 Fibonacci numbers. I'm going to calculate the square of these numbers, 1, 4, 9, 25, and till 55, the square of 3025, and then add these numbers, and I should get the output of 4895. So if you see, one function generator, second generator, and the third calculation. Now this whole has been done in one single line of code. You have created two generators and just invoked them in a single line pipeline. So entire looping, and you don't have to write the looping operators, the for loop, and you don't have to worry about writing all that complex logic. It is all encapsulated within this. Now let me run, and I'm going to expect this output 4895, and here is my output, right? So in the hindsight, what Python has done is it has generated these Fibonacci numbers, found the square of these numbers, and then added it in single line. And now this is the convenience, simplicity, which I was talking about earlier. Now let's take another example of Fibonacci. I'm going to create a generator again, initializing A and B with 0, 1. And this time I'm taking an example of printing the Fibonacci in two different ways. Okay, I'm going to print the first 5 Fibonacci series number. The first way I'm going to do is I'm going to print the next function 5 times because I'm generating 5. So let me run this. These are the first 5 Fibonacci numbers, 0, 1, 1, 2, and 3. And I'm also going to use a loop in order to print. So now in the loop, I'm invoking the 5 Fibonacci numbers and run it. So either you can make 5 individual calls, or you can use the for loop, but the output is the same, and you're using a generator.
Now let's learn about what is scope in Python. So scope in Python is the area or the region of a program where you can access variables, functions, and objects declared. The scope defines the accessibility of the Python object. So the objects cannot be accessed from anywhere in the program. Variables are not visible to the entire code, so their visibility can be restricted. Now, scope verifies which variable to be accessed. A variable declared inside a function belongs to the local scope of that function and can only be used inside that function. Now, whenever you use a name such as a variable name or a function name, Python will search through different scope levels or namespaces to determine whether the name exists or not. So Python resolves names using the LEGB rule. The LEGB stands for local, enclosed, global, and built-in scope. Now talking about local scope, the variables which are defined in the function are called local scope of the variable. So these variables are defined in the function's body. Now talking about enclosing scope, now this scope only exists for nested functions. If the local scope is an inner or nested function, then the enclosing scope is the scope of the outer or enclosing function. Coming to global scope, the variable which can be accessed from anywhere in the program is known as the global scope. Such variables can be read inside or outside the function. Now the global scope is often implemented when we want to use the same variable name in the rest of the program. Coming to the final rule, which is B, that is built-in scope. So if a variable is not defined in local, enclosed, or global scope, then Python looks for it in the built-in scope. Now this scope contains names such as keywords, functions, exceptions, and other attributes that are built into Python. Now if you define the same variable name inside and outside of a function, Python will treat them as separate variables, so two separate variables, one available in the global scope that is outside the function and the other available in the local scope that is inside the function. Now let's head over to our Jupyter notebook and we'll try scopes in Python with hands-on demonstrations. Alright, so I'm on my Jupyter notebook. Let's start with our examples. First we'll look at local scope in Python. For that, I'm going to create a function called fun, and inside the function I'll create a variable called s, which holds, let's say, an object called Simplilearn, and then I'm going to print the variable that is s. Now in this case I have defined my variable inside the function, so this becomes accessible only inside the function. Now if I call the function using the function name that is fun, and if we run it, you can see we have the message printed that is Simplilearn. Now we'll see another example. So suppose we'll try to access it outside the function, it will throw an error. So I'll just give a comment, try to access it outside the function. Alright, so again I'll create a function called, let's say, fun1. I'll give a colon, and here I'll say, let's say, s1 equal to Simplilearn, and now I'll give a comment here, print s1. Then I'll call my function fun1 and I'll try to print the variable s1 outside the function. So here s1 has a local scope since it is defined inside the function, but I'm trying to access the variable outside the function. Let's run it. You can see the error here, name s1 not defined. Now if I give a comment and run this, you see there is no message, and let me just remove this comment and print it. You can see we have the s1 variable message printed, that is Simplilearn. So this is how the local scope of a function works. Now let's see an example of enclosed scope, which is function inside another function. So I'll create a function, let's say func, and I'll use the variable this time s2 equal to Simplilearn, and then inside the func function I'll define another function, let's say infunc, which basically stands for inside function, and then here I'll say print s2, and we'll call the inner function that is in func, and then I'll call the outer function. Let's run it and see the result. You can see here we have the message printed Simplilearn. I'll just edit this message, let's say welcome to Simplilearn. Now if I run this, you can see we have updated the message here. Now for the enclosed scope, you need to define an outer function enclosing the inner function like we did here, and you can also comment out the local variable of the inner function and refer to the variable using the non-local keyword. Let me show you an example around this. Suppose I have a global variable called msg. I'll say this is a global scope message. After that I'll create a function, so I'll define a function called outer, and I'll use the same variable name, that is msg, and my message would be this is an outer variable. After that, I'm going to define another function called inner, and this will have the same variable, that is msg, and my message would be inner message variable. Now, as I mentioned before, I need to comment out the local variable of the inner function, so I'll just comment this out, and then I'm going to say non-local, which is the keyword. So I'm referring to the variable using the non-local keyword. I'll say non-local variable name, that is msg, and now I'll print msg. We'll come out of the function and we'll call it inner. After that, we'll call the outer function, and then I'm going to print. I'll just scroll this down and we'll say msg. So here what we are doing is, so this is an example of an enclosed scope, so where we have defined the outer function enclosing the inner function, and we have commented out the local variable of the inner function, and we are referring to the variable using the non-local keyword. Now let's run it. You see here I have my two print statements working here. The first one is, this is an outer variable, you can see here, and then I have print msg, so this is a global scope message. Cool. Now we'll see an example of how the global scope works, though we have already seen an example above. So this was an example of a global scope. Now we'll see a few more examples around global scope again. Suppose I have a variable called s3 equal to, I'll say Simplilearn, and then I'll declare a function func1. I give a colon and then say print s3. Now I'll call the function func1 and will print it s3. If I run it, you can see here I have Simplilearn printed twice, so I have used the same variable name s3 inside the function. So this Simplilearn is for the local scope s3, that is this one, and outside the function we have printed s3 again, so Simplilearn twice. Alright, now let me show you another example about using the global scope. Create a variable msg1. Let's say my message is welcome to Simplilearn Python programming. I'll define the function func2. I'll give a colon and I'll use the same variable that I used or declared above, that is msg1. I'll say this is the inner msg1 variable. Then I'm going to print msg1. After that, I'll call my function func2 and I'll print msg1. If I run this, you can see I have the two messages printed. First is, this is the inner msg1 variable, and the second print statement will print the global variable message, that is welcome to Simplilearn Python programming. Cool. Now you can also use the global keyword inside the function to convert a local scope into global scope. Now I'll just give a comment using global keyword. So I'll define my function func, let's say 3. I'll give a colon, and using the global keyword I'll say s, and I'll say s equal to Simplilearn. Now let me call func3 and we'll print s outside the function. Now one thing to remember here, my variable has been declared inside the function, but since before declaring the variable I have assigned the global keyword to s, so this now becomes a global scope variable, so you can access it outside the function as well. Now if I run it, you can see it here. I have my message printed. Simplilearn, if I say hello, you can see it, hello printed. Cool. Now we'll see another example of using the global scope. Let's say I have a variable called A1, which is India, and then I'll create a function called my country, and I'll use the global keyword and say A1, and after that I'm going to say A1 equal to, I'll change the country to, let's say, France. Now let me call the function my country and will print A1, and you can notice the difference in the result. So here initially I had defined India as a global variable, and after that I'm assigning the same variable name with a global keyword, and hence it will take the updated value for A1, and you can see here the result is France. Now finally let's look at built-in scope in Python. This is the final example in the demo session about scopes and arguments in Python. Cool. So this example is a bit different from the previous few examples that we saw on local scope, enclosed scope and global scope. So here I'm going to import Py from the math module. So I'll say from math import Py. So this example includes global scope, enclosed scope, as well as local scope, and of course we have the built-in scope as well. Now what I'll do is, first I'll give a comment and create a variable called Py equal to, I'll say global Py variable. I'll say this is a global Py variable, and then what I'll do is I'll say df. Let's do one thing. First of all, we'll remove the comment, and now I'll create a outer function. I'll give a colon and say the variable Py. I'll say outer variable Py, and then I'll create a nested function with the name inner, and I'll say Py equal to inner Py variable. Now I'm going to say print Py, and after that I'll call the inner function, and next I'll also call the outer function. Now if I run this, you can see the result, inner Py variable being printed, which is this print statement. Now what I'll do is I'm going to comment out the global scope variable and I'll also comment out the first outer function variable that I defined. I'll comment this out, and I'll also comment the inner function pi variable. Now if I run this, you see the result here. It prints the value of pi that was imported directly from the math module or the math library. So here pi is not defined in either local enclosed or global scope. So the built-in scope is looked up, that is the pi value imported from the math module. So this is an example of built-in scope in Python that uses inbuilt functions, modules and objects that are available in Python.
We are going to discuss what are Python modules, why do we need to use them, what are the different types of Python modules, and how differently, in different ways, we can import these modules in our code. Now, a Python module is nothing but a simple Python file with .py extension, including the statements and the definitions. So basically, you need to prepare a module file with all the functions which you want to import into your regular Python code across all the modules. Now it contains codes that you can reuse in several programs. So it's like saying you write once a piece of code like common utility methods, calculation methods, rounding off, addition, subtractions, or some common business rules which can be reused across your project. Then you keep it at one place. Now this helps in such a scenario where you have a large team, different set of developers are working on different modules, different specifications, but one single utility module file .py file will contains all the common and reusable functions which not each and every individual developer can will go and change. It's only few set of administrators or the senior developers can maintain and pass it on to the team. Now, for example, a file containing Python code demo.py will be called as a module, and its module name would be demo. So you need to take care that whatever the name of the file is, that is what will get imported in your Python code. So we will see that with our certain examples on our Jupyter notebook. Now, why do we need to use, as I have reiterated, it provides flexibility to organize the code in a logical way, and it enables reusability, which is the most important factor. So one, of course, you can organize the code, you keep the reusable code at one place, or you can keep a modular approach and also reusable. So not all the developers have to go and rewrite that code, and it is easy to maintain and helps in debugging the code easily. So if you know that there is an error coming, there is an issue coming in one of the modules which is imported or which is lying in the common file, then it becomes easy to debug. You just have to go and check that particular function. You don't need to go and check in each and every piece of code. Now there are two types of Python modules. Definitely there are built-in modules which Python library provides, which you don't need to import explicitly. But there are certain user-defined modules which you create on yourself for your own custom development, for your own custom programming. So built-in modules are predefined modules and are part of the Python standard library. For example, random, datetime, sys. So we will take a look at these examples also. And of course, the user-defined modules, which is the primary objective of this session, where we're going to show you how do you create your own defined modules and then import them. So the user creates the user-defined modules to ease complex tasks in a project. So you program the complex piece of the code in a common module and give it to everyone. You can define your own functions and classes. Now, what are the different ways? There are 5 different ways you can import modules. So you can just say import module name, and all the classes and functions within that module will get imported. You can give an alias. So basically giving an alias makes it simple, and you can refer that alias throughout your code. Then if you want to import anything specific from the entire module, you don't want to import all the functions and classes, then you can just import the specific functions and classes and give their name. Then fourth is from module, you want to import any address as an alias. You can import and give an alias to the specific function name or the class name. And then of course, similar to the first syntax, you can module everything. So first and the last syntax are almost having the same meaning to module to import everything in your module. Okay, so with this background, let's first take a look at the Python file. So what we have done is we have created a module calculations.py. So just please focus on the part where the name of the file is calculations, and in this Python file.py file we have created a couple of functions and the relevant logic related to those functions. So very simple functions like addition, add. You pass two variables and you send the result, add the variables and send it back. Basically we are overriding the Python internal operator add in our Python module, and we will be invoking this one. So we'll show you how to invoke. Then you will have, I have written multiplication, division, remainder. So you pass two variables, divide them and find the remainder. Then now a custom function where I'm adding 10 to both the variables which are being passed to this function and returning the result. Then there is a function which checks whether the number is a prime, and if it is not a prime number you will get this output, and if it is, you will get a prime number. Okay, and then another function which says check anagram. So we will just sort the two strings which we will send and check both are equal or not. If both are equal, then the strings are anagrams, otherwise they are not. So these are the set of functions which we have written. Now we will see how will we use them in our code. Now first syntax which I am writing is import calculations. So this is the name of my .py file which is residing in the same folder where I am writing this piece of code. And now if you see in my .py, I have a variable y whose value is 6. So I'm just using that value and running it and printing it. I'm just going to show you how explicitly I'm invoking the functions in the calculations class in the calculations.py file. Okay, now let's invoke another function remainder passing 140, and then I should get 20 as an output. Okay, so this has gone back and executed this particular function. Now what I'm going to do is another example of my addition. I'm saying calculations.add. I'm going to initialize and pass two variables, and my expected output is 35. Okay, so it has gone and executed this function. Now I'm going to show you another syntax of importing. So from calculations, I'm just importing the add function. So I'll ask for user input to enter for 1 and 2 numbers, and then I'm just going to add it. Two and 5, so I got my output as 7. Now the difference to be noted over here is that in the previous syntax I was making a call like calculations.add, but now I don't need to make a calculations.add syntax invocation. I just need to say import add, and I just need to use the add function. That's all. Now let's use another syntax to import modules. So I'm using import calculations as cal. So all the modules are imported, but the alias uses cal. And similarly, like the previous example, I'm going to take two inputs and print the sum. Now The difference in this syntax and this syntax is I'm using the alias cal dot add, but my output should be same. Okay. Similarly, I can call prime, whether it's not a prime or prime number. I can call the check anagram using the same alias, and I can call the remainder function. Okay. So I hope you have noticed that the difference in importing, the way of importing the module makes a lot of difference, right? Now let's take another example of importing some functions or variables. So I'm going to I'm importing my variable y and functions multi, prime and check anagram explicitly. And I'm going to print y. Okay. And I'm going to multiply two numbers. So if you see, I'm using these aliases over here. Okay. I'm using these variables directly as I've already imported. Now I'm going to say prime 9. Now it's printing none. If you see, it's because of the statements which are not executed, right? So that's why you are seeing. Now let's check anagram. And now another thing to be noted is I'm trying to invoke a function remainder which I have not imported over here. So let's see what error Python throws. Okay, so yeah, so Python has throws an error that name remainder is not defined because I have not imported it over here. So now in order to import remainder, what I'm now doing different is importing all the functions. Now if I use remainder, it should run. Okay, I'm using divide. Okay, cool. Now I'm going to show you another function which is a utility function, directory function, which will show me all the functions, variables as part of the Python file: add 10, check anagram, divide, multi, prime, remainder, y. And of course, these are some inbuilt packages which are already there in the Python file as part of the Python loader. But these are the ones which I have created. So you can actually see the list of all those functions in one go. Okay. Now I'm going to show you an example of inbuilt modules. So this import math is an inbuilt module of Python, and I'm going to show you how you can see all the relevant functions within the math module. All these are the math module functions which are available for you to use. I'm going to show you one or two. So like print math 2 to the power 8 and you get the answer 256. Print math remainder. So I'm not invoking my module function. I'm invoking the math inbuilt library function remainder, and the remainder is 0. 40 divided by 2, remainder is 0. And square root of 81, 9. Then very important, another very interesting utility is of date time, which you can use, and you can print today's date and time. Then another utility is random utility, and I'm going to create a list L1 and write a piece of code which will choose a random element from this list and just print it. Okay, so if first time it has chosen Oppo, again if I run it, it will choose OnePlus. If I again run it, it might choose something else, so it will randomly pick. Okay, so with this we have seen that you can create your own utility functions, import it, write it in a piece of code .py file, import it in your code, as an alias or all the modules and use them, or you can use the Python inbuilt modules, right? Today, let's quickly take a glance. We're going to talk about map function, filter function, and reduce function. We're going to see the syntax which are applicable to these functions and what benefits these functions bring for us during the programming in Python. So we're going to see the syntax and we are going to run certain examples for each of these functions. So let me first just give you a brief of what are the syntax for these functions, what are the signatures, what are the input parameters required, and then we will jump into the Jupyter notebook and run some examples. So what is a map function? The map function takes another function as an input, and the second input is a sequence of iterables. It could be a list, it could be a set, it could be an array or anything you want. And it returns the output after executing the function which you have passed as a parameter on each of the element of that iterable. So the function could add the values, could multiply, could divide, or any mathematical operation you want to do, or even you can perform certain string operations, which we will take a look in the examples. But the idea is that you want to apply the function on each and every iterable item individually. So the map function helps you achieve that. Also in our examples, we will take a look that you don't need to explicitly define a function. You can also use Lambda functions, which are inline functions. So you don't need to increase the line of code. You can reduce the lines of code by just writing the function in line, and that way it will make it more simple. The next function which we are going to talk about is the filter function. Now, what is the purpose? The purpose of the filter function is to reduce the size of the iterables based on the condition which you will pass to the filter function. So syntactically, it is very similar to map function, but the only difference is that you need to pass a function which carries a condition. For example, you have a set of iterables 1, 2, 3, 4, 5, 6, 7, 8, 9, and you want the function to return values which are greater than 5. So your filter function should have a condition which says that the iterables greater than 5 should only be returned by this function. So that's why you have to make sure that a filter function always have a condition which is either true or false. So based on whatever condition matches as true, the filter function will only return those values as an output. So we will take a look. And the same concept applies. Either you can make a explicit function or you can apply Lambda function inline. The third function which we are going to talk about is the reduce function. The only difference between reduce function and the other functions which we talked about, the map and filter, is that reduce function always returns a single value. So it combines all the values in the iterable, your list, your array, your set, and returns a single value. So you can apply the mathematical functions, like for example, you want to add all the values in your iterable, or you want to multiply. So it will multiply sequentially and give you the output. And the same concept applies over here. You can have lambda functions or explicit functions. Also, with one thing which you need to remember is that you need to use function tools module to import the reduce function. So we will take a look at that while we will be running certain examples. Okay, so here we are. So we will start by running our examples. So first we will start with map. So let's start by defining a very simple function which adds two values, right, and returns you the added value, right? So in the next step, we will define a list of iterables. So here we have taken an iterable list of 4 items, 4, 6, 8, 9 numbers. Now in this step we will apply the map function. Now please notice that we are sending two parameters to this map function. One is the function name, which is add, and the list, which is numbers. Okay, now I'll print the out, but it's an object, so right, it's not in a readable format, so I need to convert the out object back to a list. And now I'll be able to print. And here is my expected output. So I had 4 numbers in my list, which is 4, 6, 8, 9, and the map function has added the numbers to itself: 4 plus 4, 6 plus 6, 8 plus 8, 9 plus 9, and so that's how you're getting the output as expected. Now let's take a look at another example. We're going to redefine our list, and we are going to use now a lambda function instead of an explicit function, which is going to multiply the numbers in my list with themselves, and we are going to print my out object, convert it back to a list, and then I'll print my converted list object. And here you go. This is my output: 4 multiplied by 4, 6 multiplied by 6, 8 multiplied by 8, and 9 multiplied by 9. Okay, so here in this example we have seen about lambda function. Now we have been performing mathematical operation. As I mentioned earlier, we can also perform certain string operations. So let's take an example. What I'm doing in this example is I'm creating a map, and I'm just converting all my lowercase strings to uppercase, and I'm just printing my list now after conversion. So such kind of string operations are also possible. Let's take another example where we are going to print the length of each of the string which is there in my list, and I'm using lambda function. And here it is. So now you can see the list, the length of each and every string variable in my list: 3, 5, 6, and 7. Okay, so now these were the examples of map object, map function. Now we will talk about filter. So let's start with a simple example. So as I mentioned, the filter function should always have a condition. So let's create a function which has a condition saying if a is greater than 5, then return a. It means that you need to only return numbers which are greater than 5 in my list. So now I'm going to call this in my filter function. So if you see the syntax here, please notice: filter, you pass the fill and the list, and then you print the out object after converting into the list, and only the numbers which are greater than 5 are printed. Now let's take a look at a lambda function example rather than an explicit function. The same example, but now instead I am using a lambda function, and I'm going to print it. Output should be the same. Okay, so the only change is in the syntax of the function definition. Here we have explicit function, and here we have a lambda function. Output is the same. Now let's take an example of a string operation, string filter. What kind of string filtering we can do? So I have an example over here. So what I'm going to do is I'm going to have a list of string arrays which is going to return me only those strings which have E in them, occurrence of E. Okay. So I've created a function veggies with E, and within this list of veggies, peas, garlic, ginger, beetroot, carrot, I will only get those string variable values which have E in it. Okay, so I've got the result, peas, ginger and beetroot, right? And garlic and carrot have been discarded. Now let's run this similar example with lambda function, where I'm saying that, okay, give me those vegetables which have R in it. So I'm just gonna run this and print my map. Okay, and here is my expected output: garlic, ginger, beetroot and carrot. So what have we noticed is that similar to map filter function, of course, the only difference is the function should have a condition which should return a true or false, and based on that, the iterable list get filters out. Now let's talk about reduce. Now, as I mentioned, the first important thing is that we import the reduce function from function tools, okay, and then we apply a lambda function. So we're going to start off with just taking an example of lambda. So here is my list of 4 elements: 10, 35, 50 and 20, and I'm adding the numbers in this list. Okay, so the map function is not gonna, the reduce function is not gonna add the numbers to itself, but to the subsequent number in the list, right? So what is the expected output, right? The expected output is 10 plus 35 45 plus 50 95 plus 20 115. So what the reduce function has done is it has added the numbers in the list amongst themselves, right, in the orderly fashion. Now let's take another example. Instead of addition, we'll do a multiplication. Okay, so here what we have done is we have multiplied 9 by into 7 into 23 into 4, and we've got this answer. So this is another way of doing it. Now instead of lambda function, I'm just going to show you a simple adding the numbers. I define a function where you add the first and second number, and then you pass the function name to reduce. So custom sum and the list, similar to what we had done for map and filter, and now you can print the result. Now one thing to notice is that this result is a single number. You don't need to convert it back to a list, so you don't need to do that transformation. You just simply print the result, and here it is: 68. 3 plus 4 plus 6 plus 9 plus 34 plus 12. Okay, we are going to start with discussion of need of exception handling. What is exception handling? The types of errors you can handle in exception handling, and how exception handling works, and in the end, certain points to be remembered. And also we will support our slides with a Python Jupyter notebook examples. Now, what is the need for exception handling? Any programming language or any program you write, there is definitely a need in order to have a clean execution of the program, even if the program throws errors. So you need exception handling for cleanly logging the exceptions or throwing meaningful errors to the users. So when does exception occurs, right? Whenever the program gets terminated, right? The program terminates whenever an error occurs, right? So it could happen that an error could be a fatal error and the program gets terminated in between, or there could be a sudden termination which can corrupt the program, right? So you need to handle exceptions, or there might be a data loss because of those exceptions, and you need to take care that that doesn't occur, or the data loss does not happen. Or even if data loss happens, then you pass on a meaningful message, or you capture a meaningful message in the logs at the right point. Now, what is exception handling? An exception is a runtime error that terminates the execution of a program. So basically, whenever an exception occurs, the program gets terminated, you are thrown out of the running program. Exception handling means you generate a message in correspondence to the occurrence of the error and take the right step to handle it. So now an exception has occurred, but you need to handle it. Now, by handling, we mean that you need to throw a meaningful message, as I said earlier, and then you might need to navigate the program into the right direction or take some certain corrective actions in order to handle the error. So all that comes under the exception handling criteria. Now, in general, there are three types of errors: compile time errors, logical errors, and runtime errors. Now, compile time errors are the errors which any programming compiler or Python compiler will show you while you are compiling your program. So, it could be because of the syntax, spacing, indentation, or you are using wrong keywords. All those will get captured at the compile time. Logical errors, you have not used the correct syntax around logical operators like and or your if else conditions are incorrect, and you are expecting an output, but it is not coming as per your expectations. So those are logical errors. And the most difficult ones to capture and track and handle are the runtime errors. So imagine your program is compiled, and as per your expectation, you are expecting an output. You have written a logic, but at the runtime, it does not get executed. It does not run as per your expectation, and the program gets terminated unexpectedly. So the runtime errors are the most critical and important in order to handle them. And if you talk about runtime errors handling in production scenarios, then it becomes very critical that you have handled the exceptions correctly and captured the logs correctly, so that the team can point out where the error has exactly happened. Now, how exception handling works. There are certain syntaxes in Python which you need to follow. Now, you generally put the exception handling code, the code for which you want to handle the exception, under a try block. So you run that piece of code under a try block, and then you put an except keyword where you basically throw an error message. And then if there is no exception, right, then also you can handle the code. Okay, if there is no exception in my code, then how the code will behave, yeah, right? So it could be possible that there is a runtime error, but if there is no, then you might want to do some logical calculations, or you want to put something over there, you can put in the else block. And then finally is a code block which will always get executed irrespective of you had an exception in your code or not. So basically, generally, if you go by the legacy programming, if you have opened a database connection, or if you have opened a file, and it is essential to close those connections from your program, then those close connection code are written generally in the finally block, irrespective of the exception coming. You need to close those connections, otherwise you will run out of your connection pools. Now it's a pretty straightforward flowchart of an exception and handling. You start with the try block, and then if an exception occurs in your code, then it will go to the except block. Otherwise, it will go in the else section. And then finally, you have the finally block where the code will finally get executed and stop. So as I said, you put that piece of code in the finally block, which is mandatory. And generally the block the code which is essential to release the resources which the program has consumed, the CPU resources, the memory resources, hardware resources which the program is using. You have to release that in the finally block. Except block you have to use for capturing the error and throw a meaningful message or do any other logical operation, and else block if you want to continue your program as is. Now, what are the points to remember? These are very important points which you should consider. You can write a try block without any except block. So it's not essential that you put a except block always, or you can write several except blocks for a single try. You might be expecting a null pointer exception or a divide by zero exception or an incorrect variable naming exception. So you can start off with one try, but you can have different except blocks to capture these different kind of exceptions and throw a relevant meaningful error per except block. Also, you can write multiple except blocks to handle multiple exceptions. It's almost the same thing. And you can write exception as an object. You can also print or capture an exception as an object, or you can write multiple exceptions within a tuple. You can capture the multiple exceptions, add it to a tuple and throw it away. Okay, so now let's take a look at certain examples which we want to run in order for better understanding of exception handling. Now, throughout my exercise, I am going to focus on divide by zero error, which we are easily able to simulate. So I'm going to mostly show you how we can capture a divide by zero error. Okay, so I have declared a variable a and I have declared a variable b, a as 10, b as 0. Now I'm trying to divide a by b. Now I'm trying to divide a number with 0. So ideally, yes, this is not a correct mathematical operation. Divide by number 0 is not allowed. So I should get a zero division error. Now this is an unhandled exception. My program has not handled it properly, so that's why you're getting this error on the trace of the Python trace. But if I handle it properly, then I can very cleanly throw this error and capture this error. Okay, so I am going to take input in B, enter A and B, and I'm just going to print a generic except block. So 10, 0, and I have got an exception and I have printed it. Now there is no stack trace, there is no trace, but at least I am able to cleanly throw an error, a meaningful error. Now again, I'm differently going to handle the exception. I'm going to create the same exception, but going to handle it differently. Now there's a try block. Now I am writing an except block to capture the specific exception, zero division error exception. In the earlier code block, I had just written except, so any exception would have come to this block. But in this except block, only zero division error will be captured. So as you can see, I cleanly handled the exception. Of course, I gave the name except zero division error, and then my code got executed later on. Now, in another example, what I'm going to do is I'm going to show you that if my code runs cleanly, then it's not necessary my except block will get executed. Definitely, because if there is no error, then the except block will remain redundant. Now here you see what I have done is I've taken genuine two numbers, divided them, printed a new line and then completed. So as there was no exception, the exception block did not got executed. So the point to be highlighted over here is that it is not essential that exception block will get executed always. It will only come into picture when there is a relevant exception getting generated. Now let's take an example of how we can print an exception object. So I'm going to take my previous code and here I am capturing the exception but also printing the exception object. So what has happened is I have printed the exception of a message, a custom message, plus I have printed the exception object. Okay. Now I'm going to take the same example, but I'm not gonna generate an exception. So my exception block did not got executed and I was able to simply print Simplilearn. Now let's take another example where I am capturing my exception in a variable. So do not divide number by 0, and in this I have captured my exception division by 0. So in the exception, the Python generated exception name is this and I have printed over here. So division by 0 is the Python generated exception which I have appended in the print command. Now I'm going to take another example where I'm saying is that I will print exception as A plus I'm going to also capture another exception. So it's like one try and two exceptions. So one exception is do not divide number by 0 and second exception is name Z is not defined, right? So as I said earlier, you can have one try but two except blocks, which is permissible. Now one thing is that this exception print A by Z went through both the except blocks, except this exception and this exception, though this exception is not divide by 0 error. So therefore in this A variable nothing came in, but in the B variable the name error was definitely captured because it's a name undefined, name Z is not defined error, and that's why you can see that do not divide number by 0. After that we do not have any relevant meaningful message. Okay, now let's take another example where we are going to have two except blocks and out of these two only one will get executed. Okay, so there is no type error exception, so that except block did not got executed, but only 0 division error is there, so only that got printed. Now you can explicitly also raise an exception. It's not like you just have to wait for a runtime exception. You can also raise an exception from your code and execute it. So if you see this, what we have done is just created a variable with a negative value and just checking that if the value is less than 0, then raise an exception. So that's what we have done. Similarly, you can also raise an assertion error. It is called assert, and you can run this message. You can throw this message compatible with Linux only. We will understand what is file handling. We will go through certain file handling operations. Then we will understand how to open a file in Python using various modes, which are pretty important. And then we will discuss the file handling process, the different types of files which we can create, and advantages of using files. Now, what is file handling? A file contains a collection of data and information. It is just like a data storage. So the data can be updated and shared through files with multiple stakeholders. Now, file handling in Python performs functions such as creating, reading, updating, and deleting. So you can perform the basic CRUD operations using the file handling functions and operators. Now in Python, file operation takes place in the following order. In order to work on a file, you have to first open a file. That is the first and foremost step. And then you can perform any read or write operation. And then you have to close the file. So these three primary steps are involved in order to do any operation on a file. Now in Python, we can work with files using the open function, and it takes two parameters, the file name and the mode. So here you can see the syntax. If you do not give the mode parameter, then it takes the default values, which we're going to see in our next slide. But at least you need to give the name of the file with the extension. Now, what are the various modes in which you can perform operations on a file? Let's go through them one by one. You can open a file, first of all, in the read mode, which is the default mode, and it opens a file for reading. But if the file does not exist, it throws an error, right? Second is append A. It opens a file for appending, creates the file if it does not exist. So in this mode, if the file does not exist, it gets created. Similarly, in the write operation, it opens a file for writing and creates the file if it does not exist. So A and W will create the file. X, it creates specified file, returns an error if the file exists. So you cannot create an already existing file, you need to give a different name. Then the next mode is the T mode, the text mode, which is the default value. So by default, when you open a file in Python, you are basically opening it in default read text mode. And the next mode is the binary mode. If you specify B, it means that you're trying to open an image or any binary mode related file, which cannot be opened in a text mode. So we will see certain examples of these modes in our Jupyter notebook when we will run certain examples on a sample file. Now, what is the file handling process, right? So in a plain vanilla process, first, of course, you will create a file and then you will open a file, update and close the file. So the first thing which you can do, but from the function standpoint, like we saw in our previous slide, even if you have to create a file, you have to call the function open, then you have to read it, you write in it, and then you close it. First thing which you have to do in order to interact with the file is always make a call to the open function, and then you pass the file name and the mode as a parameter. Now, as we discussed, there are two modes. There are two types of files in Python, text file and binary file. So in text file, the data is stored in characters and string, and in binary file, the data is stored in the form of bytes. But the bytes file which you can store in a different extension, and it can be read by other utilities or tools or softwares which are meant for reading the binary files. But you can interact or you can perform certain functions using the Python operators and the open functions which are available. Text file, is a simple concept. You open the file, you can write, append, update the data, and you can open the file in your operating system and see your changes. So we are going to perform our examples on a text file where we will show you how you can view your changes by opening a file real time. Now there are some preliminary advantages, basic advantages of using files. This data is stored and is permanent. Basically it resides in the file, and then it is up to you how do you save the data in the file, in the operating system, or you process that data in some secure area, and that is up to you. And the stored data can be shared. Definitely you can mail the data, you can share it in a hard drive, you can share it on a network drive, etc. And you can update the data in the file. So you can append, you can override, you can remove, you can delete the file. All those operations, all those possibilities are there. So now let's create our Jupyter notebook with certain examples. So what I have done here is I have already created certain sample files where I have some predefined context there. So I have a Simplilearn.txt file in which I have written today is Thursday in one line, tomorrow is Friday, and I am waiting for weekend. Now I'm going to read this file. So I'll import the package in order to read the file. I'll create the file object. Now in this I have given the path where my file is residing, today.txt. The same content is there, and I'm going to be opening it in the read mode, though it's the default mode, but I'm calling it out explicitly for a better understanding. Now this is the read command, file.read. This operator, this will read the entire file. So if you see in my file, all the contents are printed. Now if I want to read the first 7 characters of my file, so what will this do? It will read the first 7 characters of the first line of my file. So in the first command, my file.read printed all the contents, but here I have passed a parameter to the read function to print only the first character, 7 characters. So that's what it has done. Now I will ask my function to read line by line. So now what is the difference between this and this? The difference is that the file.read read the entire file in one go, but here it is allowing me to read only one line at a time. Okay. So this function of read line will only go and read the line. Now, if I have to read all lines one by one, right? Now, here I have printed one line. Now I want to print all lines one by one. Then there is a different function which is file.readLines, and it will print an array. And of course you can see there's a /n operator because it's a different line. So it will print my 3 different lines in an array. Today is Thursday, tomorrow is Friday, and I'm waiting for weekend. Now, like I gave this example of file.read 7 characters, in the similar fashion, I can also provide how many characters to read from the line. Correct? So from the first line, it has given me the first 3 characters, and here in the file.read, it was starting to read the entire file, but I only limited to the 7 characters. Now let's take a look at the write function, write method. So now in my today.txt file, I now pass the mode w, and I'll override it with my new content, which is the Sunday and Monday, and say file.close and run it. Now I can go and check it's being overridden. Now I'm going to create a new file. Let me create a new file and add contents to that. I'll create Simplilearn2.txt and run, and a new file has got created with the content sunshine. So here I have passed the mode as X. Now I want to delete a file. I will just simply pass os.remove. There is no open function to be called, and just give the name of the file, and my today.txt file is gone. Even I can put a check before removing a file whether the file exists or not. If it exists, then remove, else print that the file does not exist. There is no file. Now if I want to print line by line, I'll show you another example. If I want to print line by line, then the example is import and file dot in the loop, and you print the output. So basically you can, if you want to print the lines in a loop, then you need to put the for command, for loop, and put the read lines call.
We will discuss what is sorting in Python, what is the importance of sorting. We will discuss different sorting algorithms like bubble sort, insertion sort, merge sort, and quick sort with examples. What is sorting? Sorting refers to arranging available data in a particular format. So typically, when you have data in a non-sorted order, generally there is a requirement in any algorithm where you would require the data to be organized either in ascending or descending order. So if you take an example which is there available on the presentation, here you have a list L1 where you have random numbers which are unsorted, and then you have a sorted array which is in descending order, means highest number first and the lowest later. So generally any algorithm which you implement for sorting provides you a organized sorted list either in descending or ascending order. Now, why is sorting important? Now, you must have seen practically in your day-to-day life, whenever you are navigating through a website or through an application, you generally tend to or you want to see data in a sorted order, either alphabetically or numerically, it makes search faster and easier, right? It becomes easy to search an item when if it is sorted alphabetically. Sorting is also used to represent data in more readable format. So it allows you to read the data which is sorted easily. It helps locate various patterns in the data. So for example, if you have an alphabetically sorted data, then you can easily compare if there is a difference in pattern in the data which is lying in an Excel sheet or which is shared with you in any other data format. Also, and another important point is duplicate values. You can easily find out if there is an occurrence of a duplicate value when the data is provided to you in a sorted fashion. So all the basic utilities, standalone utilities, applications like Microsoft Excel or other utilities provide you basic functionality of sorting of data alphabetically or numerically. Now, Python has a built-in sorting method which is called as sorted, and it gives you a data in ascending order. Whatever input you provide, the list, it will give you data in ascending order. And Python uses a time series sorting algorithm inbuilt to perform this sorting. So let's take a look of the inbuilt sorting algorithm which we are going to show you on my Jupyter notebook. So it's going to be very straightforward. What we are going to do is we're going to create a list and just invoke the list.sort method and print it. And just with one line of function call, our list is sorted in ascending order 12, 15, 27, 33, 62. Now with this inbuilt function, if you want to change the sorting order, right, you want to reverse it in descending order, you just have to pass a parameter saying reverse equal to true and print the list. So if you observe, now you have your output in the descending order. So this is an inbuilt function, the sorted method, but we are here to discuss custom sorting algorithm, and we will start with bubble sort. Now, what is bubble sort? In bubble sort algorithm, the first element is compared with the adjacent element, and if the adjacent element is smaller than the first element, the elements are swapped. Basically, bubble sort is a sorting algorithm that compares two adjacent elements and swaps them until they are not in the intended order. So just like the movement of air bubbles in the water that rise up to the surface, each element of the array move to the end in each iteration. Therefore, it is called a bubble sort. It is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in wrong order. So we have to remember the point that the elements in the array are swapped till the time the intended order is reached and each element has reached to the last iteration. So we will see this with an example. Now here you have a sample list which has unsorted data 9864. Now according to the bubble sort algorithm, what it will do is first it will start from the 0th element and compare it with its next adjacent element 8. Now in this scenario 8 is smaller than 9, so therefore we will swap it. So 8 and 9 will get swapped and now you have 8964. Now again 9 will be compared with its adjacent 6 and now 6 is smaller than 9, it will be swapped. Coming down 9 now compared with 4, 4 is smaller than 9, it will be swapped. So till this point what has happened is 9 has been compared and with each of its adjacent element, and in this iteration now 9 is at its correct place. It's at its last place. Now we don't need to go to this iteration again. We will only go till the second last iteration. So now we will start from the beginning. We will compare 8 with 6. Okay. And 6 is smaller than 8. We will swap. So now your output is 6849. Again, 8 is compared with 4. 4 is smaller than 8. It is swapped. Now we will not go further because now we know 9 is at its correct position. 8 is at its correct position. Now only we need to do one iteration of comparison between 6 and 4. Now 4 is less than 6. We swap, and this is the final output of 4689. So all the iterations depend on the size of the list, but in bubble sort, the whole goal is that you keep it iterating till the time each and every element is compared with its adjacent element. Now let's write a piece of code in Jupyter in order to compare our algo what we have discussed. Okay, so what I'll do is I'll just create a list of elements. Now this is the list which I showed in my example, and I want to sort it. So I'll create a function bubble sort, and I'll capture the length of the array. Now I need two loops. One loop which will run n number of times the length of the array. So I'll create a loop. Okay. And then there will be a second iteration which will run from the first element of the array to the last element. Okay. One less than the last element till the time I have placed my sorted last element in the array. So I'll show you that. Now in my example, I'll print my j iterator and the adjacent element to it. Okay. Now what we have to do is we just have to write now the condition that if the element to which my inner loop is pointing is greater than the next element, then we will swap. Now in Python, there is a very easy way to write the swap code. You are swapping the two adjacent elements with each other. So you just have to write this line. And now this piece of code will place at j position the adjacent element of j plus 1, and at the adjacent element it will put the previous element. Now just to show you, I'll print the array at unsorted and sorted level. So I'll print the array over here and here so that you can easily understand how the array has been sorted. Okay, so now you have a one loop which is running for the number of times the length of the array, and then the inner loop which is running from every time from the first element to the one less element length. Okay, now let me run this. Okay, okay, so now what we have done is, now I'll explain my example. Okay, So what we have done is we have 9864. Okay. Now the length of this array is 1, 2, 3, 4. So the length will be n, will be 4. My outer loop will run from 0 to 4, from 4 times, 1, 2, 3, 4. And now my inner loop j will run 6 times, and I'll show you how. So now first j at 0 and its adjacent element is at 1. So what we are doing is we are comparing 9 with 8, and 8 is smaller than 9. 9 is greater than 8. We are swapping it. So now this is my unsorted array and this is my sorted array. So 9 and 8 are swapped. You have 8, 9, 6, 4. Now I move ahead. J is incremented to 1 and the adjacent element is incremented to 2. So now I am comparing 9 with 6. As 6 is smaller than 9, I swap it. So now my next set or array is 8, 6, 9, 4. Now I go to J2 and adjacent 3. So J9 and 4. I compare 9 and 4. 4 is smaller than 9. I swap it. Now till this iteration, now 9 has reached its correct position. Now I'll go back again and start my iteration from J0 back again and go only till this element 4. So again I am comparing 8 with 6. 6 is smaller, I swap. Then now I am comparing 8 with 4. 4 is smaller, I swap. Now 8 has reached its correct position. Again now I am going back to 0 and will only go to the point of 4. I compare 6 and 4. 4 is smaller and I get my sorted list of 4, 6, 8, 9. Now if you observe, the number of iterations which have happened are 1, 2, 3, 4, 5, 6. It's because 9 has traversed 3 times, 8 has traversed 2 times, and 6 has traversed 1 time. 3 plus 2 plus 1, 6 iterations. So that's how you get those iterations. So this was an example of bubble sort. Now let's take example of insertion sort. Now what is insertion sort? Let's talk about that. Insertion sort places a given element at the right position in a sorted list. So in the beginning, we compare the first two elements and sort them by comparing them. Now let me show you what I mean by insertion sort. Now in insertion sort, whatever list you have, the first element is always considered to be sorted and the rest of the other elements are assumed to be unsorted. So you start your comparison of first element with its adjacent element, right? Now just to simplify things, insertion sort is like playing cards, where like you shuffle the cards and sort your cards, playing cards in your hand. It's just like that. Okay, so the array is virtually split into sorted and unsorted parts. Values from the unsorted parts are picked and placed at the correct position in the sorted part. So now in our example, our sorted part is 8 and unsorted is 4, 6 and 9. Now in the second iteration, we will compare 4 with 8. Now 4 is smaller than 8. We will put it before 8 and now we have sorted list of 4 and 8 and unsorted list of 6 and 9. Now in the next iteration, we will compare 6 with 8. Okay, and if 6 is smaller than 8, we will insert it before 8. And also we will compare 6 with 4, but now 6 is greater than 4, we will not swap it. Now my list is 4, 6, 8, 9 and 4, 6, 8 is sorted and 9 is unsorted. Now again I'll compare 9 with 8 and it's already greater than 8. I don't need to swap it and I'll not go any further and I'll stop it over here. So that's how my sorted list will get created. So my final list is 4, 6, 8, 9 and we'll see that with an example. So now let's create our insertion sort logic. So in my example, I want to create an array 8, 4, 6, 9, 15, 12. And I want to create a function called insertion sort. Okay. Now it's pretty simple. You want to traverse through the entire length of the array, but you want to start from element 1, not from 0, because 8 is your sorted element. You are already considering it your sorted element. Now take a variable in which you capture the outer array, and now I'm putting a while loop with two conditions. One is definitely the one which I explained, that you compare the unsorted element with the sorted element, so the previous element, and you go till the point on the sorted side till the last element. You don't need to go beyond 0, right? You need to only traverse through the first element, which is as the 0th index. And if you then you of course put the swapping code, you swap the unsorted element with the sorted side, and you need to go. So from the right hand side, you are going towards the left hand side of the array, right? From right towards left. So that's why you need to decrease the number. Okay. So what are we doing over here? What we are doing is we are comparing 4 with 8. Now if 8 is greater than 4, you swap, and you only go till the point you have index 0. Okay. Like now if 4 and 8 will get swapped, now 6 will come. 6 will compare itself with 8. It is smaller, it will swap. 6 will compare itself with 4, and it will stop over there. So let me show you. I'll put a print command so that it is easy to understand. So let me print the array over here and see. Okay, so what I've done is I have to print my array. Okay, so this is my original array 8, 4, 6, 9, 15, 12, 11. Now in first time I compare 4 with 8 and swap it. Then I compare 6 with 8. It's smaller, I swap it, but 6, and also compare 6 with 4. I don't swap it. Then I compare 9 with 8. It is not small, I don't swap it, and I stop it over there. Then I compare 12 with 9. It is not small, I stop it over there. Then I compare 11 with 12. It is small, I swap it, right? And then of course 15, I compare with 12, I stop it because it's already bigger. So it is like you divide, you always follow the approach of sorted and unsorted like I presented, and you keep comparing with the unsorted side element with the sorted side element and keep moving towards the left hand side. So now let's discuss another sorting algorithm called merge sort. Now merge sort is a divide and conquer algorithm. So basically in merge sort, you first divide the list into equal parts and then sort the parts and unite them as a sorted list. So basically you split the list into halves and then keep halving them, reducing each half till the time there is a single element in each half, and then you start merging them back in a sorted fashion. So we will discuss this with an example over here. Now for an example, we have our list over here with unsorted numbers 8, 4, 6 and 9. Now as it is even number of items in this list, so they will get distributed into two equal halves. In the left half you have 8 and 4, and in the right half you have 6 and 9. Now again recursively you will split each half, the left half and the right half again, till the time you have single elements. So now you see 8 and 4 now again get split into individual element of 8, 4 and 6 and 9 into 6 and 9. Now you start merging the individual elements in a sorted fashion. So first you will compare 8 and 4. Now 4 is less than 8, so you swap and put 4 first and 8 at the second position. Similarly, when you compare 6 and 9, 9 is greater than 6, then the order of this particular set remains as is. 6 and 9 are taken into the new array. Now you have two merged halves which are in sorted order, 4 and 8 and 6 and 9. Now while merging you compare the leftmost elements of each array. So first you will compare 4 and 6. So 4 and 6, now 6 is greater than 4, you place 4 and 6 at their correct positions. Now you compare now 8 with 9. Now 8 is the leftmost item in the array and 9 is the leftmost item in its own array, and both are in the sorted fashion. So that's why you put 8 and 9 at their relevant position, and this is your sorted output. So definitely we will take a look at the example with our implementation in Jupyter Notebook. Okay, so now let me take my list example which I had shown in the presentation, and I want to perform a merge sort on this list. Okay, so I'll create a function merge sort, and I'll start off with checking that the length of my list is greater than 1. If it is a single element, then I don't need any sorting. Now I'll find the midpoint of my list and take the left part of the array list and the right part of the list. So the convention which I am using is actually automatically taking, means that the list starts from 0 till the midpoint, and the list here will start from midpoint to the length of my list. It's the same convention. So you can keep 0 or not, it's up to you. And the length of my list, I have the /2 means that if the list is of odd number, then it will divide by 2 and round it up to the nearest integer. So you will not get the decimal output. So you will get a integer rounded mid value. Now after I have done this, I will recursively call the left array and the right array into this merge sort. So using this, I'll be able to get the split value of 8, 4, 6, 9, and with this recursions I will reach to the point where I'll get individual elements of 8, 4, 6 and 9. Okay. Now I have to iterate through the left array and the right array. So I'll create two variables which will help me iterate through left and right array, and I am also initializing a variable which I'll keep as a counter for populating a new array which will comprise of my merged list. Okay. So now this is the logic. I will loop from left element from 0th index to the length of the left array and 0th index to the length of the right array.
and I'll compare. If the left is less than equal to the right, it means I already have my value in the sorted order. I'll just add it to my merged array and put it at the kth position and increment my left array further. Else I have to pick up the right array element. So if the left array is smaller and greater than right array, then I put it the left one in the merged list, or if the right one is smaller than the left one, then I put it in the merged list and increment my right list. Now while after this conditions are done, I increment my merged list incrementer. Okay, I move ahead. Now there could be a possibility that there might be some elements which might remain uncompared in the left list. Like for example, if this would have been an odd number of elements, then here would have been 3 and 2, then one element will remain uncompared. So then I need to iterate through the remaining left array and just put them in my merge list and increment I and k by 1. And same could be the possibility of the right array, that there might be some elements which might remain uncompared or unsorted in the right array. So I'll put them back in my merge list. So my list is my list which I am updating constantly. So now let me put some prints. When I'll run this code, I want to put some printouts so that I can explain where my list is. Now this is my merge sort and I'm gonna run this. Okay, so now what I have done, we had a list of 8, 4, 9, 6. So in the first recursion, the list got split into 8 and 4 and 9 and 6. Okay. Now, okay, sorry, let me just make it similar. 8, 4 and 6, 9. Then in the second recursion, I have 8 as a single element, 4 as a single element, and in the third recursion I have 6 as a single element and 9 as a single element. Now after that, this logic gets executed where I compare left and right elements and I merge them. Okay, so now I compare 4 with 8 and 4 is less than 8. I swap it, move 4 to the left common array and then 8. Then in this case 6 and 9, they're already in the sorted fashion. I just move it into my common list, my list. And again now 4, 8 and 6 and 9 are compared. The leftmost element is 4 compared with 6. It's smaller. It is put it in the common list. 8 and 9 are smaller. It is put it in the common list and you have the sorted array. So this is the idea behind a merge sort, where you have divided the list to the nth element, to the 0th element, and then you start merging it back by comparing the leftmost elements. Now let's take an example of another sorting algorithm called quicksort. Quicksort, like merge sort, is also a divide and conquer algorithm, but in a different way. In quicksort, first you choose a pivot element in the array, then store elements less than the pivot in the left subarray and greater than the pivot in the right subarray, and then keep doing this activity recursively for each subsequent left and right array which you have done.
After that, we will call quick sort on the left subarray, and similarly we will call quick sort on the right subarray. So it's a recursive algorithm based on the choice of the pivot element which you have taken on the array. Generally, the pivot element is generally taken as the rightmost element of the array. Now let me try to explain quick sort with an example over here, and then we will look into the Python code. Now I have an array with 6 elements where my last element is my pivot. So now what I have to do is I have to create a left array where all the elements smaller than 34 should get aligned, and then I have to create a right array which should be having elements greater than 34. So in order to achieve that, that is the whole algorithm which you have to write. Now I have taken 2 pointers, the orange colors, and the one on the left hand side and one on the right hand side. This is I and this is J. Now what is the job of I pointer? The job of I pointer is to find the elements which are less than 34, and the J pointer is to find the elements which are greater than 34. Okay, so I will keep on shifting towards the right until and unless it finds an element greater than 34, and in case of J element it will shift towards the left until and unless it finds an element less than 34. Okay, so we will see that. Now I will start its journey from the 0th element always, and J will start its journey from the one element less than the pivot always. Okay, now in this example I is already pointing to a element which is greater than 34, but J is pointing to an element which is greater than 34, but it should move towards the element which is less than 34. So now I will remain static and J will move one element further, which is 17, and it will check whether J is less than 34 or not. If not, then it will stop over here, correct? And I is less than or pivot or not. If not, then it will also stop over here. Okay, so J will check if it is greater than 34 or not, and I will check if it is greater than 34 or not. Now in this scenario, 40 and 17 now are meeting the condition that whether 40 is greater than 34 and 17 is less than 34, we will make a swap of these elements. So 17 will interchange with 40 and 40 will interchange with 17, and then now I and J will continue their journey ahead. What will happen now? I moves to 21, J is at 40. Okay, now 21 is less than 34, I will continue further. It will come to 8. Okay, 8 is also less than 34. I has now moved to 40, right? Now 40 is not less than 34. I will stop over here. Now J, what happened with J? J is greater than 34. It will move further. Now J has reached 8 and I has reached 40. Now at this point, when J has crossed I, then now it is the point when you need to swap the pivots. You need to change the pivot. So at this point, when J has crossed, when J is greater than I, you need to swap the pivots. So in this case, what will happen is 40 will get swapped with 34 and 34 will come in place of 40 and 40 will go to the end. Now with this whole exercise, what has happened now, 34 has found its correct position in this entire array, and if you monitor, all the elements on the left hand side of 34 are smaller to 34 and all the elements on the right hand side are greater than 34.
and this is what we wanted to achieve. Now the same logic will get applied to left array and right array. In left array now 8 will be assumed as the pivot, and in the right array 40 will be taken as the pivot. Now, and applying the same logic, now 8 is taken as the pivot, 17 and 21 I and j are pointing. Now as there are only two elements, 21 is greater than 8, 17 is also greater than 8. So then automatically 21 will move ahead, j will move ahead, and I will move ahead, and then 21 and 17 will swap each other. So the final will become 8, 17, 21. Here we only have one element of 51. Okay, 51 and 40 will swap amongst themselves as pivot, and they will align themselves. So I know it's a little confusing and a complicated algorithm, but I'll try to explain this with my example. Now what I have to do is I have to create my data, and I am creating a quick sort algorithm. Now, in order to start the quick sort, I need to send the 0th index and the length of the array -1. And of course, if the length of left is less than right, means there is some data, then only I'll continue. Now, secondly, what I have to do is I have to find the index of the pivot element and pass it recursively to the quick sort. So now we will create another function which is called partition, which will encapsulate the entire logic. So I'll create my left pointer I, which I was explaining, the right pointer j, which is one less than the rightmost element, which is my pivot, and I'll capture my pivot, which is the rightmost element in our example 34, and then I'll run a while loop for the duration when while I is less than j, right? When j becomes greater than less than I, means when they cross the path, then we will swap the pivot. Now first I will move my left iterator I to the right hand side, right, when it is less than the right, and I'll check my element on the ith index is less than the pivot, because this is my left sub array, and then I'll increment. Similarly, I will move my j iterator from right to left, compare that the element at the j pointer is greater than the pivot. So because I have to create my right subarray. Okay. Now I am checking if my I index is less than j, correct? Then I'll swap the elements, and let me print the array over here. Now outside the while loop, I'll check my array I index is greater than the pivot. Yes. Then I am now changing my pivot, basically pivot value. I'm swapping the pivot value, and I'll print it here for you, and I'll return the I. This is the index of the pivot.
let me indent it correctly and print it. Okay, let's see what has happened. Now this is my original array where the pivot is starting from 34. Now, as I told, my I did not move ahead because I is checking if my element of I is less than pivot, 40 is greater, 40, so I has not moved, but J moved. J moved from started from 51 till 71 till 17 and it stopped over here. And at this point 17 and 40 got swapped. 17 came over here and 40 came over here. Now hereafter I started moving forward. 21 is less than 34, okay. 8 is less than 34, okay. 40 is less than 34, no. So I stopped over here. My J was at 40, it moved further. 8 is greater than 34, no. So I and J have crossed each other. Now this is the point where we have to make a swap between 40 and 34. Okay, so 40 will move to the end and 34 will come in middle. So now 34 has reached its desired and actual position, and all elements left of 34 are smaller than it and right of 34 are greater than it. Now I am working on my left subarray where 8 is my pivot. Now I will start from here. So 17, it is greater than 8, it will not move ahead. 21, it is greater than 8, it moved ahead. J, and it reached 17. Now 17 and 21, now J has crossed I, they will swap each other. Okay. And now my array position is 8, 21, 17, 34, 51, 40. Now my pivot changes to 17. 17 will be compared to 21. And this is the swap happening over here. Now coming to the right subarray, my pivot is 40, only single element is there, 40 and 51, the swap will happen over here. So as you understand, quick sort, you will better understand when you run it with multiple examples.
Video, we are going to perform a really interesting data analysis using Python on the Spotify music streaming service platform dataset. I'll also be asking you a few questions related to Spotify during our discussion. Please make sure to answer them in the comment section of the video. So now let's get started. Spotify is a Swedish audio streaming and media services provider founded in April 2006. It is the world's largest music streaming service provider and has over 381 million monthly active users, which also includes 172 million paid subscribers. The total number of downloads on the Spotify app in the Android store exceeded 1 billion in May 2021. So millions of people listen to music all day. Even I am hooked to music. As an analyst, what's better than exploring and quantifying data about music and drawing valuable insights? Before I move ahead, I have a quiz question for you people. The name Spotify comes from a combination of two words. So which are those two words? Please let us know your thoughts in the comment section below. I would like to repeat the question again. The name Spotify comes from a combination of two words. So what are those two words? We would love to hear from you. So please put your answers in the comment section below. Now let's use Python libraries and functions to analyze and visualize our dataset. First, I'll show you the two datasets that we'll be using. So here is the first dataset that we'll be using for our demo, and then I have my second dataset called Spotify features, which is essentially about the genres of the different soundtracks. Now these datasets have been downloaded from kaggle.com. Now the links to the datasets have been provided in the description box. Please go ahead and download them. Now let me just go ahead and brief you about the columns that are present in our first dataset, which is about tracks. We have our column A, which is ID. This is the unique ID for each of the songs. Then we have the name column, which is essentially the name of the song. Then we have a column for popularity. So the popularity ranges from 0 to 100. Then we have duration in milliseconds. This is the duration of the track in milliseconds. Next, we have a column called explicit. Now we are not bothered about this column because we are not going to use it in our analysis. Then we have artist, so the name of the artist who has composed or sung the song. Then we have ID of the artist. Then we have a column for release date, which is basically the date on which the song was released. Then we have a column for danceability. So this describes how suitable a track is for dancing based on a combination of musical elements such as tempo, rhythm stability, beat, strength, and overall regularity. The value ranges between 0 and 1. Next, we have a column for energy. So the energy is a measure between 0.0 to 1.0 and represents a perceptual measure of intensity and activity. Typically, the energetic tracks feel fast, loud, and noisy. Higher the value, the more energetic is the song. Then we have a column for key. So key is the pitch, notes or scale of song that forms the basis of a song. There are 12 keys ranging from 0 to 11. Moving ahead, we have loudness. So the overall loudness of the track in decibels, it ranges from -60 to 0 decibels. Then we have mode. So songs can be classified as major and minor. 1.0 represents major or 1 represents major and 0 represents minor. Next, we have speechiness. So speechiness recognizes the presence of spoken words in a track. More exclusive speech like the recording, example talk show, audiobook, or poetry, the closer to 1.0 the attribute value. Then we have a column for acousticness. So a confidence measure of 0 to 1 of whether the track is acoustic or not. So 1.0 represents high confidence the track is acoustic. Then we have other information about instrumentalness. Then we also have a column for liveness. So liveness detects the presence of an audience in the recording. Then we have a column for valence. So valence is a measure between 0.0 to 1.0 and describes the musical positiveness conveyed by a track or a song. And finally, we have the columns for tempo and time signature. Now, even in the second data set, we have almost the same columns, just that we have an additional column that is about the genre of the songs present in the data set. Cool. Now let's head over to our Jupyter notebook and we'll start with our analysis. Okay, so one more thing to remember. Our data has information from 1922 onwards. So all the songs from 1922 till 2021. Cool. Okay, so I'm on my Jupyter notebook. So you can see I have a few cells that have already been filled up. So we'll start with our analysis. First of all, let's go ahead and import the necessary libraries. So I'm importing NumPy, Pandas, Matplotlib and Seaborn for my analysis and visualization. I'll hit Shift Enter to import the libraries. Alright. And in the next cell, I'm going to load my dataset using the pandas read_csv function. I have my location already put here. Let me show you the location where the data files or the data sets are located. So this is my location under Chrome downloads. I have a folder called Spotify datasets. Okay, so let's import and check the first 5 rows in the dataset. So for that I have used the head function. There you go. So here you can see I have my first 5 rows of information from the dataset, and on the top you can see the different columns. You have ID, name, popularity, artist, then we have the release date, danceability, energy, key, loudness, liveliness or liveness, valence, tempo and other information. Cool. Now let's check for null values in the dataset. I'll just give a comment as null values. Every time when you download a dataset from an open repository, there are chances that the dataset would contain null values, so it's better to check them beforehand. So I'm going to use the isNull function present in the pandas library. PD I'm using because I had imported pandas as PD. So PD dot isNull. Then I'm going to use the variable name df underscore tracks because I imported my dataset and stored it in the variable df underscore tracks. So I have my data frame under df underscore tracks variable, and then I'll use the sum function to check the total number of null values present in the dataset for each of the columns. If I run it, there you go. So here you can see my name column has 71 missing values or null values, and we don't have any null values for the rest of the columns. Okay. Now let's use the info method that will give us the total number of rows and columns in the dataset, and we'll also check the data types and the memory usage. So I'll say my data frame name, that is df underscore tracks dot info. If I run it, you can see here, now if you mark, there are total 5,86,601 names or the names of the songs present in the dataset, while the rest all have 5,86,672. So clearly there are total 71 song names or soundtracks missing from our dataset. And below you can see the data types. We have float, integer and object, and then you can see the memory usage. Cool. Now before I move ahead with our next analysis, I have another question for you. Which artist or musician has the most number of followers on Spotify? I repeat, which artist or musician has the most number of followers on Spotify? Please put your answers in the comment section below. We would be happy to hear from you. Now let's move ahead and do our first major analysis in this demo. We are going to find the 10 least popular songs present in the Spotify dataset. So I'll create a variable called sorted underscore df that will be equal to my data frame name, that is df underscore tracks dot. I'm going to use the sort underscore values function and say my column name is popularity. So I'm going to sort the values based on the popularity and then say ascending equal to true, since I want only the least popular songs. And then I'm going to say head of 10, which means I want the top 10 least popular songs. Now let's go ahead and print sorted underscore df. If I run it, you can see we have the list of 10 least popular songs on Spotify. You can see that popularity is 0, and you can see the names of the songs. Some of them are songs which are not in English language, and you can see the artist names as well. Cool. Now moving ahead, let's see some descriptive statistics for the numerical variables that are present in our column. So I'll say df underscore tracks dot describe, which is the function to get some descriptive statistics, and I'm going to use the transpose function after that. If I run it, there you go. So we have the statistics about count, mean, standard deviation, minimum value, 25th percentile, 50th percentile, 75th percentile, and the maximum value for these columns like popularity, duration in milliseconds. Then we have energy, key, loudness, mode. Cool. Now if you see this popularity column, the minimum value is 0 and the maximum value is 100, and you can see the 50th percentile is 27, which is essentially the median. You have the standard deviation as 18.37. Then similarly you can check for the other features as well. Cool. Now we'll see the 10 most popular songs which are greater than 90. So we are going to check for the top 10 songs with popularity greater than 90. Let me show you how to do it. So in this cell, I am going to create a new variable called most popular, and I'll say df underscore tracks dot. This time I'm going to use the query function that is part of pandas library again. I'll use the column that is popularity, and we'll set the condition popularity should be greater than 90. I'll give a comma and say in place equal to false, because I don't want to change my original data frame. And then I'll say sort underscore values, and I'm going to sort it based on popularity in descending order. So I'll say ascending equal to false, and then let's take only the top 10 popular songs. So I'll say most popular, use square brackets, and we'll then pass the slicing operator and say :10. Now if I run this, there you go. So here you can see the 10 most popular songs that is present in our Spotify dataset. So first we have Peaches by Justin Bieber, Daniel Caesar and Gibbon. Then we also have a song name called Driver's License, Astronaut in the Ocean, Save Your Tears. We also have The Business, Streets, and Heartbreak Anniversary. So these are the most popular songs that are present in our dataset based on their popularity. You can see Peaches has the highest popularity with 100. Alright, now moving to the next cell. So here we are going to set the index to be release date column in the main data frame. So I am setting my index using the set underscore index function. I have passed in my column name as release date, and I'm saying in place equal to true, which means I want to change it in my original data frame. And then I'm changing the value to date time format, and let's print the head of the dataset. So you can see here we have successfully changed our index. Now here you can see instead of 0, 1, 2, 3 we have the release date column, and the rest of the columns are intact. Cool. Now let's move ahead. So suppose you want to check the artist at the 18th row in our dataset. You can use the index location method for that. Let me show you how to filter only specific rows of information from the dataset. I'll use my data frame df underscore tracks, and using double square brackets I'll say my column name, which is artists, and I'll use the index location method and say, let's say I want to check the artist who is present in the 18th row in my dataset. So I'll use iloc18. If I run it, the artist's name is Victor Boucher. Cool. Now let's move ahead. We are going to convert the duration in milliseconds to just seconds. So if you see our dataset, we have a column called duration in milliseconds. So all our songs are present in milliseconds. Let's convert them into just seconds. So for that, I'm using the Lambda function and dividing the values in milliseconds by 1000 so that they get converted into just seconds. I have used in place equal to true, so I want to change it in my original data frame. Let's run it and do the necessary changes. Alright, now we'll print the head of the dataset just to check the duration column. So I'll say df underscore tracks dot duration dot head. If I run it, there you go. So you can see the values have now been changed to just seconds. Cool. I have the final quiz question for you. Who has the most monthly listeners on Spotify? Please put your answers in the comment section below. We'd be glad to hear from you. Now coming to the next cell. So here we are going to create our first visualization, that is going to be a correlation map. We are going to drop 3 unwanted columns, and those are key, mode and explicit, and then we are going to apply Pearson correlation method. Now I have set my figure size to 14,6, and then we are using the Seaborn heat map function to create our correlation map. I have put the variable that is correlation underscore df. You can see above we had created this, and then I'm setting annotation equal to true. So this will write the data value in each cell. I have set fmt equal to .1g. So this is a string formatting code to use when adding annotations. Then I have set my vmin and vmax. So these are the values to anchor the color map. Otherwise they are inferred from the data and other keyword arguments. CMap here stands for color map. You can just search for SNS CMap. You will get the documentation. So you can choose whichever color palette or the color map you want. Here I have used Inferno, and I have set my line widths and line color. Finally I am giving a title to my correlation map, and I have set the extra labels. Let's go ahead and run this to get our first visualization. If I scroll down, there you go, we have got a nice correlation map. So here on the right side you can see the scale. It ranges from -1 to +1. -1 means the variables have least or negative correlation, while the values which are above 0.0 means that the variables have a positive correlation. Now here you can see there are values like -0.7 for energy and acousticness, which means if the energy is high, the acousticness is really low. Again, for loudness and say speechiness, if the song is loud, the speechiness is low, so there is negative correlation. But if you see for energy and loudness, there is a really high correlation between these two variables. You can see the value is 0.8. So if the song is loud, this implies the song has really high energy, and vice versa. Now if you see for a few other variables, there is negative correlation between acousticness and danceability. There is negative correlation again between valence and acousticness. Similarly, there is positive correlation between energy and valence, which is 0.4, and even for danceability and valence, that is positive correlation, which is 0.5. Cool. So from the correlation heat map, you can note that acousticness appears to have a strong negative correlation with energy. So if you see for acousticness and energy, there is a strong negative correlation, and there is a moderately strong positive relation between loudness and popularity. So if you see for popularity and loudness, the color is orange, which means it lies in this positive region. And there is also a moderately strong positive relation between danceability and valence. So if you check for danceability and valence here, there is a moderately strong positive correlation. Alright, now let's move ahead. We are going to sample our data and take just 0.4% of the total data, and we'll create 2 regression plots using this data. So let me first sample my data. So I'll create a sample data frame using my original data frame, which is df_tracks, and say sample. I'm going to use the int function and say 0.004 multiplied by the length of my original data frame, which is df_tracks. Alright, now let's run this, and we'll print
the length of my sample data frame. If I run it, you can see 0.4% of my total data set is 2346 rows. Cool. Now we are going to create a regression plot between loudness and energy. Now in our correlation map, we saw there was a positive correlation between loudness and energy, which was 0.8. Let's plot it in the form of a regression line. So I'll use plt.figure. I'll set my figure size equal to, let's say, 10,6. I'll say SNS dot regression plot. So I'm using the function called regplot, and I'll use my data as sample underscore tf, give a comma, and say in my y-axis I'll have my column loudness, and in the x-axis we'll have energy. I'll give a color to my data variable. Let's say the color is C. Then I'll set my title to loudness versus energy. Let's say correlation. All right. Let's make sure everything is fine. Now we'll run and see our result. There you go. So you can see here clearly there is a very high positive correlation between loudness and energy. On the y-axis we have loudness, and on the x-axis we have energy, and you can see all the data points or the songs are in one direction. So if the energy increases, the loudness of the song also increases, and similarly if the loudness of the song decreases, your energy of the song or the track also decreases. So there is a very high positive correlation, and you can see the regression line here. It has gone and is increasing gradually. Cool. Now similarly, I'll just copy this code, and we are going to see another regression plot, this time for two different features. Let's say we have popularity in the y-axis. So I'll say popularity, and then in the x-axis we have, let's say, acousticness. I'll change the color to, let's say, B, which stands for blue, and will set the title to popularity versus, I'll have acousticness correlation. Just scroll down and we'll run it to see the result. There you go. So I have the different points for the songs, and here you can see the regression line is downwards, which means if the acousticness of the song increases, the popularity decreases, and similarly if the popularity increases, acousticness decreases. You can see the downward trend of the regression line. Alright. Now in the next cell we are going to create a new column called year from our release date column, and I have changed this to date time format. Let me just run it. Cool. Now after that we are going to create a distribution plot to visualize the total number of songs in each year since 1922 that is available on the Spotify streaming app. So I have used my Seaborn library and dist plot function. Now one thing to remember, you need to update your Seaborn library to this version if you haven't done it. So use this command pip install --user Seaborn and the version. So here in the distribution plot, we are going to plot a histogram. So I have used kind equal to hist, which stands for histogram. Let's run and see the result. Okay, so here you can see I have my distribution plot. So the plot tells us that the number of songs for each year in the dataset according to their release date have increased in the recent years since music became more accessible to people globally with technological advancements. So earlier you can see there were very few songs available in the 1920s. Later on the number of songs increased rapidly, and now you can see we have a lot more songs available for people to listen. Cool. Now we are going to see the duration of songs over the years. For that, again, we are going to create a bar plot. So I'll first create a variable called total duration equal to df underscore tracks dot, I'll use the duration column that we created with seconds, and then I'm going to set my figure dimensions. So I'll use figure underscore dims for dimensions equal to 18,7. After that, I'll have my figure axis defined. So I'll use the matplotlib subplots function, and I'll set the figure size equal to my figure dimensions, and then I'll say figure equal to sns dot, I'll use the bar plot function and say my x-axis to be years, my y-axis will be total duration or total underscore dr that we created here. I'll set my axis equal to ax, and then I'll set error width equal to false. Let's set the title for my plot as title equal to year versus duration, and finally I'll say plt dot xtext, I'll rotate it by, let's say, 90 degrees. Alright, let me just recheck once if everything is fine, and then we'll go ahead and run it. My axis, error width, title. Okay, let me just run it. We'll see the result in a moment. If I scroll down, you can see we have the bar plot for the different years and the duration of the songs in seconds in the y-axis. So earlier in the 1920s, you can see the duration of the songs were less, and later it increased around late 1930s, and this remained consistent until 2010, where the duration was high. But after 2010, you can see the duration of the songs have started decreasing. Now in the next cell, I'm going to create a line plot to analyze the average duration of the songs over the years. It is going to be similar to our bar plot, just that now we are going to visualize it in terms of a line. So I have my code ready. You can see here I've used my Seaborn library and the line plot function. In the x-axis I have years and in the y-axis I have total duration. I've set my title to year versus duration and I'm rotating my x labels by 60 degrees. Let's run it and we'll see the output. There you go. Now if I scroll down, you can see we have a nice line plot, and on the x-axis you have the years and on the y-axis we have the duration. We can see that the songs from 1920s to 1960s have comparatively shorter duration, since most of the songs tended to be more singing based rather than instrument based. After 1960s, you can see the duration of the songs started increasing until I would say 2010, and in the present day the duration of the songs have started declining since the attention span of the average listener is also declining. Alright, now let's move to our second data analysis project, which is based on genres of the songs. So I am importing my dataset using the pandas read_csv function. I have given my location and here I have my dataset name followed by the extension of the type. So this is a CSV dataset. Let's go ahead and run it. Okay, now let's print the first 5 rows of the dataset. I have stored my dataset in a data frame called df_genre. I'll use the head function to get the first 5 rows of information. I'll hit shift enter to run it. There you go. You can see here I have my genre column, artist name, track ID, popularity, acousticness, duration in milliseconds again, and we have the rest of the other columns that we saw in our first dataset. Just one thing to note, here key is present in terms of C, D, E, C minor, F minor, and not in terms of numbers between 0 to 11. Now we'll see the duration of the songs for different genres. For that, I'm going to create a bar plot. So I'll start with setting the title for my plot as duration of the songs in different genres. I'll use the Seaborn library and I'll set my color palette to, let's say, rocket. I'll give a comma and say as CMap equal to true. This would be color palette. Now I'll say SNS dot bar plot. In the y-axis I'll have genre and in the x-axis I'll have my duration column, which is in milliseconds, so duration underscore ms, and then I pass my data frame using the data argument. So I'll say data equal to df dot genre. Next we'll set the x labels, so I'll say plt dot x label. Let's say my x label is duration in milliseconds, and then I'll say plt dot y label as genres. Now let's go ahead and run this. There you go. So here you can see we have the different genres on the y-axis and on the x-axis you have the duration in milliseconds. And if you see the graph for classical genre and for songs that belong to world genre, the duration of the songs are more compared to other genres. Now if you check for children's music genre, the duration is less or the least. Cool. And finally we'll move to our last demo where we'll see the top 5 genres by popularity. So I'll say sns dot set underscore style. I'll set my style to dark grid, which will be my background, and then I'll say plt dot figure. I'll set my figure size to 10,5. Then I'll create a variable called famous, since I want to take only the most popular songs based on the genre. So I have created a variable called famous, and I'll pass my data frame name, that is df underscore genre, and I'll sort the values based on my popularity column. So I'll say popularity, and I want to sort it in descending order. So I'll say ascending equal to false, and I'll take the first 10 values. I'll tell you the reason why I'm taking the first 10 values and not 5. Then I'll say sns dot bar plot, and in the y-axis I'll have genre, in the x-axis we'll have popularity, and I'll give a comma, and using the data argument I'll say my data to be famous, which is this variable that we created, and then I'll set my title as top 5 genres by popularity. Alright, now the reason why I took head of 10 is because there are a few genres which are repetitive. So if you see this, we have children's music appearing twice, so hence we have taken 10 instead of 5. Let me just go ahead and run it. There you go. So here if I scroll down, you can see I have my top 5 genres based on the popularity. So we have dance, pop, rap, hip hop and reggaeton. So these are the 5 genres which are most popular based on the data that we have collected from Spotify. Alright.
Let's dive in and get started with some Python interview questions. Number 1, what is the difference between shallow copy and deep copy? And you can see with shallow copy we have object 1, which has child 1, child 2, child 3, and so on, and object 2, which has child 1, child 2, child 3. A deep copy creates a different object and populates it with the child objects of the original object. Therefore, changes in the original object is not reflected in the copy. Copy.deepCopy creates a deep copy. Shallow copy creates a different object and populates it with the references of the child objects within the original object. Therefore, changes in the original object is reflected in the copy. Copy.copy creates a shallow copy. And you can look at this. If we make a change to child 1, it's only a pointer. So if you make it in object 1 and a change to child 1 in object 1, it will also make that change in object 2. Number 2, how is multi-threading achieved in Python? Oh, this is a good one. With multiprocessing and multi-threading, this question is actually asking you, do you know the difference between multiprocessing and multi-threading and how multi-threading works? Multi-threading usually implies that multiple threads are executed concurrently. The Python global interpreter lock doesn't allow more than one thread to hold the Python interpreter at that particular point of time. So multi-threading in Python is achieved through context switching. It's very different than multi-processing, which actually opens up multiple processes across multiple threads. So multi-threading. Discuss the Django architecture. So the Django architecture, and the first thing to know is that the Django is a web service, way to build your web pages basically. And so when you look at the architecture, you can see here we have a nice model drawn out where the user initiates the Django, which initiates the URL, which initiates the view, what they're going to view, and you have your model and your template. So the model of data, whatever data model you're pulling, goes into the template and then goes back up the pipeline to the user. And the important thing to note is there's a template, the front end of the web page. This is what they're going to see. There's a model, the back end where the data is stored. So you can keep the template and the looks and everything looks the same, but you can swap out the underlying information that goes into that template. Then you have your view, which interacts with the model and template and maps it to the URL, and then the Django serves the page to the user. So your Django grabs it and says, okay, thank you for the URL, and here you go, user. What advantage does NumPy array have over nested list? So NumPy is a module you import. Almost always see NumPy, import NumPy as NP. NumPy is written in C, such that all its complexities are backed into a simple to use module. Lists, on the other hand, are dynamically typed. Therefore, Python must check the data type of each element every time it uses it. This makes NumPy arrays much faster than lists. I would also add in that NumPy has a lot of additional functionality that you don't have in lists. There's a lot of things you can automate in the NumPy. Quick flip over to our Jupyter notebook. Any IDE will work. If you're going to do a set of interview questions, taking a quick look at code is always important. We have our import NumPy as NP. We'll go ahead and import time. Here's our list sub for I in range of 100. And what we're doing is we're going to time it. So we're going to create a list, then we're going to create a NumPy zeros array. And you can see here, look how quick you can create this NumPy zeros array. Here we are appending 1 0 at a time for a regular Python list, and here we are with NumPy. They're all zeros, and they're all of type integer. I believe it's either float or integer on this. I'd have to actually do a type on it. And then, so if we take in and we create a TL1 time equals time, and then we do for I in range of 100, for j in range of 100, L of I, j equals L of ij plus 5. So we're just doing a simple calculation on our array and subarrays. This is an array of arrays. And we'll do the same thing with TL2. TL2 time.time, TL1 equals, so here we have our final time on that. And then we'll do this with an array op, and this is what I really love, a equals a plus 10, and then you can just print it right out. So you can see right here with a NumPy array, we're doing the same thing. If I run this, our time is significantly different. Here we have 0.09 and 0.003. So you can see that the time drops significantly when you're running this on a NumPy array versus a list array. Also important to note, these times aren't going to be, they'll change each time I run it depending on what I have running in the background. So there we go. Number 5, what is pickling and unpickling? Amazes me how many times I pickle and unpickle something. Converting a Python object hierarchy to a byte stream is called pickling. Pickling is also referred to as serialization. Unpickling, converting a byte stream to a Python object hierarchy, is also called unpickling. Unpickling is also referred to as deserialization. So if you just created a neural network model, you can now save that model to your hard drive, pickle it, and then you can unpickle it to bring it back into another software program or to use at a later time. How is memory managed in Python? Number 6. Python has a private heap space where it stores all the objects. The Python memory manager manages various aspects of this heap like sharing, caching, segmentation, and allocation. The user has no control over the heap. Only the Python interpreter has the access. You have a nice little diagram here. Here's your program. There's your interpreter. We have our heap, memory management on the garbage collector going off of there. Number 7. Are arguments in Python passed by value or by reference? Arguments are passed in Python by reference. This means that any change made within a function is reflected on the original object. So you can see here def function of L of 0 equals 3, L equals 1, 2, 3, 4, function L, print L, and you're going to get 3, 2, 3, 4 because we've passed L in there, so it's a pointer. Here we have def function L equals 3, 2, 3, 4, L equals 1, 2, 3, 4, function of L, print L. Because in this function I have assigned, instead of operating on a piece of L, the list, I've assigned a whole new value to that list, or L. It then at that point will create a new object. So if I make changes to the object, it's going to change it in the outside the definition. If I use a variable and I assign it a completely new value, like L equals 3234, that will not show up when you're outside the function. Number 8. How would you generate random numbers in Python? To generate random numbers in Python, you must first import the random module. The random function generates a random float value between 0 and 1. The random range function generates a random number within a given range. And you can see here 1 is the lower end, 10 is the upper end, and step 2. So it would be 1, 3, 5, and so on as far as the options in the random generation. Number 9. What does the double forward slash operator do? In Python, the forward slash operator performs division and returns the quotient in float. For example, 5 over 2 returns 2.5. To do a double forward slash operator, on the other hand, returns the quotient in integer. For example, 5 double slash returns 2. 5 divided by 2 and you drop the 0.5. Number 10. What does the is operator do? The is operator compares the ID of the two objects. And you can see in here where list1 equals brackets around 1, 2, 3, list1 equals list2 equals true. And you have the double equals in Python, of course. And you can do list1 is list2, where list2 equals 1, 2, 3 is false. List2 is not the brackets 1, 2, 3. It equals it, but it's not the brackets. And if we do list3 equals list1, then list1 is list3 equals true. Number 11. What is the purpose of pass statement? The pass statement is used when there's a syntactic but not an operational requirement. For example, the program below prints a string ignoring the spaces. And so here we have variable equals Simplilearn. We've added 2 spaces in it. For I in variable, so it goes through each I. If I equals space, do nothing. Else, print I, and then we'll have the end equals bracket bracket, and they'll print out Simplilearn. Now, of course, you would probably write this if I does not equal blank space, print. But this would be another way you could do that if you need a placeholder for that first logical set or that first area. And you can also do a function like this. You could do function, whatever your def function name, brackets, colon, pass. So it goes into the function and does nothing, but it's a placeholder. Number 12. How will you check all the characters in a string are alphanumeric? Python has an inbuilt method, isAllNumber, which returns true if all characters in the string are alphanumeric. And so you can see here, A, B, C, D, 1, 2, 3, isAllNumber, output equals true. And the second line, A, B, C, D, the @ symbol, 1, 2, 3, the pound symbol, is all num, output equals false. So really you just want to know about is all num, all numerical, alphanumerical. Number 12. How will you check if all characters in a string are alphanumeric? So here we go. If you know isAllNumber, which returns that the characters in the string are alphanumeric, one can also use regex instead. And so we have Boolean RE match. What's important about this is to note your capital A dash to capital Z, A lowercase to dash to Z, 0 to 9 means that that array includes all of those, the way they have it written out. Plus a $sign, and then we have what we're comparing it to, the string we're comparing to, the ABCD 1, 2, 3. And so we can do an RE.match, and if it matches, if all these things, if all the different entities in that array matches the first one, we get an output true, and if not, an output false. Number 13. How will you merge elements in a sequence? Sequence. There are 3 types of sequences in Python. There's lists, tuples, and strings. Python, of course, makes this easy. If we have a list 1 and list 2, and list 1 is square brackets 1, 2, 3, list 2 is 4, 5, and 6, we can simply do list 1 plus list 2. And our output is 1, 2, 3, 4, 5, 6. If we have tuples, your tuple is the curved brackets designates it, and again, just add them together. Same thing with strings. We have Simplilearn, S1 plus S2 equals Simplilearn. Number 14. How will you remove all leading whitespace in a string? Python provides the inbuilt function lstrip to remove all leading access from a string. And you can see here, space python dot lstrip, leading strip, Python. And you can also do strip, which relieves leading and ending. Of course, there's also the ending set. Number 15. How will you replace all occurrences of a substring with a new string? The replace function can be used with strings for replacing a substring with a given string. Syntax: string.replace old, new, count. Replace returns a new string without modifying the original string. Hey John, how are you, John? Question mark. Replace John with capital JOHN 1. And then you can see right here, hey John, how are you? And since we designated with the 1, just says we're only going to replace one of these. 16. What is the difference between del and remove brackets on lists? Del for delete. Del removes all elements of a list within a given range. Syntax: del list start to end. Remove. Remove brackets removes the first occurrence of a particular character. Syntax: list remove element. And we see a nice example over here. If we delete the list 1 to 3, it will delete the first, in this case B 1 2. It doesn't do 3, remember that. 1 2, so we'll delete B and C and you end up with a D. Where if we do remove B from the list and we have an A, B, B, D, it's only going to remove the first B. Number 17. How to display the contents of text file in reverse order. Open the file using the open function. Store the contents of the file into a list. Reverse the contents of the list. Run a for loop to iterate through the list. Number 18. Differential between append and extend. Append adds an element to the end of the list. You can see right here we have a list 1 2 3 4 and we append 4 and we end up with an output 1 2 3 4. And extend adds an element from an interval to the end of the list. And we have here list equals 1 2 3, list.extend 4 5 6. Output is 1 2 3 4 5 6. So if you want to append an array to the end of another array, you want to use the extend. Number 19. What's the output of the below code? Justify your answer. This is a great interview question because these are the kind of things that come up when you're proofing code. Def add to list, value, and list. So we have value in and a list in, or list equals an empty, in this case an empty list. List.append value, return list. List 1 equals add to list 1. List 2 equals add to list 1 2 3, empty bracket. List 3 equals add to list A. And then we want to print them. List 1 equals, and you can see the formatting. We have our placeholder, list 1, list 2, and list 3. So when it prints list 1, we get 1, comma A. And what you want to notice here is that list 1 and list 3 are equal. Why are they equal? Well, when we passed the information to the add to list, we passed value without passing the list equals brackets, without passing a second value. What this means is that list, as we have it, if you don't have a list, it'll start off with empty list, which we append the 1 to. The second one, list 2, we appended a value to an empty list. So it's only going to be 1 2 3. It doesn't matter what the list was before, we've already assigned an empty list. And then list 3, here's the tricky one. We're adding A to the list, but because we didn't designate the list, list is a shared value. In other words, it doesn't reset it. And we end up with list 1 equals list 3, 1, comma A. Default list is created only once during the function and not during its call. Number 20. What is the difference between a list and a tuple? Lists are mutable while tuples are immutable. And you can see an example down here where I have list equals 1 2 3. Square brackets denote it's a list. List of 2 equals 4, and I print it out and I now have 1 2 4. If I do the same thing with the tuple, I get an error, because you can't change the tuple 1 2 3 into 1 2 4. You have to completely reassign tuple to a new value. What is docstring in Python? Docstrings are used in providing documentation to various Python modules, classes, functions, and methods. And so you can see here we have def for a function, add AB, and this is a docstring. We have the triple brackets on there. You can add carriage return in that so that you can go multiple lines. And it says this function adds 2 numbers. And then sum AB returns sum. And so we have down here 2 different ways of accessing this function. Output, accessing docstring method 1, this function adds 2 numbers. Accessing docstring method 2, help on function add in model main. This function adds 2 numbers. And so you can see the code down here has 2 very different end values. The second one is basically a help menu. There's our help menu. Number 22. How do you use print without the new line? The solution to this depends on the Python version you are using. In Python version 2, you can do print hi and then you add a comma afterwards. Print how are you? And you have hi, how are you? In version 3, print hi, comma, end equals, and it'll add a space on the end there. You can put different characters in there, but generally you just want to put a space on the end. Print how are you, and now we get hi, how are you? Number 23, how do you use the split function in Python? The split function splits a string into a number of strings based on a specific delimiter. So we have string, split, delimiter, comma, max, the maximum number of splits. The character based on which the string is to split by default is space. So here we have an example. We have a variable red, blue, green, orange, and we want to split it by commas, and we only want to do the first two. So if we print the list now, you'll find it has red, blue. It only split it the first two times, and then it gets to the third one and just groups them all together, green and orange. If you leave the two off, it'll split the whole thing. Number 24, is Python object-oriented or functional programming? Python follows object-oriented paradigm, and you should really know in depth what they mean by object-oriented paradigm if you're doing any interview for scripting languages. Python allows the creation of objects and its manipulation through specific methods. It supports most of the features of OOPS, which has inheritance on a polymorphism. So you have an object and you can inherit all the traits of that object and then add new traits in or alter some of those traits. That's what object-oriented means. Python follows functional programming paradigm. Functions may be used as first-class object. Python supports Lambda functions, which are characteristic of functional paradigm. So you can set a variable to a function as opposed to setting it to an object. Number 25. Write a function prototype that takes variable number of arguments. Here we have def function name list. So we could have, in this case, whatever the list is, def function. The asterisk denotes, so we're going to take multiple arguments of a variable, and then we can do for I in var, print I. So if you send function of 1, you'll end up with a function 1, 2, 5, 6. It'll actually print those out one at a time. The first one just prints out a 1 because it only sent one variable. The second one will print 1, another line 25, another line 6. Number 26. What is asterisk args and asterisk quargs? Args used in function prototype to accept varying number of arguments. It's an iterable object, def function args. And you can imagine it's just a basic list. So if I add the numbers a comma b or a comma b comma c, it doesn't really matter. It will have that number of objects in it, whatever I send to it. And there's other uses for it, but that's very basic. Quargs, I can actually tell it what I want to send. So used in a function prototype and to accept varying number of keyworded arguments. It's in both are iterable objects, so you can go through them one at a time. And the def function quargs, you can now set like color equals red, units equal 2. So you'll see that, especially in machine learning, there's a lot of they'll have inline equals true, that kind of thing. Number 27. In Python, functions are first-class objects. What do you understand from this? This means I could return a function. It could be one from another function. I could create a function and treat it just like an object. I can assign it to a variable. I can pass them as arguments to other functions. Number 28. What is the output of print name __ name? Justify your answer. The double underscore name double underscore is a special variable that holds the name of the current module. Program execution starts from main or a code with 0 indentation. Thus, double underscore name has a value double underscore main double underscore in the above case. If the file is imported from another module, then double underscore name double underscore holds the name of this module. Number 29. What is a numpy array? And we briefly touched numpy array compared to a list earlier in processing speed. Now let's go ahead and look at some of the more specifics. A numpy array is a grid of values, all of the same type. So if they're either all float, all integer, all string, and is indexed by a tuple of non-negative integers. The number of dimensions is the rank of the array. And the shape of an array is a tuple of integers giving the size of the array along each dimension. Number 30. What is the difference between matrices and arrays? A matrix comes from linear algebra and is a two-dimensional representation of data. It comes with a powerful set of mathematical operations that allow you to manipulate the data in interesting ways. Now, an array is a sequence of objects of similar data type. An array within another array forms a matrix. Like we said here, two-dimensional, so if you have an array of 3 by 4, that would be a matrix. Number 31. How to get indexes of n maximum values in a numpy array. Of course, the first thing to do is to import your NumPy as NP. You don't necessarily have to use NP, but that is the most standard use of NumPy. We create our array equals an np.array of 1, 2, 3, 4, 5. And then if we want to get our indexes of n maximum values in a NumPy array, we can do, one way to do it is to take our array, sort it, then do -n colon. That means we're going to do, once you've sorted it, you can do -n. N would equal then the number of indices, so it's not the actual letter n, colon. And really this is about understanding this notation, that we can sort it, so it goes from lowest to biggest, and then we can get the top values for n indexes. And then we have our final set of brackets with the -1 on there. Number 32. How would you obtain the resulting set from the train set and the test set from below? And let's go ahead and look at the two different variables. We have train set equals an array of 1, 2, 3. Test set equals a NumPy array of arrays. We have 0, 1, 2, 1, 2, 3. What's important here is that, one, it's a NumPy, so that leaves A out, and then we're stuck with three other options, and I'm going to say that D is out, none of these. And let's look at np.concatenate versus np.vstack. Concatenate would put one set after the other, so you would end up with, probably give you an error, because one set is 1, 2, 3, and then we're going to concatenate array 0, 1, 2 and array 1, 2, 3, the array of arrays, onto the end of that. What we really want to do is stack, and by the way, you can actually switch, there's variables you can put into concatenate obviously that can change this, so you could use the concatenate with a lot of fudging around. But really what we're looking for is VStack. V stands for vertical versus the HStack, which is horizontal, and if we do a VStack we can simply do train set comma test set and stack them together. And so we have C, resulting set equals np.vstack train stack test set. Both option A and B would do horizontal stacking, but we would like to have the vertical stacking. Option C does this. Again, you could add the axes in and use the concatenate to stack it the correct way. Number 33. How would you import a decision tree classifier in sklearn? We have sklearn.decisiontree import decision tree classifier. From sklearn ensemble import decision tree classifier. And we look at these and they're all import decision tree classifier. That actually last part happens to be correct, and it's really just a vocabulary knowing where is the decision tree classifier stored, what module is that a part of, and it is of course part of the sklearn.tree. Number C. Number 34. You have uploaded the data set in CSV format on Google Spreadsheet and shared it publicly. How can you access this in Python? What's important here is to know that we can read stuff with pandas. So we don't show it here, but you can, there's actually a number of ways to do this. What's important here is to know a couple things. One, we have our link generated from the Google Docs and spreadsheets, and then we can do a string.io request get link.content. So there's our source. And then finally, we know that pandas can read a CSV. There's obviously many ways to read a CSV, but data equals pd.read_CSV source. Number 35. What is the difference between the two data series given below? Below we have df name and df location, colon, comma, brackets around, asterisks around name, comma, where. And then we have df equals pd data frame, AABBXXUU, comma, 21, 16, 50, 33, columns equal name and age. So let's take a look and see what they're looking at. We have, just glancing at the questions, they want to know, is it the original data frame or is it the copy of the data frame? And you can see here that 1 is view of the original data frame and 2 is a copy of the original data frame. 2 is a view of the original data frame and 1 is a copy of the original data frame. Both are copies, both are views. And if you're working with pandas, you know that unless you specifically in certain things tell it to do it inline, and a lot of functions don't allow you, that you're always taking a slice and it is always a copy. So C, both are copies of the original data frame. Number 36, you get the following error while trying to read a file, temp.csv using pandas. Which of the following could correct it? So here's our error, trace back most recent call last, file input, line 1 in module, Unicode, in encode error. ASCII codecs can't encode character. Ooh, I hate it when that one comes up. And we have 4 different entries. We'll go ahead and just pretend that D doesn't exist unless we really can't fit it into one of the other answers. And the first one is PD read CSV has our file compression equals gzip. Well, gzip is just an unzipping, and you actually get a zip error on there. The second one is dialect equals string. Again, not an encoding or coding setup. And then we have encoding equals UTF-8. Well, that would be the encoding error, switching it from the character code. There's UTF-8, there is Unicode. That's the most common two that it goes between. So really this is about understanding the difference between a UTF-8 coding and a Unicode, and the error that comes up quite regularly with that. Number C, encoding should be UTF-8. Number 37, how to set a line width in a plot given below. So looking at this, we have import matplot library, pyplot as PLT, and you should know your way around this, how to do a plot in there. plt.plot 1 2 3 4 plot equals show. And so this is a little bit of a vocabulary test. The vocabulary is it width equals 3, line width equals 3, LW equals 3, or something else. And the vocabulary word that we're looking for is LW equals 3, which stands for line width in pyplot library, pyplot. Number 38, how would you reset the index of a data frame to a given list? So this is a vocabulary challenge in understanding what reindexing is. Reindexing, as we have the different values here, we have the first one, which is reset the index. Well, we're not really resetting the index. Reindex number B means we are double checking our indexes to the column and to the main index, and so the values match correctly. Where reindex like now brings in a new index outside of our data frame to a given list. So this is coming from external, and thus the vocabulary word like is our key word, that it's external, and we have a data frame to a given list. Number 39, how can you copy objects in Python? The functions used to copy objects in Python, we have copy for shallow copying, and copy deep copying for deep copy. Number 40, what is the difference between range and xrange functions in Python? Well, this is a good one. We have matrices and arrays. With a matrix, the range returns a Python list object. Xrange returns an xrange object. And with arrays, an xrange returns an xrange object. Xrange creates values as you need them through yielding. The key here is that xrange returns the values as you need them. So it actually processes it post, like if you have for x or for a variable in xrange, it is processing them as you need them, 0 to 9. It doesn't create an array 0 to 9, it just hands you 0, then 1, 2, 3, 4, 1 at a time. Number 41, how can you check whether a pandas data frame is empty or not? The attribute df.empty is used to check whether a pandas data frame is empty or not. And so you can simply create we have down here import our pandas as PD. We create our pandas data frame equal to an empty array, and is df.empty comes out as true. One of the catches you got to remember with these vocabularies is with empty along with some other pandas setup, whether you need the brackets or not at the end. Number 42, write the code to sort an array in NumPy by the n-1th column. This can be achieved using argsort function. Let us take an array x, then to sort the n-1th column, the code will be x to colon n-2.args_sort. So let's see what that code looks like. We import numpy as np. We'll create our array, our numpy array, which is 1, 2, 3, 0, 5, 2, 2, 3, 4. So we have 3 different entities with 3 different columns in there. And we go x of x, and so we take x of all the rows, first entity, or in this case it's actually the second one because it's 0, 1, 2, .argsort. So that would be the second entity, or -2 would also be the same. You could also do, instead of 1, you could also do -2 there instead of the 1. Argsort, and then we get an output of the array 1, 2, 3, 0, 5, 2, 2, 3, 4. Number 43, how to create a series from a list, numpy array, and dictionary. So we'll go ahead and import our numpy, our pandas, and have my list. And you can see here we have my list equals list of A, B, C, D, E, F, G all the way through. So my list now makes a list of that. for array, we have np.arange to 26. My dictionary will create a dictionary with zip my list, my arguments. So I'll just use the numpy array we just created with my array to go into the dictionary. And the solution is simple with the pd.series my list, pd.series my array, pd.series my dictionary. So it's all about knowing the dot, capital S-E-R-I-E-S. Don't forget that capitalization. Number 44. How to get the items not common to both Series A and Series B. And you can see here we have, instead of Series A and B, we have Series 1 and 2, and we have 1, 2, 3, 4, 5, 4, 5, 6, 7, 8. The solution is we take a panda series, we have a series U equals a panda series, NP union one dimension, series 1, series 2. So we can now make a union of them. We now have series 1 panda series with an intersection, and then we can remove one from the other. Series U is series U dot is in series 1. So if the union is not in the intersection, then you know it's a unique value. A little bit of logic going on there and playing with 3 different terms to get the answer we want. 45. How to keep only the top 2 most frequent values as it is and replace everything else as other in a series. So again, we're working with pandas, because if you're talking series and data frames, that means we're working with pandas. So we're going to import pandas as PD. We'll go ahead and create our panda series. We're going to do that by creating a numpy random state, 100, so 100 in the numpy one. And then we have our panda series. You can see here we're random integer, numpy random integer, 1, 5 by 12. And so the solution for this is we go ahead and we've created a PD dot, remember the capital S series solution. We're going to print the top 2 frequencies, and that is our series dot value counts. And then we take series values count dot index of up to 2. So we're going to take everything up to 2. And then we'll do the series is in. So if it's not in the first 2, then it's going to equal other. And this would be something you'd want to write down on paper. If it looks confusing, take a moment, pause the video, write this down, and see if you can figure out how the logic came together and try to throw yourself a couple other little logic puzzles like this. Number 46. How to find the positions of numbers that are multiples of 3 from a series. And in here we're actually going to use a numpy to solve it. The first part, series, lets you know it's going to be a panda series. And if we come down here, we have np.argwhere, so this is a vocabulary question. Series with, remember the percentile 3 is a remainder, so if the remainder equals 0, then we're going to generate that string where the object divided by 3 equals 0 has no remainder, so then we know it's a multiple of 3. Number 47. How to compute the Euclidean distance between 2 series. And this one's really cool because we have our panda series, P and Q. And what I like about this one is they give us 2 solutions you can go with. And really you should kind of know both. The first one would be, yes, you know what the Euclidean distance is. And that is we can take the first series minus the second series squared. And then sum them up, and then we do the square root, which is the same as taking the power to 0.5. Doing the power to 0.5 is easier than doing the square root. So a lot of times you'll see that as a switch, but you could have also done the square root and used the math in there. So there's solution 1, you should know your Euclidean distance. And then solution 2 is the numpy solution. So we have np.linalg.norm. That's how we're going to compute our Euclidean distance. P minus Q. Very elegant and very straightforward and easy to compute. Number 48. How to reverse the rows of data frame. So here we have our data frame. We're going to create a numpy array by 25, reshape it 5 minus 1. And this creates a 25 by 25 data frame. And so our solution is to do the dfi location. And this is just understanding how steps work. The steps, you have your colon minus 1. So we're taking all the rows, all the columns minus 1. So we're stepping minus 1 going the reverse direction. And then we're just going to use across all the different columns on there. Let me say that again. The first colon is going to be your rows. Starting row, stopping row, step minus 1. That's all this is about, is that step minus 1, comma, and then all the columns. 49. If you split your data into train test splits, is it possible to overfit your model? And the answer is yes, is definitely possible. One common beginner mistake is retuning a model or training new models with different parameters after seeing its performance on the test set. My favorite example of this is you have your script put together and you keep hitting the rerun button until you get the answer you want, not taking the answer it first gave you, or running it over an array and recording all the answers to see how they vary. Number 50. Which Python library is built on top of Matplot library and pandas to ease data plotting? The answer to this is Seaborn. Seaborn is a data visualization library in Python that provides a high-level interface for drawing statistical information informative graphs.
And that calls for a wrap. Hope the session was interesting and helpful. If you have any questions or need the resources like PPT or project source codes, feel free to reach us in the comment section below along with your mail addresses, and our team experts would happily revert to you with your queries and concerns. Stay safe and keep learning. Thank you. Until next time.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.